Let's go ahead and get a project set up. So you are going to need a repo of your own. For me, I'm just going to use github.com/calebtolling/git-essentials. And what I'm going to do is I'm just going to clone this down to my computer. So I go git clone and then that SSH URL. Or you can use the HTTPS URL if you don't have an SSH key on GitHub yet. You probably don't if you're just taking this course for the first time, and that's okay. If you don't have an SSH key on GitHub, you can always use the HTTPS URL, but remember, use your own repo. Don't use my repo, not yet anyways. We'll get to that at some point, but make sure you use your own repo. So you might need to create one from scratch if you don't have a repo already. And that's something we covered pretty in depth in Git and GitHub 101. Next, let's just cd into that folder and let's open this up in VS Code. All right, how do we check out previous commits? Well, first of all, let's go ahead and use the terminal in VS Code. And I can do git status. I can do git log -- one line and shows me my git log. We have tags and stuff in here. This is just a repo that is from another Git course of mine. And let's say we want to go back in time and we want to see what happened exactly here when we said updated README. What happened? Well, let's go ahead and open up this README right now. And let's see what we have in here. We've got all sorts of stuff contributing, all sorts of good stuff. Let's say we wanted to go back to this particular point in time. So git log -- one line, and let's just update that README. Or let's go back to this particular point in time, whenever this was. We don't know when that was. So what I want to do is I want to copy this commit hash, this E19519F, and I want to type git checkout and then just paste that hash in there. And you can see that some of my stuff has changed on the left there. Let's go ahead and do git log -- one line. And you're going to see that head is now at updated README. And this README, there wasn't very much in it at that point in time. So we've now actually changed where our code is. Not our code, but where our Git is pointing to. And so let's say this was exactly 2 months ago. We just went back in time 2 months and we could see exactly all the code that existed from this commit up until this point in time. Now here's the thing is whenever you go back in time with git checkout, you always have to make sure that you end up going back to your main or master branch. And so if I do git branch, you can see that head is detached at E19519F. And you don't want to be detached for too long. And you especially don't want to be working in detached mode. It's really good for looking around. But it's not that great for actually doing work. Actually, it's going to cause you a lot of problems if you try to work and then make a commit at this point in time. So what we need to do is we need to go back to our branch called master. Or if you're using a newer version of Git or GitHub, it's often called main. So you do git checkout master or git checkout main, one of the two. Really depends on how old your repository is. And so all we had to do there was git checkout and then some sort of hash. And we just took the first 7 or 8 characters of a hash. So we could do git log -- one line. And let's go ahead and grab sample rebase. And we could do git checkout and then whatever that hash is, git log -- one line. You can see my files changed on the left there. And head is now at sample rebase. And if I do git branch, I'm in detached mode. So git checkout master git branch shows me I'm back on an actual branch. You always want to be working on an actual branch. All right, let's talk about what issues are. So issues is when you go into GitHub or GitLab or Bitbucket, there's usually some sort of tab that says issues. And an issue is used for filing a lot of different things. Possibly a bug would be a good first way to open an issue. But really it's a way to communicate with the maintainers of a project about what needs to happen or what should happen. And so an issue is, for instance, let's say we had a typo somewhere. I don't think we do, but let's say we had a typo somewhere in here. What we could do is we could open up an issue, and we could say new issue, and change a typo in your readme.md. And let's just say this is a sample issue. Now, this takes Markdown. Markdown is supported. So if you want to, you can go ahead and learn some Markdown. Title. This is a block quote. And this is a sample issue with a link to HTTPS. And then let's just go to my website, caleb.io. Preview. Title. This is a block quote. And this is a link to caleb.io. And so I can submit this new issue. And you can see that issues went from 5 to 6 up here. And so let's click back on issues, and there's a new one in here. Now, an issue is literally just text. It's not code. There's no code associated with it. It's just text. And so you can have a whole conversation in here. There could be someone stating that there's a bug, and there could be a conversation in here about, oh, it's not actually a bug. It's purposely designed that way. Or, yes, maybe it is a bug. How should we maybe go about solving this? In this issue, you can have assignees. So I'm going to assign myself to this issue. And so that basically means I'm the owner of this issue. There are different labels you can add. So for instance, you could say that there's a bug. You could add documentation because it's the README that we're assuming has a typo. It actually doesn't, not as far as I know anyways. And let's say it's a good first issue and help wanted. And so that adds all those labels in there. Projects, if we have a project, we can add a project in there. Milestones, same thing. This is for more like agile project management. We're not going to get into that right now. Linked pull requests. We can link a pull request if we wanted to, but we don't currently have a pull request associated with this yet. We have other pull requests for sure, but we don't have a pull request associated specifically with this issue. And so again, the idea here is that when someone hops on a repository, they can go over to the issues and they can see that there's an issue of some kind in there. Now, what's really nice is if you ever run into a coding problem in your issues, you could just type in what the problem is. So let's say I had a typo in a Python package and it was preventing it from working with Django. I could just click into it and I could read through it, and maybe someone else has already experienced that same issue and has a solution. That's the power of an issue. Now, an issue usually is going to be associated with a pull request. So at some point in time, we're going to open up a pull request and it's going to be tagged. It's going to tag this particular issue, issue number 36, issue number 36. What are branches? So branches, well, everything in Git is really a branch. So even on master or main, it's still a branch. It just happens to be the main one that we use. A branch is basically a copy, a full-blown carbon copy of all of your code from your master branch or your main branch, and it's just a couple of changes in it. And so what we can do is, let's not open that, let's open this, and let's create a new branch. So first of all, let's do git branch, make sure we're on master, and then we can do git checkout -b, and then our new branch name. So 2021 new branch name. And if I do git branch again, new branch name. Now let's go ahead and add a new file in here. And let's just close this README. I don't want to save that. New file.txt. And actually, let's call that something better. Let's call it new file from 2021 branch. And let's just say this is a new file from the 2021 branch. Now we did get checkout -b, so what that does is it creates a new branch for us and it checked it out. And so when we do git branch, we're no longer on master, we're on this new branch. GitHub currently doesn't know about this branch though. So what we need to do is git status, git add our new file from 2021 branch. You notice that I used quotations around that just to encapsulate those spaces in there, just to capture those spaces. Git status, git commit, new branch, comment, new branch, commit, not comment. And then I want to do git push origin, and then whatever this branch is called. So 2021, I hit tab for auto completion. And what we're going to see as soon as this is done is I can create a pull request if I wanted to. GitHub is now letting me do that. But more importantly, if I go in here, I can click view all branches. And there is a new branch in here called 2021 new branch name. And so we can actually go ahead and see this entire branch. And in this branch, we have new file from 2021 branch.txt in here. And if you look at our URL, we're in github.com/ the username / the repo name, blob, then the branch. Oh, what did I do there? And then the branch, and then the file name. Whereas if I go back to the original source code here, and I change my branch back to master or main, it depends on how old your repository is, you're going to see that that file doesn't exist in here. And so it only exists in a branch. And so the nice thing about a branch is you don't have to touch your master or your main source of code. What you can do is you can create a new branch with git checkout -b and then your branch name, so -b branch name. And that's going to create a new branch and switch to that branch for you. And then you can do all sorts of work in there. And at some point in time, you can then ask Git or GitHub to open a pull request to merge in your new branch into your masterwork, which is what we're going to do in the next lesson. But before we do that, there's one thing we need to do. One more thing we need to do. Git branch. We need to be able to get back to master. So if we ever wanted to get back to master, we could do git checkout master. And you can see this file is actually deleted. And watch when I do git checkout 2021 new branch name. On the left, that new file is going to show up. And boom, it exists only in this branch, but it does not exist in master. So if I do git checkout master, it's not going to exist. Just like that. So branch is a carbon copy of basically your master work. And you can do whatever you want to it without affecting the main source code, which is really good when you're working with multiple people. Next up, let's talk about pull requests. All right, let's talk about pull requests. So a pull request is basically a way for you to ask the maintainer of a repository to merge in some of your code into their work. And so by doing that, you would become a contributor. And the idea here is that you simply have, for instance, a pull request, or a PR for short. And then you have different commits in here. So a pull request could have multiple commits. Usually it comes from a different branch or another repository. This one's coming from another repository. It's been forked. We'll talk about forking in the future. And the branch is master. And this person wants to merge their work into my master branch. And so I can see what they did here. I can see what files they changed. So it says not an empty file.md. This is not an empty file. This is not an empty file. And they said D. Kravitz, Sci-5, replaced the lorem ipsum that used to be here with a message for the exercise at the end of lecture 33 for the Git Essentials course, which is not this one. This is Git and GitHub 201. And so the idea here is that I can then review these changes and I can say, yep, this was good. I can approve these changes. And that doesn't actually do anything yet. That just approved it. And then what I could do is I can merge this pull request, or I can squash and merge or rebase and merge. Typically, we just we merge the pull request. We do a normal merge instead of a rebase. And all I have to do is press this button and it's going to go into my master branch. Now, I don't want to do that yet because I want my master branch to be a little cleaner. Not that there's anything wrong with this pull request whatsoever. In fact, this is a nice clean pull request. What else can we talk about? In PRs, a pull request, there's also a comment. So you can open up a new pull request. For instance, let's go ahead and open up a new pull request. Let's not click that button. That button was kind of cheating. Compare. I'm going to compare my 2021 new branch name. That's from the last lesson. And I want to put it into master. And you can see that there's one commit in here. And there's only one file that's being changed. So I can go ahead and create this pull request. And new branch commit, let's say this is a new PR test. Just testing a PR to match the issue of issue number 36. and I just do $36, and that creates a link and a nice little pop-up there. And so I can go ahead and I can create this pull request, or I can add a reviewer. Can we add anyone in there? No, because I'm the owner of this repository, so I can't add myself as a reviewer. Assignee, I could set myself. Labels, let's say there's bug, duplicate, help wanted. We could add project, milestone, and a linked issue. Let's go ahead and create this new pull request. And so all this is going to do is open up a brand new pull request, which we can see up here. It went from 25 to 26, and this is a new pull request. And then someone can come in here, they can review it, they can approve it. You can't approve your own pull requests though. And that's just for, basically it's for security. So if I write some code, I want someone else to be able to review it to make sure that I don't have any flaws in my logic. And then I can merge this pull request in by hitting this button, which I'm not going to do because I want to keep this repo nice and clean, but that's all I have to do, and it goes into my master branch. Now, typically we create a pull request using a new branch. So I can't create a pull request from master going into master, because if I do git push origin master, it's just going to update my master branch. So I need to git push origin 2021 new branch name, and that's going to create a new branch for me. And that allows me to create this new pull request. Keep this in mind, because down the road, I'm going to want you to not only create a copy of I guess this repository, but I'm going to want you to create a pull request to put some code into this repository as well. We'll talk about that down the road. You don't have to worry about doing that right now though. Okay, let's talk about forking. So forking, and you can see over here, there's 37 forks on this repository right now, forked by all these people. And what forking does is it will take my entire project here and it will copy it line by line into your account. And so let's go ahead and coding for everybody. We're going to go to github.com/coding for everybody. And let's take these 7 days of Wagtail. And let's make sure I don't already have this forked. Nope, neither of those are me. So what I can do is I'm going to go back and I'm just going to click this fork button, and I can fork this into any other organization or my own personal account. I'm going to select my own personal account. And so this is just going to take a quick second, and this is going to fork it over. And so you can see up here, it's now in my account. There's 7 days of Wagtail, forked from coding for everybody /7 days of Wagtail. And so what I can do is I can now clone this onto my computer, and I can actually modify all this code any way I like. I wouldn't be able to do that with anybody else's code. If you had a repository in your account, I can't clone your project, make changes, and push it back up, because it's not in my GitHub account. But what I can do is fork it, so there's a copy of it in my GitHub account, then I can clone it down, and I can make all the changes I want to it. So let's do this. Let's cd up a directory, and let's do git clone, and I'm going to paste that link in there. cd 7 days of Wagtail, ls-la, or if you're on Windows, dir. And let's go ahead and open this up in VS Code. And what I'm going to do is I'm going to open up the terminal in here too, so I don't have to flip between two different programs. And what I want to do here is git branch. And this is a very modern workflow that we're going to be working with here. So I'm currently on master. If I do git remote, I think it's capital V. Git remote lowercase v. There we go. Let's try that once more. Git remote lowercase v. The origin is pointing at github.com/calebtallien/7 days of Wagtail.git. Even though this is forked from coding for everybody, I have a copy of this from my personal account on my computer now. And so let's go ahead and create a new branch, git checkout-b, new branch demo. So git branch just to make sure I'm on that branch. And let's go ahead and let's just overwrite the README. Overwritten by Caleb the Hacksaw. So now that I'm on this different branch, what I can do is I can say git status, git diff, readme, and that's just going to show me that I deleted all of this stuff. Go all the way down, just hitting the down arrow. And I added one line, overwritten by Caleb the Hacksaw. Git status, git add, readme. git status once more, git commit, and let's commit this to our branch called new branch demo. Hacksorted. And it's git push origin new branch demo. Now, let's go ahead and take a look at what this looks like. So if I go back here and just quickly refresh, I'm on /CalebTallien/7 days of Wagtail on GitHub. If I go in here, I can see new branch demo. If I go to where this was forked from, the original repository, the coding for everybody /7 days of Wagtail, that branch doesn't exist. It only exists in my personal account. And so what I can do now is I can open up a pull request from my forked version here. So let's go ahead and compare and pull request. And so it looks a little bit different this time. What I can say is the base repository, the one that I want to merge code into, is going to be this repository or any other fork of that repository. I'm going to select the original one. Which branch do I want to select? Just the master branch. It's the only branch that's in there. My head repository is going to be my account / my repo. Where do I want to merge into or merge from rather? So I did all my work in CalebTallien /7 days of Wagtail. And I want to merge in my new branch demo into 7 days of Wagtail. The coding for everybody one, not my own, but the coding for everybody one. And so let's go ahead and first of all, let's go into pull requests. We're going to see that there are no pull requests in there. Let's go ahead and create a pull request. And we'll just refresh, and we can see that there is a pull request in there from one organization or one individual to another organization. And I can go in here, click it, see what changed, and you know what? I don't like that. So what I'm going to do, pull request authors can't approve their own pull request. Oh, that's too bad. I was hoping that we could get away with that because one is in an organization called Coding for Everybody and the other one is a personal account. But that's not going to work. What I can do though is I can either merge this in, which I don't want to do, or I can close this pull request. I can also assign reviewers, assignees, labels, all sorts of stuff. I'm going to go ahead and just close this pull request. And it says close with unmerged commits. And what I can do now is I can delete this branch. And so I'm going to go ahead and delete that branch. And if I go back to my version of this particular repo, my forked version, my branch was deleted. I just had to refresh the page there just to make sure that that worked properly. Okay, so I have this forked repository here and I want to delete it. So I'm just going to go into my settings, scroll all the way down and go delete this repository. And it's going to make you basically copy and paste this or type it out by hand. I'm just going to copy and paste that in there. And that's just going to confirm that I'm going to delete it from CalebTallien /7 days of Wagtail and not the Coding for Everybody organization /7 days of Wagtail. So this just confirms that you're deleting the right repository and not the wrong one. And so let's click, I understand the consequences. Delete this repository. And repository deleted. Simple as that. All right, let's talk about gists. So what is a gist? A gist is a little piece of code or a few files that you can share with someone. And so let's go and click this little plus up here and say new gist. And this is going to bring us to gist.github.com. And we can add a description. And it's a lot like a repository, but a lot smaller. It's a lot more mini. And the idea is it's just code that you want to share and maybe embed on a website. And so let's type my first gist. And this is really good for sharing large chunks of code with people, especially if you're talking with coworkers on Slack or something. You can always just write a gist. You can copy and paste a bunch of your code in here, and then you can just send them the link instead of just spamming them all sorts of text on Slack. So let's go hello world.py. That's what we're going to call this, hello world.py. And this is simply going to be a Python file that says print hello world with a heart. I'm going to create a either secret gist or a public gist. I'm going to make sure that this is public. There is a difference though. So when we create a secret gists are hidden by search engines, but visible to anyone that you give the URL to. And a public gist is a public gist that's, it's available to everybody. So yeah, maybe let's go ahead and make this a secret gist. because this is not a valuable thing that I don't really want to contribute this to the whole world. We can make that a secret gist. We can add a second file in here, or we can delete that file, but we have to have a minimum of one file. We can dictate the number of spaces, if it's going to be used spaces or tabs, indenting size, if we're going to wrap or have soft wrapping, or no wrapping or soft wrapping. And let's go ahead and just create this secret gist. And so the idea here is that I now have this link, and I can copy and paste this link to you, and it's just a long hash. It's nothing fancy. It doesn't have a slug or anything. And I could just copy that and paste that link to you, and you could see this code. And then you could either embed it in your website, or you can download this entire thing as a zip. Now what's cool about this is it also comes with revision, so it has basically Git power behind it. So let's go ahead and edit this once more, hello world, and let's do print. This is a second revision. Update secret gist. And we have two revisions in here. We have the first one and we have the second one. And so now we have the power of Git behind it as well. And again, at any point in time, you can just embed that code. You could save it to your computer if you want to use the GitHub program. I don't personally use the GitHub program itself. Or you can download the zip. You could delete it. You could unsubscribe. You can have people star it as well. And so there's a lot of power behind this. And this is really, really nice if you don't want to create like a full repository, but you have like, let's say just 5 files that you want to share with someone. This is a really good way of doing that. All right, let's talk about Git aliases. So I have this Git alias called GitLG, and my friend Cody sent this to me, and I'm not sure where he got it from, but this is a beautiful way of seeing your Git log. So we've been doing git log -- one line. And okay, so it's not bad because there's only 3 commits in here. But what if I did GitLG? This looks a little bit nicer, a little more color, a little bit spaced out. What happens if I do this? GitLG in here. And does that look better? Not too much better. Or I can open this up in my own terminal and change the sizing of it pretty easily and do GitLG, and this looks a lot better. And so what I can see here is that Caleb Tallien authored on Friday, November 13th, 7 days of Wagtail source code. On November 25th, he updated the README. On January 14th, there's a new branch where my local head is currently sitting on Git, so my Git is pointing to this particular branch called new branch demo, and the commit is just called hacksword. We've got commit IDs down the left, and we have all this nice stuff, and this all comes with GitLG. Now, if you type GitLG right now, it's simply not going to work for you. You need an alias. And so a nice way to work with this is if I just go back here, because this is a little bit bigger, a little easier to work with while I'm recording at least, is I can type Vim or Nano or maybe even code. Let's try code. /.git config. And yeah, that opened it up in VS Code for me. And what I have here is my entire Git config. This is my personal one. So my user, remember in Git 101 when we were like, what did we type? Git -- config, something along those lines, user.name and user.email. That's what we set here. User name, user email. I also have core and stuff in here. I have a couple different aliases because I check out a lot of things. I type git co when I'm not recording videos. In order to get that GitLG command, I have an alias in here. And it says LG is equal to log all of this stuff. So if I just copy that, and let's move this back up, Git, and then I just paste all of that in there, it gives me that nice GitLG command again. But that's impossible to remember and impossible to type. So what we do is we throw this into an alias inside of our .git config. And that git config, again, once more, comes from root.git config. I have a few other goodies in here that you might also want to steal. So rebase autostash is equal to true. Pull rebase is equal to true, so always pull. GPG program is going to be GPG2. Color diffing, I have all this stuff in here. What I'm going to do is I'm going to paste my my entire git config into a file that you can download. So look for it in your project files or look for it in the lesson files. But yeah, all there is to really creating a Git alias is open up your Git config. You type alias between two hard brackets. The alias name, so git lg, you don't type git, just lg is equal to, and then whatever that command is. So for instance, git co is the same as git checkout for me. Okay, let's talk about your project. What I would like you to do is go to github.com/calebtallien/git-essentials. Now, this is from a different Git course, but this is still very, very applicable. What I would like you to do is A, star this repo, and B, fork this repo into your account. Once that's forked over to your account, what I want you to do is then clone it down to your computer from your account, not this particular one. This one's not going to work for you. Well, cloning will work, but you're not going to be able to push to it. So you're going to want to clone from your account. So it should be github.com/your-username/git-essentials. You want to clone that. Then I want you to create a new branch. And to create a new branch, remember, we do git checkout -b new branch name. Then I want you to add a file. Create a brand new file that doesn't exist in here yet. Create a brand new file and push it up to your new branch. Once you push it up to your new branch, you should see GitHub is going to prompt you to open up a pull request. But if it doesn't, you can always go into pull requests and you can create a new pull request. Let's go from that one. And you're going to want to select your branch, your new branch, and you want to put it into master. So it's going to look a little bit different from this, but we saw it in a video a couple of lessons ago. So you just want to make sure that you point your repository and your branch to my repository and the master branch. Go ahead and create a new pull request. And remember, at any point in time when you're creating a pull request, you can always close your own pull requests. So if you think you messed up, you could always just close that pull request. You can always edit your pull request. Make sure you add a little bit of text in there and make sure that the file's changed is, there's actually something in there. And last but not least, take a screenshot of your pull request and share it down below, share it with the rest of the class. I would love to see that you are actually opening a pull request here. And the whole idea is that you're going to be forking my repo. And then once you are done forking that repo, you're going to make a change, push it up to your account, and open up a pull request to ask me to bring in the changes from your version of my code. And that is the modern workflow way, using pull requests. Go ahead and give that a shot. And when you are done, don't forget to share your code. And I'm looking forward to seeing what you have built and how your journey is coming along in the world of Git. Python 2 versus Python 3. Python 2 is old and outdated. And while there still are companies using Python 2, it's now considered a security risk. It's not maintained whatsoever. And so we're not going to be learning Python 2 because that's old. It's deprecated. It's obsolete. We're going to be learning Python 3. And in this course, we're actually going to be using Python 3.9. So at the time of recording, this is the newest version of Python. But if there is a newer version of Python, let's say Python 3.10, 3.11, absolutely go ahead and download that in the next lesson. And you can use a newer version of Python as well. Everything you learn in this course is still very applicable to newer versions of Python. And that's because Python is reverse compatible. So I would highly recommend not learning Python 2 whatsoever. And honestly, you're not missing much. You're missing maybe a little bit here and there where like syntactical sugar is a little bit different. So like your print statements are going to be a little bit different. But honestly, if you learn Python 3, you've basically learned Python 2. Now, there are a few differences, which I just mentioned in Python 3 versus Python 2. For example, the print statements are a little bit different. But for the most part, Python 3 is not only significantly faster, but it is just crammed full of new features that you're going to want to take advantage of because it just makes your life a lot easier. And every company that you'll work for in the future is going to be using Python 3. So that's why we're not going to be learning Python 2. We are simply sticking with Python 3. Python 2 was deprecated at the beginning of 2020, I believe. And so the idea is that no one should be using Python 2 anymore whatsoever for any reason. And so moving forward, we should be using Python 3. And we're already on Python 3.9. We're pretty far into the Python 3 life cycle. When is Python 4 going to come out? Who knows? Maybe never. We don't know that yet. But even if Python 4 were to be announced, you can still learn everything in Python 3 and apply it to Python 4. And again, that's because Python is largely reverse compatible. In the next lesson, let's go ahead and install Python on our computers. It doesn't matter if you're using Mac or Windows or Linux. We're going to get it up and running on our computer and run a little bit of code. Hello and welcome to installing Python. In these videos, we are going to be using Python 3.9. Now, if you don't have Python, you're going to need Python. Now, if you have a Mac, like what I'm using here, it comes with Python, but it comes with Python 2, and that's no good. We need Python 3. And we're going to be using Python 3.9. Now, if you're on Windows, you're going to need Python as well. So if you head on over to python.org and click on Downloads, you can go in here and you can download the proper version that you're looking for. So I'm going to be using Python 3.9.0, and I'm just going to install that or download that. Where are you? Download, download, download. And if you scroll on down here, you can download different versions here. So I'm on a Mac, 64-bit, so I would download this one. If you're on Windows, Windows 10 most likely, or Windows 7, you're going to want to download the Windows version. And that's probably going to be your executable installer, your Python 3.9.0.exe. And then you're going to want to install that. So I already have Python installed on my computer. But once you have that downloaded and installed, what you can do is you can open up your command line. Now, if you're on Windows, you're going to want to probably use Windows Subsystem for Linux, WSL. That's just the easiest way to work on a Unix-based system. If you're on Mac, all you have to do is open up your app called Terminal. And once you have Python installed, you should be able to do Python-V, and it's going to show you your version. Now, if it shows you the wrong version, like if you do Python-V and it says like Python 2, that's no good. You can do Python 3-V, and it'll show you that I'm using Python 3.8 as my default. And if I want Python 3.9, I can do Python 3.9-V, and it's going to show me Python 3.9.0. So in this course, we're going to be using newer Python, Python 3.9.0. Now, if you're watching this in the future, after this was recorded, and there's a new version of Python, go ahead and get the newest version. You don't need to have Python 3.9 or 3.8 or 3.7. You can get the newest version of Python. So go ahead and make sure you download and install Python. And once you have it downloaded and installed, let's go ahead and look at how we can actually run some Python code in our command line. Okay, let's take a look at how we can run some Python code. So first of all, there's really one way to run Python code. The main way is through your terminal, but there are different types of terminals. So on Windows, you can use Windows Subsystem for Linux, or you can just use PowerShell or Bash if you're on Linux, or Terminal if you're on Mac OS, or iTerm2 if you're on Mac OS. You know, whatever command line tool works for you. All we really need to do is open up our command line tool here, and if I just clear this, I should be able to type Python 3.9-V, and we're going to see it's Python 3.9.0 that I'm using. Now, to execute any Python file is really easy. So typically you just type Python and then your file name .py. Py stands for Python. Py. Now, if Python is using Python 2 or a different version of Python you don't want to be using, you can always just type in like Python 3.8 if you have a newer version, or just Python 3 or Python 3.9, and then your file name .txt. So let's go ahead and give this a shot. At this point in time, you should already have a text editor installed. If you don't have a text editor, I highly suggest VS Code. It's made by Microsoft, it's well maintained, it's fast, it's intuitive, it's smart. It is a good editor. And if you're like me, you don't really like Microsoft products, well, hey, guess what? This is one of the good ones. So let's go ahead and open up VS Code. And in here, we can go to, I think it's just View, and then, yeah, Terminal. And this will open up a little terminal for us in here. And in here, we can write the exact same command, Python-V, Python 3.9-V is going to give me 3.9. Now, first things first, we need to create a new file here. So let's just call this one Hello World. And let's do a print statement. Let's print Hello World. And what I'm going to do is File, Save As, and I'm going to save this right to my desktop. hello world.py. And you can see down here that this automatically told me this is a Python file. If it doesn't do that, you can go down here and you can select Python, but it should automatically do that for you. Next, we want to do an ls-la, or if you're on Windows, you can type dir, and you'll be able to find where you are exactly. So I don't think I'm actually on my desktop right now. pwd, I'm not. So what I want to do here is cd over to my desktop. And if I do ls-la, or if you're on Windows, again, you can just type dir, ls-la is going to show me all of these different files that I have in here. And I've got one in here called hello world somewhere. Hello world, where are you? Hello world.py. So what I can do now is Python 3.9. And instead of -v, we're just going to give the file name. So hello, and then I hit tab for auto-completion hello world.py because I have two files. And it says hello world, and I can do anything I want in here. Hello world from Python 101. And let's go ahead and rerun this command. Hello world from Python 101. And that's how we run our code in our terminal. And so in the future, what I'm going to be doing is I'm going to be writing some code in here, and I'm also going to switch back to my terminal where I can actually write some code in here. And it's the exact same thing. So I could cd over to my desktop. And if you need a command line refresher, I have a command line 101 course. Definitely go check that out. So all I did was change directories to my desktop. And now I can do the same thing here. Python 3.9 hello world.py. And it says the same thing. Now, what I'm going to do behind the scenes is I'm going to alias Python 3.9 to be just Python. So when you see me type Python in the future, if this, again, turns out to be Python 2 for you, just make sure you type Python 3 or Python 3.9 if you've got multiple versions of Python on your computer. And what I would like you to do is very simply create a new file called hello world and print something. So write print parentheses, and then in quotations, hello world. And then you need that ending quotation and that ending print statement. And then in your, either in your terminal, or in your VS Code terminal, or in your PyCharm terminal, or wherever you are, just type Python 3.9 or Python, just straight Python, hello world.py, and make sure that it works. Once that's working, you know you have the right version of Python installed, and it is working with Python 3. In the next lesson, let's go ahead and take a look at some basic arithmetic using Python. Okay, welcome to Basic Arithmetic. In this lesson, we're going to take a look at just some basic math. And this is really, really important to know because we can do some really cool things with simple mathematics. So, for example, we're going to be talking about addition, subtraction, division, multiplication, exponents, and this thing called modulus, which is really just a remainder. It's a really fancy word for remainder. And so what you see in front of me here is I have just gone to File, Open, and I opened a whole folder called Python 101. And you can do this on your VS Code as well. And it just opened up this folder for me. So all of my working files are going to be on the side on the left here. And so I want to go over to View and open up my terminal again. And this way we've got our files on the left and we have our terminal at the bottom, and we can write some code up top in here. And so let's take a look at some basic arithmetic. Now there's two ways we can execute Python. We can execute Python in a .py file like we did in the last lesson where we had hello world, or in your terminal, wherever you want to use that, you can simply type Python. And if you want to get out of this Python shell, we can just type quit, opening and closing parentheses, and that will quit it for us. So I could type Python 3.9. And you can see that the first one was using Python 3.8 because I haven't made that alias yet. I said I was going to, but I haven't got around to it yet. And this one is Python 3.9. And so now we can do some basic arithmetic in here. Let's go ahead and move this up. And let's do some basic arithmetic. So we could do like 5 plus 5 is going to be 10. And this is just executing simple Python for us right in our Python shell. So that's addition. We just use a plus sign. Subtraction is very, very similar. Let's go ahead and make this just a wee bit bigger here. We could do like 99 minus 11. That's going to give us 88. 4 times 4 is going to be 16, and we just use an asterisk. So on a standard North American English keyboard, you use Shift 8, and that gives you this little character here. And so when I hit enter, that's going to be 16. Division is just a slash, just like that. So we could do 100 divided by 25, and that's going to give us 4. And you can actually see that gave us 4.0. That's technically a float. That's not an integer. We're going to talk about these in the future. Now to clear your terminal, let's say I write a bunch of stuff and it gives me errors. I can just hit Control L. Control L tends to clean out the terminal for me. So that's what I'm going to be doing in the future. Now let's talk about exponents. We could do 4 to the power of 4. That's 2 multiplication signs side by side. That is the power of. So in other languages, it sometimes looks like this, 4 to the power of 4. In Python, it's 4 star star 4, and that gives us an exponent. So this is going to be 4 times 4 times 4, which in my mind is going to be 64. Nope, I was super, super wrong, 256. This is why we let computers do mathematics for us. And then we have this weird one called modulus, M-O-D-U-L-U-S, modulus. And all this is going to do is give us a remainder. So if we did 10 divided by 3, we're going to see 3.3333335. It's a weird one. So let's say we wanted the remainder. So 3 goes into 10 3 times, so 369, and it has a remainder of 1. So we can do modulus here. And to get that remainder, we use the modulus sign, which is really simply a percent sign. So we can do modulus 3, and this is going to give us 1. And again, that goes 369, and then it basically takes that last number and says 10 minus 9, and that gives us our remainder. And so if you remember doing long division, well, maybe not remember how to do long division, but if you remember long division from school, it's basically that. It's going to give us the remainder very easily. We don't have to do any sort of long division. And in fact, a lot of people think you need to know a lot of math to get into web development or into programming or into Python. The truth is you do not. And here is the case in point. I could do something like 88 modulus 6.4. Now, I don't remember how to do long division. It's a fairly simple thing in mathematics, but I just don't remember how to do it. That was a long time ago for me. And that was an unexpected indent. If you ever see that, you probably have an extra space in there. And this is going to give us a modulus of 4.799999999999995. And so I don't need to know long division anymore. The computer knows how to do it. And that is the nice thing about pretty much all programming languages, not just Python, but all programming languages can do this. So what I would like you to do is go ahead and try some basic addition, subtraction, division, multiplication, try modulus, and also try exponents. Now, truth be told, you're not actually going to be using modulus and exponents all that often. You probably won't even really use multiplication all that often, or maybe even division all that often in web development. But in data science, you're going to use these all the time, and these are very, very important, especially when you get into things like algorithms, if you ever wanted to get into algorithms. Now, in web development, you don't need to get into algorithms. It's not really all that important unless you're working for Google and you're working with Google's search division, which is pretty unique. Most web development, you don't need that. So go ahead and give addition, subtraction, division, multiplication, modulus, and exponents a try. Make sure you open up your Python terminal. So again, quit. And I just went into Python, and that goes straight into my Python terminal for me, or my Python shell, as I call it, the Python shell. And to quit, you just type quit parentheses, and that gets you out. When you're done that, let's head on over to the next lesson where we learn about variables. Welcome back. Let's take a look at variables. Now for this one, I'm not going to be using my terminal, not just yet anyways. I might open that up in a little bit. And I'm going to create a new file here called variables.py. So what a variable is it's really just a little piece of memory allocated in your computer to a named association, which again sounds like a very complicated thing, but it really isn't. So it looks something like this. We could say name, or maybe let's not do name. Let's do course is equal to Python 101. And this is a variable. So let's take a look at some of the syntax and some of the how it actually works behind the scenes. So behind the scenes, this is our name. And this is going to allocate some sort of memory on our computer. Automatically does that for us. Then we say is equal to, just one equal sign, and then with quotations around it, we say Python space 101. And this is called a string. We'll talk more about strings and numbers and floats and all sorts of data types down the road. You don't need to know that right now. Now, you don't need a semicolon. If you come from a PHP or a JavaScript background, often we use semicolons. Python doesn't care. Python doesn't need semicolons. Python works on new lines, and it works on indentation. So what we could do is we could say print hello world, and you see how this is in quotations, and this is in quotations. Well, we can basically swap that out. We can say, instead of hello world, we could say print course. And what this is going to do is say, find a variable called course, if it exists, and then find what that value is. And so in your computer, somewhere, it's being stored as Python 101. So when we print this, it's actually going to say Python 101. And that's a variable. And that's really all there is to variables. Now there's different variable types, different data types. We'll talk about each one down the road individually. But for now, you just need to know that a sentence has quotations around it. So if you have a space in there, or if you have any letters from A to Z, or any European or Russian or Asian characters, really any sort of character that's not a number or a decimal, you put quotations around it. And so let's go ahead and give this a shot. Let's save this and view our terminal. And what I can do here is, because I have variables in this folder, I can also do ls-la, or if you're in Windows, you can type dir, or if you're in Windows, you can type dir. So ls-la shows me variables.py, and I could type Python, var, hit tab for autocomplete variables.py, and it says Python 101. Now, if this was a different course, if this was, let's say, a JavaScript course, we could simply change that here, and it will change it here for us as well. So we could go ahead and rerun this, and it says JavaScript 101. Now, that's the nice thing about variables, is we can use them as many times as we want. So we don't have to just declare it once. In fact, if you declare it once, it's probably not that useful. Actually, no, I explained that wrong. Declaring it once is useful. You only need to declare it once. Accessing it more than once makes it useful. So we could print this a number of times, and I just printed that over and over and over again. Hit save, and let's rerun Python variables.py, and it says JavaScript 101 over and over and over again down here. And that's all there is to a variable. Now, what I would like you to do, as just a little bit of side practice, is I just want you to create a variable and print it. So create a variable, call it something like Python 101, or create a new variable, call it name yourself, and then print out your name. That's all I want you to do. Nice and simple, should take you 30 seconds to a minute. When you're done that, let's head on over to that next lesson where we look at a little bit of formatting in Python, because I mentioned that Python doesn't care about semicolons. It doesn't really care about curly braces and things like that, and it works on indentation. So let's take a look at that in the next lesson. Python is a unique language because it doesn't care about things like curly braces. So in JavaScript, you have something that looks like this, a function, thing, parentheses, and then curly braces. And then we can have some sort of indenting in here, or we don't have to have any indenting, and we can just write this. That works too. But we're not writing JavaScript, we are writing Python. And in Python, we use indentation. So a thing like a variable, like course, is equal to Python 101. And then to create another variable, we just put it on another line. We don't have to worry about a semicolon or declaring multiple variables at once like we do in JavaScript or any other language. We simply do name is equal to Caleb Tallien. And if you wanted to, you could always follow me at Caleb Tallien on Twitter. Let's do that, in fact. Let's do Twitter at Caleb Tallien. And then for another variable, we simply do, the variable name is equal to, and then some stuff in here. Now, when it comes to things like functions, which we'll talk about near the end of this course, or when we talk about things like conditional statements, which is in the middle of this course, we're going to see things like if something is equal to something else, colon, and then we have our code in here. And what's nice about this is we don't need all those curly braces. We don't have to get lost in where all the curly braces are. We simply use a colon. And that tells Python that the next line is supposed to be indented. Now you can indent any way you want as long as it's consistent. So if you have one space, that's fine. 2 spaces, 3 spaces, 4 spaces, 68 spaces, you could do anything you like. But typically we stick with tabs or 4 spaces. 1, 2, 3, 4. And you can see those tiny little dots in there. That's 4 spaces. I usually just hit tab and that works. Now, in other programming languages, if you have any programming experience in another language, typically we can get away with writing nothing in here. And that's fine. We can stub out some code that way. But that's not going to work in Python. In Python, if we have no code inside of here, we simply type pass. But all our code can go in here. And then when we want to get out of this if statement, we simply delete that tab and we go back to the leftmost line here. And then we could say something like, if something else is equal to something else, pass. And this should have a pass as well. So we're looking at something like that, and that's indentation. And so when you indent, you're saying, hey, there's a colon at the end here, make sure you indent. And that's going to execute all this code in here. And if there is no code, we simply type pass. And that just means do nothing. Otherwise, watch this. If we do course is equal to Python 101, and let's get rid of this pass, and let's execute this file, we're going to see an indentation error. So we can do Python indentation.py. That's the file that I made up here before I started this video. And it says file indentation.py line 8, syntax error, unexpected, end of file while parsing. And so it expects more to be down here. What we could do is we could simply say, let's touch this up, we could say pass. And when we do this, we don't see any errors. So if you see a syntax error, chances are it's just indentation. Indentation isn't working. Let's go ahead and do one more example here. Let's delete that pass and let's write another if statement, but this one has a pass. And so this time we're not going to see an unexpected end of file while parsing. Let's go ahead and run this. And this time we see an indentation error. And anytime you see an indentation error, it's definitely indentation error based. And it expected an indented block after line 8. So, I guess this is actually before line 8. So it's saying there's an indentation error on line 8 and it is expecting something up here. So we could type PASS for pass. And we don't see any errors. And so the whole reason I'm making this video is because in other programming languages, we tend to use curly braces. And curly braces, when it opens and closes, says everything inside of the curly braces is going to be part of, our if statement or our function or something like that. In Python, we simply use indentation. Now, what happens if we go ahead and indent course and Twitter? Well, this is expecting something else. And so it gets this weird indentation here automatically. And when we run this, we should see an indentation error as well. And we see indentation error, unexpected indent. And again, all your code should stick to the left as far as possible, unless you have a colon. Whenever you have a colon, you hit tab. If you have another if statement in here, if something, do something else. We could say if something else, colon, do another thing. And so every time you have a colon, you just want to indent. And whenever you want this if block or a function, and again, we'll talk about those in the future, but whenever you want those to not work, or to end rather, not to not work, but to end, you simply unindent. And you go back to, well, in this example, we would go back to our leftmost area. In this example, we would come back out where it says if, so we would write more stuff in here. And to get out of this if statement, all this stuff in here, we simply say, do more stuff in here. And then what's nice about VS Code is we can simply collapse this with these little arrows. And VS Code is it's intelligent enough to know that these are if statements that are being, well, they're trying to be executed, but the syntax itself is suggesting that, for example, only this should be collapsed, like that. And all of this should be collapsed, like that. Now, there's no homework or assignment for this particular lesson. This is simply a conceptual lesson. I want you to know that indentation is very important when it comes to Python. Code comments. In every programming language, we have some way to write a code comment. And a code comment in Python, and let's just create a new file here called comments.py. is if we have something like name is equal to Caleb Tallien, that's me, we can have a code comment that starts with a number sign. And this is a code comment. And you can see that it's sort of grayed out because it's not actually going to execute when we try to run this file using Python. And so what we can do here is print name. And if we go down here and type python comments.py, we're going to see that it prints my name out. Now, the reason comments are important is, well, first of all, they're not going to be executed. Even if we have a tab in here, it's not going to care because it is simply a code comment. It doesn't matter. Code comments are for humans, they're not for the computer. Now, we could have another code comment at the end of a file, or not the end of a file, but the end of a line, and we simply hit space, number sign, another code comment. And we can go and execute this, and this is still not going to say anything about another code comment. So comments are great for sharing thoughts and ideas to come back to. If you're writing some piece of complex code down the line, you might want to comment your code just so that, if you put your code down for a month or 6 months and you come back to it, you're going to know exactly what's going on. Now, typically in Python, we don't comment basic code. So everything you're learning in this course, we tend to not comment. But if you're working with something complex, maybe data science or large data sets, or something a little bit unique for your website, chances are you're going to want to write some comments. And not only is it good for you, but a code comment can be good for other developers. So if you're using a version control system like Git, you're going to want to share your code comments with other people. So when they download your source code, they can just simply read through it and go, oh, this complex piece of code simply says this is a code comment, or a better comment would be, this is the teacher's name. And so when people read your code, or if you download this code, if you read this code and you say, who is this name? Who is Caleb Tallien? You can read this and say, oh, it's the teacher's name. Ah, okay, that's who Caleb Tallien is. And so it makes a little more sense that way. Another great thing you're going to see is to do, T-O-D-O. And you can see mine actually highlight to do a thing in here. So if you're stubbing out some code for a complex feature and maybe you're halfway through and, tomorrow you want to pick it up, tomorrow morning you want to pick it up, and you're like, okay, well, I still need to do this thing. You can leave a little code comment for yourself. To do a thing in here. Now, if your to do doesn't highlight in VS Code, that's because I have an extension called to do tree. And all this does is it shows your to-dos, fix-me's, etc. And so if I go back here, and you can see down here, once I have that extension installed, it gives me my to-dos, Python 101, comments.py, and it brings me straight to that line when I click to do a thing in here. And so you're going to see a lot of to-dos or a lot of fix-me's in production code, or while you're writing some production code with a team. Now, what I want you to do as your task for this lesson, write a code comment, execute that file, and make sure that it doesn't show up in your code. That's super easy, should take you about 30 seconds, maybe a minute. When you're done that, let's head on over to the next lesson where we talk about Python data types. Let's talk about Python data types. We have different variable types, such as numbers, strings, lists, dictionaries, tuples, sets, booleans, and none. There's actually more, and in Python you can create your own data type as well. So in this lesson, I'm simply going to show you a bunch of data types and what they could look like. And in the next several lessons, we're going to go through each one by one. So let's get started with one that we've already seen. One called a string, and this is simply a sentence like that. And so it has an opening and a closing quotation mark. You could also use apostrophes if you wanted to, but if it starts with an apostrophe, it must end with an apostrophe. If it starts with a quotation, it must end with a quotation mark. And this allows any form of sentence, any form of characters. Anytime you have basically anything that's not just a number or a decimal, you're going to want to use a string. Next, we have integers. And an integer is just a whole number, like the number 99. Then we have floats. And a float is like 99.0, or 1, or 0.2, or pi, 3.14. That's going to be a float. And a float simply means it's a whole number, plus it has a decimal in there. Then we have these things called lists. Now, in other languages, these are called arrays, but in Python, it's called a list, and it looks like this. item 1, comma, item 2, comma, item 3. We'll talk about these in depth as well, so don't feel like you have to remember all these. I just want to put these in your brain for the next few minutes, and then we're going to go over each one of these one by one. And so a list here opens with a hard bracket, I guess you would call it, and ends with a closing bracket. And then you have these different items, and they're separated by a comma and a space, or just a comma technically, but it looks nicer if you use a comma and a space. And then it doesn't even just have to be full of strings, because we know these are now strings from line 1. Integers. And we could put floats in here. And so this is going to be a string. This is going to be a float accessing the variable called floats, which is going to be a value of 3.14. And integers. Integers? Integers. And this is a variable. It's referenced on line 2, and its value is 99. So this is like saying 99. And so that's a list. Then we have these things called tuples. Tuple. And a tuple is a lot like a list, but we can't change it. So once it's set forever. We'll talk about these again in the future. So we could do something like item 1, floats, integers. We could have all sorts of things in here. Then we have sets, and sets are a lot like a list. Again, we'll talk about these in the future in its own particular video as well. But a set is like a list, but in a list, just like when you're going grocery shopping, it's in order. So you've got item 1, floats, integers. When you have a set, it uses curly braces, and it just says item 1, item 2, item 3. But these are not going to maintain their order. So whenever you access a set in the future, even though we wrote item 1, item 2, item 3, it could end up being like item 3, item 1, item 2. It's not going to maintain its original sort of listing. It's not going to maintain its order. That's a better way to put it. It's not going to maintain its order. And so that's a set. Then we have this thing called a dictionary. And a dictionary, if you come from JavaScript, looks like an object. And so we have some sort of key, some sort of value, comma, a second key, and a second value, comma. And that is a dictionary. Then we have booleans, and booleans are either true, and I'm using a code comment here, or false. And notice that it's a capital T for true, and it's a capital F for false. And the last one we might possibly use in this course is going to be the none type. So none is equal to N-O-N-E, and this starts with a capital N as well. Notice this one is a variable, but as soon as I capitalize that N, it changes color for me in VS Code. So that's syntax highlighting, and that's telling me that it's trying to access the none data type. And this simply means that there's nothing in it. So in the next number of lessons, let's go through each of these one by one, starting with integers. Number data types are really important for doing math. So for example, let's go ahead and write something like items is equal to 4. And let's just pretend that we are writing some sort of e-commerce system. So the user has bought or has checked out 4 items and now wants to go and buy these 4 items. And let's say there's going to be a price, and each price is going to be $19.97. So we could say print the total is going to be, well, we know how to do basic math now, so we could do items times the price. And if we print this total and then execute this file, we could do Python integers.py. We're going to get 79.88. Now this is really, really important because if these weren't number types, so this one is an integer and this one is a float, if this was, let's say, a string, and we execute this, this is going to not do what you think it's going to do. So let's go ahead and execute this once more, and we're going to see 1997, 1997, 1997, 1997. And all this is doing is saying 1997 times 4. And so it's taking that string and it's doing it 4 times. Now, a fun little thing you could do here, if you wanted to, is you could make a fun little joke, and you could say, word is equal to, print word times, I don't know, like 10. And let's just comment this one out so that we only get one print statement here. And this is going to say, Batman, something like that. And so this is what happens when you multiply a string, which we've somewhat learned about, with a number. So let's get rid of that. And by the way, how'd you like that for a dad joke? Batman in Python. And so what we want to do is we want to make sure that these are simply number types, so that when we're doing mathematics, we're using either a number, a whole number, or a float. And once more, a float is simply a number with a decimal in it. So even if we did 4.0, that's a float as well. If we do just float, or if we do just 4 rather, that is an integer. And both of these are considered number types. So this one is an integer. Let's do this. Integer. And we'll do a code comment here. And this is a float. And this is multiplication. Now what I would like you to do is recreate my terrible Batman joke. Take a number as any sort of variable. It doesn't matter what the variable name is as long as you use it consistently throughout the rest of your code. And then multiply it by a string so that you get na 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 na. Oh, and actually there's one more thing I wanted to show you here. Python does this really cool thing. So if we did a really large number like this, if you look at this, could you tell me quickly what number that is? Probably not. But what we could do is we could do underscores. And Python doesn't care about underscores in numbers or in integers. It doesn't matter. It simply says, make it readable. And Python is all about making your code readable and maintainable. And so now all of a sudden we can see that this is 1 trillion. If we don't have those, that's pretty hard to read. We have to then count the zeros manually and figure out what the number is. However, if we put those underscores back, we could do print total. That's not going to be right. Let's go ahead, select that, cut, and put that in here. And it gives us this large number without the underscores. And so this just makes it readable. So that's a fun little thing. I almost forgot to mention that. That's really important when you're working with massive, massive numbers. But your homework stays the same. Go ahead and try to recreate this Batman joke that I did. When you're done that, let's go ahead and talk about strings. Strings. Strings are basically just sentences. We use quotations around them like we've seen before, so we could do something like a sentence is equal to, and then we could fill this with like lorem ipsum or really anything we want in here. We could put a number in here, 1, 2, 3 if we wanted to, but this is not going to multiply the way we expect it to multiply or add or anything like that. Basically, your basic arithmetic is somewhat useless when it comes to a string. And so a string should really just be a sentence. A sentence in here. And all we're saying is, this is a string because it opens and closes with a quotation mark. Or, instead of using a quotation mark, we can use simply an apostrophe. So either one of these works. It just has to start and end with the same thing. Now in Python, we can do multi-line strings with 3 at the start and 3 at the end. So a sentence here and on a new line. So there's 2 ways of doing this. Now you're not going to see this too often. It's going to be pretty rare that you see something like this. Chances are you're going to see it on one line using just one set of quotation marks. But let's go ahead and run this. Python strings.py. And oh, that's not going to do anything. Let's print the sentence. Now let's try it. And it says a sentence in here, and this is on a new line. It even kept our blank line in there. Now let's go ahead and have some fun with this, and let's go into our shell. Let's type Python 3.9 or just Python 3 or whatever version of Python you want to use. Hit Control L to clear that out, and let's do a sentence. Sentence is equal to a thing in here, and let's see what we can do. We can do sentence dot and then hit tab, and we're going to see we can do all sorts of things with this. And woo, there's a lot of different things in here. So let's go ahead and just use some basic ones in here. We could do sentence dot upper with parentheses, and it changes it all into uppercase, or sentence dot lower, and that's going to change it all into lowercase. And if you ever want to reference what that sentence is, you could just type sentence, and it basically prints it out for you instead of having to use the print statement. Now, as a fun little fact, you can always do type. Put your variable in there, and it's going to tell you what it is. str means it's a string. You'll see int, you'll see float, list, dictionary, all sorts of things in there, a little bit down the road. But for now, we're just working with a string, and we're using .lower and .upper. So what I would like you to do as your task for this particular lesson is create a sentence, and then do .upper or .lower on it, and print it out, and then execute that. And so what I mean here is you can have a sentence on multiple lines if you wanted to, and then you could do .upper. And remember, it needs those parentheses. That means it's going to execute some sort of logic, some sort of function. It's not just another variable, it's something that's going to be executed. So it takes parentheses. Now we can do Python strings.py, and it's all in uppercase. Go ahead and give that a shot. And when you're done with that, let's head on over to lists, where we learn about how we can accept multiple variables in a single variable, or multiple values in a single variable, rather. Lists. Lists are how we can store multiple items in a single variable. And so a list looks like this. List is actually a keyword, so we tend not to use list, so we use usually lst. If you come from JavaScript, it's called an array. If you come from PHP, it's called an array. In Python, we call it a list. It's the exact same thing, just a different name, I guess. I'm not sure why, but we just call it a list. And so it looks like this. Instead of using quotations like a string or just a straight number, we use an opening bracket and a closing bracket. And then we have anything we want. So we could have a string in here, we could have a number in here, and we could have a float in here. We could even, if we wanted to, have another list in here, and you're going to see lists inside of lists when you get into data science using Python, or most programming languages really. And that's how we create vectors or matrices. We're not going to get into vectors or matrices. That's advanced math, and we don't really need that for web development. But let's create an empty list in here with a new item, and we close that off, and let's do one more. My name, Caleb. And so this is somewhat of an advanced list. And in this list, we have our first value, then second value, third value. Our fourth value is actually a list itself, and its first item, and this is where it gets a little complicated, is a new item. And then in our original list, because this one is closed off right here, in our original list, our fifth item is Caleb. Now, at this point in time, if we just print this out, print LST, we're going to see that this isn't actually super useful. And really, it just prints out exactly what we wrote. So what good is that? Now, a little bit down the road, we're going to be learning about loops. And we can actually loop through all of these, and we can say something like for item in LST, print that item. And what this is going to do, and again, we'll talk about this down the road more in depth, is we're going to say for every item in here, so we've got 3, 4, 5, it's going to print that item. And notice that indentation. So we said for every item in our list, colon, tab, print each of those items. And so now we're getting into a lot of referencing. This item references this, which references each one of these at an individual point in time. So if we type python lists.py, it's now going to actually print it out for us. And we could do something a little more unique. Say the item is, and now it's, oh, I got to save that. Let's go ahead and rerun this. And it says the item is string, the item is 1, the item is 3.14. The item is an array or a list with a new item in it. And then the item is Caleb. And so really what you need to know for this is not this part. I'm going to comment this out, but you can access that code later. But for this particular lesson, all you need to know is that this is a list and it stores multiple values in it. And those values could be variables as well. They don't have to be hard-coded like what I did here. They could also be variables. Now let's go ahead and open up our shell, Python 3.9. And what we can do here is create a new list. So let's give it names is equal to a list called Caleb and Nathan. And we have a list. We could also do names dot append. We could add someone to this. We could say add John to it. Names dot append, and then we use an opening parentheses and a closing parentheses, and inside of it we put some sort of data type. Here I just put a string called John, and that's going to append it. We could do names, and when we type out names here, we see Caleb, Nathan, and John, and so we've added to it. We could also remove a name. We could do names dot remove, and we just give it the item we want to remove. So let's remove Nathan. We type names again, and this names variable, this list, is now just Caleb and John. Now, a really cool thing we can do here, and you're going to see this quite a bit, especially in data science, is we could pop out that last value. So we could say that last value is going to be John, names.pop. And it doesn't take any sort of parameter here. We just say .pop. Now, it looks like it does nothing, but if we type names, it's just a simple list with one item in it. But what it did here was it took that last item called John. And so what it did there was it took that last value out, like up here, it would take Caleb out, and it threw it into a variable called John. Now, what I'd like you to do is go ahead and give this a shot. Create a list of names, give it 3 or 4 names, and then I want you to do list.append and add a name to it, list.remove, remove a name from this list, and then list.pop, and put that into a variable. And just as a reference, there's a lot we can do with lists. We can hit names, hit tab a couple of times here, and we have append, clear, copy, index, extend, count, insert, pop, remove, sort, and reverse. These are all the different things we can do with a list. So if you wanted to, go ahead and try to reverse the list, see what happens. Go ahead and run sort on that list and see what happens. And feel free to experiment with it. You're not going to break anything at this point. So go ahead and give that a shot. And when you're done that, let's head on over to the next lesson where we learn about a very, very popular data type. It's actually a data structure. Lists are data structures as well, but a very popular data structure called a dictionary. Dictionaries. Dictionaries are a special data type. It's actually a data structure. And so if you're familiar with a JavaScript object, it's pretty much the exact same. Or if you're familiar with JSON, it's very similar to that. And so it really just looks like this. We could do person is equal to, and then we use curly braces here. And this is how it knows it's either going to be a set or a dictionary. We'll talk about sets in just a little bit, but let's start with a dictionary. So it has some sort of key, colon, some sort of value. Now your key is typically a string, and the value could be literally anything. It could be another dictionary, it could be a list, it could be an integer, a float, a string, it could be literally anything. And so let's go ahead and write name, Caleb, and Twitter is going to be at Caleb Tallien. And so now what we can do is if I go down, let's actually just make this a little smaller. It's sort of in the way. What I can do here is print the person, and to access any one of these, I simply add the key. So it's a hard brace, or hard bracket rather, and then we put the key in there, and the key is going to be Twitter. And so what this is going to do is it's going to access this dictionary. It's then going to look up Twitter, which matches right here. We can see this matches this. You can see I'm using quotations and apostrophes interchangeably. It doesn't really matter as long as they start and end with the same thing. So it's going to look up Twitter and it's going to give me that value. And so let's go ahead and save this and run Python dictionaries. And we're going to see at Caleb Tallien. That's my Twitter handle. Now we can add things too, which is really nice. And the whole reason we use dictionaries is because currently we would have to have a variable called name and a variable called Twitter. And maybe we want to add a new one called Instagram. And we would have to add that as well as a variable. It would be Instagram is equal to whatever the value is going to be. So instead of 3 variables, we can do one big variable. And so let's go ahead and add that. We can do person, Instagram, and that's the key, is equal to at coding.for.everybody. And when I print this whole thing, let's print the entire person object. We're going to see that Instagram is now in there. In fact, let's print before and after. So let's comment this out, copy that line, paste that line. And so before it's going to print all of this stuff, Instagram is not going to be in there. We then said person variable, add a key is equal to this value, and then print that again. And so if we run this for a second time, we need to save that file first. If we run this for a second time, or a third time, I guess, the original value here is key value, name Caleb, Twitter is Caleb Tallien. Over here, we see that it's key value, name Caleb, Twitter at Caleb Tallien, Instagram at coding.for.everybody. And so we simply added something in there. Now, we see that we have key value in here. We can delete that as well with the del keyword, del, And all we do is type person, and then we access the object or the key or the property that we want to delete. And let's go ahead and delete key. And so we're looking up person, key, and we're simply going to delete it from here. And so if we, for a third time, print this, we can see in the third one down here, there is no key. So the first two have a key. The second one, we added something, and the third one, we deleted something. And that's how we work with dictionaries. Now, dictionaries can become really, really complicated. And the nice thing about a dictionary is you can have dictionaries inside of dictionaries. And why is that nice? It's because you can have one variable storing multiple variable types. Now, when would you even use a dictionary? Like, why wouldn't you just use the variable name, Twitter, or the name Instagram as variables? Well, we do this because these are all related somehow. We're talking about one individual here, me. The name is Caleb, that's my Twitter, and because it's all related around me, I threw it all into one particular data type called a dictionary. So in the future, when you're working with multiple variables, and they're all somewhat related by some sort of subject, like maybe a favorite food, or ingredients for like making your own pizza, for example, you could do something like that. You could have pizza is equal to, and then ingredients is a list of ingredients, the name of whatever you're making. Maybe it's called Caleb's Pizza or John's Pizza. There could be a phone number in here for them to call you at. There could be a website. So instead of Twitter, we could put website and then http://myawesomepizzawebsite.com. We could have all sorts of stuff in there, and it's all related. And so that's why we use dictionaries. We use dictionaries because it's all related information. Now, you don't have to use related information. That's just typically how we as humans use dictionaries. Now, what I would like you to do as your task is create a new person or a favorite food, or maybe the people in your household, including your animals, and go ahead and create key value pairs. Don't forget the syntax is a curly brace. You've got a key as a string, colon, and then some sort of value. And it doesn't have to be a string. It could be anything. And then we use a comma, and that's how Python knows that there's going to be another one. And so we put another one in here, name Caleb, comma, Twitter @CalebTolling. This one doesn't have a comma. Python also doesn't care if you put an extra comma in there. In JSON or in JavaScript, it might care, but in Python, you can put an extra comma. It's still going to work the exact same. It does not care. Go ahead and try that out. And when you're done that, let's talk about tuples, which is a somewhat unique thing in Python. Alrighty, welcome back. Let's talk about tuples. So tuples are a lot like lists in the sense that they're an iterable. And so we use this thing called a for loop when we're learning about lists, and we can do the same thing with tuples. And this just means it's an iterable. It means that we have multiple items that we can loop through and take an action on every single item. But the difference between a tuple and a list is, or maybe it's called tuple. And some people say tuple, some people say tuple. I say tuple. But the difference between a tuple and a list is that a tuple is immutable. And I'm saying immutable versus mutable. And again, developers and programmers like their fancy words. This really just means it's not changeable versus it's changeable. That's it. That's all that means. And so let's do an example here. We have, actually, a better example is going to be right in our shell. So let's open this up and let's type Python and then your version of Python. So I want to use Python 3.9. And so we have this thing called a list. So we could call it like animals is equal to a list of a cat, a dog, a zebra, and an aardvark. Forgive me if I spelled aardvark wrong. I don't think I've ever typed that word in my life. So we have animals here. And what we can do is animals dot sort. And what this is going to do, it looks like it does nothing, but if we type animals again, it put aardvark at the very beginning and it sorted it alphabetically. Now, that's with a list. If we have a tuple, we can't do that. So what we could do is create a tuple, and we're going to call this one foods. Foods is equal to, and it has an opening brace in here, and I just made that a little bit bigger. So let's go ahead and let's close that for a quick sec. And so it basically looks like this. Pizza, orange, apple, and pasta. And so here's a weird little caveat. In older versions of Python, Python might think that this is somewhat of a function. So often you're going to actually see an ending comma in there. And that just tells Python, hey, by the way, for sure, 100% this is a tuple. And so if we do type foods, we're going to see this as a tuple. Let's clear this out. Type foods once more. Now, if we do foods dot and hit tab a couple times, we don't have all these different options. Whereas if we have animals dot and hit tab, we have all these different options, like sort. So we can't sort foods because it's a tuple. Foods dot sort simply doesn't exist. We can do count or index. So let's run sort, and we're going to see we get an attribution error, an attribute error. Tuple object, this tuple that we just created, has no attribute called sort. This is an attribute, sort. We have that on a list, we don't have that on a tuple. We also, in the list lesson, said something like animals dot append. We could add a fish. Animals, and we just added that to the end of the list. Whereas a tuple, we can't do that. A tuple, we're using foods. We don't have append, we don't have add, we don't have anything. Once a tuple is set, it is set for life. We cannot do anything with it. Now, why is that important to know? Well, because when you use a tuple, the idea is that it's a little more efficient. So, for example, animals dot comes with all these different things, and this has logic behind it, and this means it has to store the stuff in memory. Whereas foods dot, this is a tuple, only has two things, foods dot count and dot index, and that's all we have. So it's a little more memory performant. It's just faster. So if you ever need to create a list that never needs to change, never needs to be sorted, never needs to do anything, you just maybe need to store it as somewhat of an immutable or unchangeable list down the road, a tuple is the way to go. So let's close this down and let's create a new tuple example. So let's do foods again is equal to a tuple. So remember, a list starts with this. A tuple starts with parentheses. We could do pizza, fish, tomatoes. And let's just go ahead and throw a comma in there just for a healthy reason, just so that Python always knows. Now, modern Python is smart enough. It knows, hey, if you're using modern version of Python, that this is going to be a tuple. Older versions of Python will say, maybe this is a function. And so we just add that little comma in there to tell it that it's always going to be a tuple. And so we do for food in foods, print the food is whatever that food is. And so this food is now referencing this food, which is going to loop through each one of these, and pizza becomes a food, fish becomes a food, tomatoes becomes a food. Let's go ahead and save that. And let's go to view our terminal. Let's quit, and I'll move that back down. And we can type Python tuples.py, that's the name of my file, and it's going to say the food is pizza, the food is fish, the food is tomatoes. And so this is called an iterable. The only difference here, again, really is we can't do anything. Once this is set, it's set for life. We can't do anything with it. We can't add, we can't remove, we can't do anything except loop through those values and do something with those said values. So that's a tuple. It's a weird one. If you want to, this one's completely optional. Give this a shot and write like foods is equal to and then some sort of tuple and try to append to it. Notice that it'll give you an attribution error or an attribute error. But if you don't want to, you really don't need to do anything because it's very similar to a list. It's a restricted list. In fact, that is a very good way of putting it. I should have said that at the very beginning. Tuples are restricted lists. Let's talk about sets. So sets are interesting because they're a lot like a list, but they kind of look like a dictionary. So remember, a list looks something like this. Varname 2, varname 3. And so this is a list with variables called variable or varname 2, varname 3. And a dictionary looks like this. It has the opening and closing curly braces. And then remember, a dictionary has key value pairs. Key value pairs. And you can have multiple key value pairs. Now a set looks like this. And if I even just move that down a little bit more so we can see all of this in one view, a set, let's just call it S, is equal to And it starts with opening and closing curly braces too, but it doesn't have a key value pair. It simply takes items or values like a list or a tuple does. And so we could say item 1, item 2, item 3. Now, what makes a list really unique is actually two things. Not a list. What makes a set unique is two things. A set, first of all, is not going to maintain its order. In a list and a tuple, it maintains its order 100% of the time. So if this were a list, this would say item 1, item 2, item 3. If this were a tuple, it would say item 1, item 2, item 3. A set does not do that. A set is going to say, oh, okay, just store this anywhere, and it doesn't matter. It doesn't have to remember the ordering, which makes it also a little bit more performant as well. And so if we just comment these out and print s, and let's go down into our terminal here and type python sets.py. I've got to save that file first. Sets.py. Look at this. It does not maintain its ordering. It says item 2, item 1, item 3. It does not care about the ordering. That is very important. That is unique attribute number 1. Unique attribute number 2 about a set is, well, items are unique. So if we type item 2 twice, let's make this a touch smaller. In a list, we can have multiple items. So in the list, this would say item 1, item 2, item 2, item 3. A tuple will say item 1, item 2, item 2, item 3. A set is going to say item 1, item 2, item 3 in any order, and is going to say, oh, these are the exact same, so just merge them together. And so if we run this code once more, we're going to see item 2, item 1, item 3. Again, it does not maintain its ordering, and item 2 only shows up once. Even though we wrote it twice, it only shows up once, so it keeps it completely unique. Now, let's go ahead and open up our Python shell here. Let's do Python 3.9 or whatever version of Python you're using. And let's create a set. And what I'm going to do is I'm literally just going to copy this. That's I copied all of that and I'm going to paste it in here. And so I've got this set called S. And you notice that it's changed its ordering again. It's now item 3, item 2, item 1. Not in any particular order. It just happens to be 3, 2, 1. So we can add to a set, whereas a tuple we couldn't, a list we could, a set we can. So we do s dot, and then we have all these different things we can do. Let's do s.add item 4. And let's do s again, and we can see item 4, 3, 2, 1. We can also remove an item with s.remove. And there's a lot of different things we can do in here. We're not going to learn about all of these in Python 101. But we can do s.remove. So s.remove, let's remove item 3. Item 3. And let's see what s is. And it removed item 3 for us. And it actually maintained its ordering that time. Often it will not. So we can use s.add an item to add an item to the set randomly in there, wherever it's going to go. It doesn't matter. And s.remove, and then the item value, whatever that item value is going to be, we got rid of item 3, and it got rid of it in our set. Now, I would like you to give this a shot because I feel like not enough people use sets, especially for uniqueness. And the nice thing about this is eventually you can turn a list into a set to make it completely unique. That's called typecasting. We'll talk about that a little bit down the road. But for now, just go ahead and create a set. Remember, its syntax is an opening and closing curly brace. There is no key value pair. It's just a list of values. There is no key in there, so there's no colons whatsoever. And then I want you to do set.add and set.remove, and make sure it actually adds and removes those particular items that you're trying to add or remove. When you're done that, let's head on over to the next lesson where we talk about Booleans, which is going to be probably a super quick lesson because Booleans are super, super basic. Booleans are probably the easiest and arguably the most important data type. And so when your code is executed, pretty much everything is going to boil down to some form of a Boolean. And a Boolean, or a bool for short, is a true or a false value. That's it. It can't be a number, it can't be a string, it can't be anything. It's either true or false. It's either 1 or 0. 1 being true, 0 being false. And so we could say something like, can you code is equal to true, because, well, you're going through this course, I would say you can code. And then we can say a conditional, which we haven't learned about yet, but we'll learn about these shortly. We can say if can code is equal to true, and notice that it's got a capital T. False also has a capital F in Python. print, you can code. And let's go ahead and execute this. Python booleans.py, and it says you can code. Now, what if I change this to false? This is not going to work. This is simply going to print out nothing, as we expected. And that's because we're saying, first of all, can code. This is like saying true is equal to true. Actually, that's not. That was a lie. Now it's like saying it's true. So can code is a lot like saying this. Because this value is true and we're comparing it to a true value, it's going to execute this code. And notice the indentation. The indentation is going to become more and more important in Python as we progress through this. Now, when I say everything boils down to a Boolean, and we'll touch more on this when we're talking about comparison operators, which is the if keyword here. An if statement is always looking for something to be true. So if can code is equal to 1, or if it's a string, if I can spell that right, of any kind, if can code, it's going to take this value and try to evaluate it. Is it true? Is it false? And that's basically boiling it down to a Boolean. And because there's a value in here, Python is going to say that string is actually true. And we're going to say this is true. And the if condition here, the if statement, is looking for a true value. It's always looking for something to be true. If it's false, it skips it. Now, there's not really much to do here, just because Booleans are so basic. It's either true or it's false. There's no other option. And this is a Boolean. Once more, I'm saying B-O-O-L-E-A-N, or sometimes you'll see the word bool for short. In the next lesson, let's talk about none, which is basically nothing. None is a data type that means there's nothing in it yet, or we've purposely set it to be nothing. And it looks a lot like a Boolean, where instead of using lowercase, we use uppercase. And you'll notice that N-O-N-E is actually highlighted here, versus N-O-N-E is not highlighted here. And that means one is a keyword, one is not a keyword. So we could say something like, my wallet has nothing in it. And then down the road, we could have some sort of code. And then we could say the wallet has $82.45 in it. Now, all this is doing is saying, hey, there's going to be a variable down the road, and we need to be able to put something in it. But we need to be able to maybe write that variable a little bit early. Now, this is really hard to explain without more complicated code, but all you need to know for this particular lesson is that none literally means nothing. There's nothing in it. It's just an empty variable. And then we tend to overwrite that a little bit later. So in the real world, you're going to see something like wallet is equal to none, and then we could say if wallet is none, and this is a comparison operator, but notice we're not using the same one we used before. We're saying is none. And that means wallet literally is nothing. Print, there's nothing in my wallet. And we could execute this by doing Python none.py, and it says there's nothing in my wallet. We could also do the standard type of comparison, and it's going to do the exact same thing. Now, those comparisons are actually different. That's a subject for another day. But usually what you're going to see is if wallet is none, then we could say there's nothing in my wallet. Wallet is equal to 82.45. And then we could say print my wallet has wallet. And really, this is just going to execute from the top to the bottom. So it says there's nothing in my wallet. If there is nothing in my wallet, reassign that so there's $82.45 in there. And then say print my wallet has $82.45 in there. Now, there's nothing to do with this particular lesson because none is also super, super easy. And we're getting really close to learning about conditional statements, which is basically lines 3 through 5 here. But before we move on, let's talk about indexing and slicing iterables. Let's talk about indexing and slicing iterables. So an iterable is really anything that you can loop through, such as arrays, sets, tuples, or even strings. And so what I want to show you is a non-subscriptable error. But first, before we do that, we need something that's non-subscriptable. And what non-subscriptable means is if I have a list, 1, 2, 3, 4, and 5, I could print LST and then 0, 1, 2, 3, or 4. And so when we're talking about indexing, an index is this here. This is going to be index 0, 1, 2, 3, and 4. And computers always start counting at the number 0. Why? I'm not sure. Probably because the number 0 is actually a number to a computer, and it doesn't mean nothing. That's more of a human concept. It's not really a computer concept. So that's my explanation. Whether that's right or wrong, I have no idea. But if we wanted to get the number 1 in here, we would do 0. And let's go ahead and actually change this. So let's get rid of that and work with this properly. So we're not going to get confused with these. 1, 2, 3. Let's just do 3. And so if I run this, LST, and I get the 0 index, that's going to be this first one, 0, 1, and 2. It just happens to be that the value is called 1, 2, and 3. So let's go ahead and run this. Python indexing and slicing.py, and it says 1. If I change this to 2, which one do you think this is going to run? Remember, it starts counting at 0. 0, 1, 2. So this is now going to say 3. This is called an offset. Offsets are kind of difficult to wrap your head around in computer science and in programming, but once you get the hang of it, it becomes basically second nature. So this makes it subscriptable. A list is subscriptable. That means we can use this particular value in here. And so we're saying list, and because it's subscriptable, we use a hard bracket. The index we want to use, so the index number, closing bracket, and this tells it to pick out number 2. So 0, 1, 2, and then we close the print statement. Now let's go ahead and give a Boolean a value here. Let's say it's true, and we could say b, just the variable b, and let's give it the 0 index here. Now notice how it doesn't have a list of things. It doesn't have 1, 2, or 3 in it. It's not a list, tuple, set, or a string, or really anything that's subscriptable. We're going to see some sort of error in here. And it actually says, type error, bool, this is a Boolean, it's an object, everything in Python is called an object, is not subscriptable. And that means we simply cannot use an index in it. And so that is an example of a non-subscriptable error. Now, what if we wanted to, in our list here, let's go ahead and add some more. 4, 5. What if we wanted to just get the first one? Well, that's easy. We know that already. We could do LST 0. What if we wanted to get multiples? What if we wanted to get 1, 2, and 3? We could do list 0 and then print list 1 and list 2. Or we could do 0, and then where does it stop at? 3. So let's go ahead and run this, and we're going to need to print this as well. Print our list, start at 0, that's 1, and go to 3. And this needs to be saved first. I keep making that error. And it says 1, 2, 3. And so all this is doing is saying start at 0, 0, 1, 2, 3, 4, and go up to the third one. So 0, 1, 2, and it goes up to the third one. Remember 0, 1, 2, 3. So this is technically the third one, and it's going to say, grab all of those. Now we could also say, start at a particular number and go all the way to somewhere else. So we could say 2, colon, colon, and when we do this, let's just run that, it says 3, 4, 5. So it starts at 0, 1, 2, 3, 4. So it's going to start at 2, right? 0, 1, 2, and the colon, colon means go straight to the end. And we could also work our way backwards. We could say list -1, so start at the very back. And what do you think this is going to do? If this one is 0, that's our index, what is -1? Is it going to be 5? Or is -0 5? See, that's a good question. And this is why we need to experiment with Python as we're learning. It's always fun to experiment and learn how things work. We're going to see that this is actually 5 because 0, -1, -2, -3, -4, -5. Let's go ahead and try -5 and see what this runs. boom, it worked its way backwards. So if we ever just wanted like the last two, we could say -2, ::, and this is going to give us 4 and 5. Just like this, 4 and 5. Now, strings are also iterables. And we can do the same thing here. So we can say course is equal to Python 101, print course, and then we can give it also an index. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And so let's say we wanted the n. We would go 0, 1, 2, 3, 4, 5. Let's print that, and that's going to give us the letter n. Now, what I would like you to do for your task is let's uncomment that and do a list. So LST is equal to something. It doesn't have to be called LST. It can be called literally anything. And I want you to experiment with different index numbers, with different slicing and indexing. Remember, this is called slicing if we use colons. If we don't use a colon or a set of colons, this is called an index. So this is an index, but what's going to be returned here is a slice from this array or from this list. Go ahead and give this a shot. Have some fun with it, tinker around with it, and just get some muscle memory to remember that this is 0, 1, 2, 3, and bam, 4. Try that out, get some hands-on experience with this. In the next lesson, we're going to learn how to accept user input so that we can work with it. So we all know that Python is basically a command line program. It can be visual for sure, but currently, as we know it, it is just a command line program. And so it has to run on your command line. And sometimes you want to ask someone for some information. We can do that with the input function. And so let's say you want to make a command line game, or you want to accept some form of user input in raw Python. You're going to need to use the input function. Now, as a heads up, every time you ask for input from a user, even if they type in a number, it's always going to come back as a string. So let's give this a shot, and I'll show you why knowing different data types is really, really important. So we could say, your age is going to be input, and we could say, what is your age? And just as an example, this is Python user input. This is just simply going to ask me what my age is. So I'm going to type 31. Does nothing, but it did ask me for my age before it exited the script. So that's pretty cool. It paused it on line 1. Then we can say dog years is equal to age times 7 and print dog years. Let's go ahead and give this a shot. What is my age? 31. And you notice that it says 31, 31, 31, 31, 31, 31, 31, 31 over and over and over and over again. And that's because age is coming back as a string. And we actually need that to come back as a number. So in the next lesson, we're going to be learning about casting. How do we turn this into a string? But for now, let's take the shortcut and let's just say this is going to be an integer. And so we're saying whatever this comes back as, if I type 31 or my name, it doesn't matter. It's going to try to cast that as a number, or as an integer rather. And so let's go ahead and run this one more time, 31. And I'm going to be 217 years old in dog years. Now this is honestly not the greatest example because we're getting ahead of ourselves by talking about casting. We haven't learned about casting yet. Instead, what we could do is we could say name is equal to input, what is your name? And then we can say print hello, and then the name. And when we rerun this, we're going to see Python user input. What is your name? My name is going to be Caleb. And it says, hello, Caleb. And there's an extra space. Let's go ahead and ditch that space. What is my name? My name this time is going to be Nathan. And it says, hello, Nathan. Hello, Caleb. And it stored whatever I wrote in here into this name input. And so now we can create some sort of guessing game. Or for our project, we can input some sort of value for, let's say, rock, paper, scissors. Now, the main thing to take away from this is you can ask for any sort of information, but it's always going to come back as a string. And that's why it was important to know strings, integers, floats, things like that. In the next lesson, let's go ahead and cast some data so that we can start working with this a little more appropriately. And casting, again, is as simple as running int or bool or something like that. We're going to look into that in the next lesson. Oakley dokley, let's take a look at typecasting. In the last lesson, we looked at it very, very briefly. And so typecasting is simply changing one data type to another data type. So if we wanted to change a string into a list, we could do that. We could change any of those into a Boolean or a dictionary or a tuple. And you'll notice that these words are being highlighted. This is normal text. And you can see is in Python is a keyword, so it's being syntax highlighted there. We've got string, list, bool, dict, tuple, set, etc., etc., etc. Basically, any data type that we've talked about so far, we can cast it. So let's go ahead and create an example here. Age is equal to input. What is your age? And then we can print the type of age. And in fact, let's throw this into its own variable. So data type is equal to function type. And then we throw whatever that value is. It's going to be a string. We know that all input is going to be a string. We learned that in the last lesson. Then we could go ahead and cast that age by saying, we know it's a string, turn it into an integer. And we're going to throw age in here. And so all we're saying is whatever age is, turn it into an integer and put it back into that same age variable. Then we can do the same thing, data type, and I just copied and pasted there. And let's move this just down a little bit here. And let's run this. Python typecasting. What is your age? I'm going to put, let's error this out. Caleb. I'm going to say Caleb is my age. Caleb cannot be turned into a number. Let's see what error pops up. We get a value error. Value literal for int with base 10. And so it's trying to turn Caleb into a number. Doesn't work that way. Let's try this again. What is my age? I'm currently 31. And we need to print this. So what I'm going to do here is I'm going to click here, and then I'm going to command click down here, or if you're on Windows, I believe it's just control click. And I'm going to type in two spots at the same time. Print, data type, new line. And so this is all of our code. Let's go ahead and give this a shot. What is my age? 31. And originally it was a string, and then it was an integer. Now we can work with that as an integer. We can say, print your age in dog years is, and then we could say age times 7. Let's go ahead and give this a shot. What is my age? 31. And it says your age in dog years is 217. And just as a fun fact, you're probably looking at this wondering why I use multiple parentheses here. Do we need this? Do we not need this? Whenever you have a question like that, it's always good to experiment. Experiment and then ask the question. So what is my age? 31. And it still works. All I did was clean that up a little bit by using parentheses around age times 7. That's all that was. Now this is one example. We can go ahead and create another example. Let's convert a list into a set so that all the items are unique. So let's say we've got a grocery list. Grocery list is equal to, and we need to pick up apples, oranges, nanners, bananas, and apples. And you can see here, and I just made that a touch smaller, you can see here that in my grocery list, I have apples twice. And so if I wanted this to be completely unique, what I could do is say this grocery list is equal to a set, because we know sets are completely unique. It's not going to hold its order anymore, but honestly, if we're doing grocery shopping, we don't need it to be necessarily in order. And then let's print this grocery list, And what this is going to do is return apples, oranges, bananas in any order. It doesn't matter what the order is, but apples is only going to show up once. We can also type of grocery list, and we're going to see that this is a set. So we know that up here, this is a list. We're casting it to be a set, so it's going to be completely unique. It's going to get rid of the 2 apples in here and turn it into just 1 apples. Then we're going to print our unique list, and we're going to make sure that it is, in fact, a set. So let's go ahead and run this. And we've got oranges, apples, bananas. We don't have apples in there twice, and we can see that it is, in fact, a set. Now, I have a particular task for you that I would like you to try. I want you to make a grocery list. It could have any foods in there, but it has to be a list. And then I want you to cast it as a tuple. And the idea here is you make your grocery list at home, and when you're at the grocery store, you're like, I don't want to be buying anything else, so that I have to stick to this list. I can't add anything, I can't remove anything, I have to get everything on this list. So cast it as a tuple, and then I want you to, just like we did here, print your list, or it's going to be a tuple, so print your tuple. And then I want you to print the type of variable that this is. So this should now say a tuple instead of a list. Go ahead and give that a shot. It's really important that you learn about typecasting because it is very important when we're working with user input. And what's the point of making a program if it's not going to accept any form of user input? We need to be able to accept user input, and we need to be able to cast things a certain way. Go ahead and try that out, and when you are done, let's head on over to that next lesson. Let's talk about print formatting. So there's like 100 different ways, not actually 100 different ways, but there's like 100 different ways to format your print statements in Python or to format your sentences in Python. There's so many different ways, but we're going to learn the two most modern ways. One is going to use .format, and the other one is going to use this thing called an F string. So let's go ahead and set up a little example here. Welcome message is going to be hello, some sort of name, welcome to Python 101. And then we want to print this message, print the welcome message. Now, we need to somehow replace this. So let's create a name, because currently we don't know how to dynamically put something in here into a variable. Let's create a name. Welcome, Caleb. And so the first way we can do this is using the format function. And I think this was introduced in Python 3.6. So we can do curly braces, dot, format at the end, name. And all this is going to do is look for this curly brace, and then it's going to format it with dot name. So name is going to be Caleb, and it's going to inject it right in there. So let's go ahead and run this code, and we're going to see that it actually works the way we expect it to work. And it says, hello Caleb, welcome to Python 101. Now that's one way. The more modern way, arguably the better way, the way I really like to do this is with an F string. And so an F string looks like a regular string. So we could say, hello, some sort of name, welcome to Python 101. And instead of using dot format, what we can do is we can put a variable in here. So we use curly braces, name. Now this itself is not going to work. I'm going to show you what this looks like. It says, hello, curly braces, name. That's not working. But if we put a little F in front of it to format this, Python now knows that this variable is going to be basically from somewhere else. It's going to be from above it at some point. And so it's going to throw Caleb into here. And so I much rather prefer the F string method over the format method, just because you can read it. You can say hello, name, and you know exactly what that's going to be. Welcome to Python 101. And that's not going to work until I save that file and run it again. There we go. Hello, Caleb, welcome to Python 101. Just like that. That's exactly what we're expecting. Now, there's the old way where we could put a % in here, S string, and then we could say % name. And you're going to probably see this quite a bit, but this is going to work as well. This is the old way of doing it. And so, not F. There we go. Still outputs the same thing. But this is saying there's going to be some sort of string, and at the end we use the % and then the variable name. But honestly, I don't like doing this way. It's the old way, and it doesn't seem as intuitive as simply writing the name right in here. This way you can read it like a regular sentence, which is very Pythonic. You can say, hello name, welcome to Python 101. You know exactly what's going to go in here. With the other methods, you don't know exactly what's going to go in there. It could be a name, it could be a number, it could be anything. You don't really know, but when you name your variables explicitly like this, you have a good idea of what's going to be injected. So what I would like you to do for this particular lesson is write the .format method and also write the fstring method. Go ahead and inject a variable into a string and then print that string out, execute that file, and if it's all working the way you expect it to work, let's head on over to that next lesson where we finally learn properly about comparison operators. Alrighty, let's finally take a proper look at comparison operators. A comparison operator is how a computer can compare values to make some sort of decision. So everything in computer science really boils down to this. Without the ability to make a decision based on existing data, a computer doesn't know what to do. And in fact, a program is rendered completely useless if it doesn't know what to do. Now, the idea is if something is true, do a thing. Otherwise, if it's false, do something else. And it splits the code into some sort of a path. And so let's take a look at the syntax. It looks something like this. If something is equal to something else, do a thing. And so this is saying if something is the same as something else, do something. We can also say the opposite. If something is not something else, do it. So we're looking for a false operator there. And by that, I mean, like, if we're saying if something, for example, if true is equal to true, do something. Then we can also write an else statement. If true is not equal to true, for whatever reason, do something else. And so let's go ahead and switch this back. If we say can code is equal to true, do a thing. Otherwise, do something else. And let's comment this out as well. And so now we can actually start to work with this. And notice we're using colons here. And when we use a colon, we indent automatically. We've got an indent there and we have an indent here. So let's go ahead and set this up for success. We can say can code is equal to true, print, you can code. Otherwise, print, you don't know how to code yet. And let's go ahead and run this. We can do Python comparison operators.py, and it says you can code. And the idea here is, again, we've got some sort of variable that we're comparing. We're saying can code is true. If that can code value is equal to true, then print this. Otherwise, if we say we can't code yet, and we type false up here, this is a lot like saying false is equal to true. Well, that just makes no sense. False is not true. True is true, right? And so if we type if can code, which is false, is equal to true, well, this statement does not become true in the computer's mind. In the computer's CPU, it's just not true. So it's not going to execute this. What it's going to do is say, look for an else statement and then print that. And so we're splitting our code into two different ways to execute itself. And so we can do this again, and it says, you don't know how to code yet. And that's because we changed it from true to false. Again, if we change it back to true, it says you can code. Now this is just one example. This is a Boolean example. We can write another example here. We can say, teacher is equal to Caleb Tallene. If the teacher is equal to Caleb Tallene, print, show the teacher portal on a website or something like that. Otherwise, you're probably a student. You can say, print, you are a student. Welcome to Python 101. And boom, it says show the teacher portal. And that's because teacher, this value, is the same as this value. Now, what happens if we did this? Caleb Tallene, but all lowercase. Caleb Tallene with a capital T and a capital K is not the same as Caleb Tallene with lowercase letters. And so it's going to say I'm a student, which is technically wrong. But a good way to compare this is because we never know if users are going to make a typo or capitalize things. People do weird things sometimes, and I've seen this a lot. K-A-L-O-B with a capital B. I don't know why, it just sometimes happens. So we can say teacher dot lower, and that's going to change this into a lowercase value. It's going to look like that. Teacher.lower is equal to the lowercase value. So this is a little less strict now. And it's going to check to see if, even if there is an uppercase letter somewhere else, it's still going to match the name perfectly. And when I rerun this, it's going to say, show the teacher portal. Now let's go ahead and get a little fancier with this, and we can ask for user input. And so now we can say, what is your name? Your name is going to be input. What is your name? And then we can say, if that name is equal to Bob, and we're looking for a capital B here, print, welcome, Bob. Otherwise, print, hey, you're not Bob. Get out of here. And when we run this, it says, what is your name? And I could type in Caleb. It says, you're not Bob, get out of here. I could type it again. What is your name? B-O-B. Welcome, Bob. And so now we have a way of running different sets of code. Now, this might not seem like a really good example, but we can get a little more complicated with it. Just a touch more complicated. So now we can say, bring food is going to be pizza, because apparently Bob likes pizza. And for people who aren't Bob, you get everything else. The food we're going to bring is going to be not fish, salmon. Print. You are eating, and then bring food. And this is going to be an F statement, so that we can put bring food in there. And what this is doing is it's splitting our code and then bringing it back together. And so we're going to ask for the name. If the name is Bob, it's going to say welcome Bob, and it's going to bring pizza. It's going to say you are eating pizza. If the name is not Bob, it's going to say, hey, you're not Bob, get out of here. And the food is going to be salmon. And then it's going to say you are eating, bring food. And in both cases, we're declaring a variable here called bring food. And so our code is essentially split, like a fork in the road. And either way, there's going to be a bring food at the end of it. It's just going to be a different type of food. And then at the end, that fork in our road, that split code is going to come back together, and we're going to say you are eating whatever that food is. Let's go ahead and give this a shot and see what happens. It says, what is your name? My name is going to be Caleb. And it says, you're not Bob, get out of here. You are eating salmon. I could run that again, and if I type my name as Bob, it says, you're not Bob. I probably added a space in there. B-O-B, there we go. Originally I typed B-O-B space. I didn't mean to have that space in there. Remember, strings when we're comparing are very sensitive. And in fact, they're not only case sensitive, but like, you know, if there's an extra space in there. So if we said Bob with a space versus Bob without a space, that's important to distinguish. So now it's saying, welcome Bob, you are eating pizza. And so now our program is getting a little more advanced. It's asking for some form of input, and we're doing an if statement. If that name is Bob, the food is going to be pizza. Otherwise, if the name is not Bob, the food is going to be salmon. Now we can make this one step more complicated. Maybe not complicated, but advanced, and we can do an elif. So in other programming languages, we call it an else if. In Python, we call it an elif. And we can say the name is equal to Caleb. Bring food is going to be tacos, because I love tacos. And it's going to print, welcome to your teacher portal, I guess, because why not? And so now what this is doing is it's going to go from top to bottom. It's going to say, is that name Bob? Maybe it is, maybe it isn't. If it is, then cool, execute this code and ignore all of this. Otherwise, if it's not Bob, it's going to then check to see if that name is Caleb. If it is Caleb, cool, it's going to execute this code and it's going to ignore all of this. Otherwise, if the name is not Bob or Caleb, it's going to execute this code. Let's go ahead and run this. I'm going to type K-A-L-O-B, and it says, welcome to your teacher portal. I am eating tacos. And that's because it didn't recognize that the name is Bob, so it skipped this entirely. It did recognize that the name is Caleb, so it executed this. And because of that, and notice the indenting here, we've got 3 paths we can go down if the name is Bob, if the name is Caleb, or everyone else. And so because it executed this path, it's not going to go down this path. And again, it's a lot like a fork in the road. When you're driving somewhere or you're walking in the forest and you see a split in your path, you can only ever take one path. And that is exactly what an if, elif, and else statement is. Now we can do unlimited else if statements. We could do if the name is equal to Nathan, bring whey protein. And we're going to welcome him with welcome to the gym. And let's go ahead and give this a shot. We're going to type the name as Nathan. And it says, welcome to the gym. You are eating weight protein. Whey protein. I have no idea how to actually spell that. Good enough though. Good enough for this example. Spelling is unimportant here. But yeah, that's a comparison operator. So we have if statements, elif statements, we can have unlimited elif statements, and an else statement. And that just basically splits our code into, consider it like a fork in the road. Now we have another way of doing this. If we wanted to ask for someone's name, we could say the name is equal to input, what is your name? Then we could say that name has to be name.lower. And we could say if the name is not Bob, print, you're not Bob, get out of here. And then we could like exit the code, or we could do something with that. Otherwise, if the name is Bob, and this is really just the inverse of where's our first example? Where's a good example here? If we get rid of this stuff, it's the exact opposite of this. So the first one is saying if you are Bob. This one down here is saying if you're not Bob, print, welcome, Bobby boy. And what is my name? My name is going to be Bob. Oh, nope, I spelt it with a space in there. B-O-B, no space this time, and it says, welcome, Bobby boy. The first one, did you notice, even though I typed Bob, there was actually a space in there. I typed it too fast, and it said, you're not Bob, get out of here. We can do the same thing. Caleb, it says, you're not Bob, get out of here. And so there's two ways to do this. We can say, if something is equal to, or if something is not equal to, we can do that kind of comparison operator. We can also do different types of comparison operators. And I'm going to fly through these pretty quickly, and I want you to, at the end of this video, give these a shot. I want you to try these out. So let's say age is equal to 18. If your age is equal to or greater than 18, print something like you can vote. So there's a greater than or equal to symbol. You can do just greater than, or instead of doing just greater than, you can do less than. If you're less than 18, you're probably not allowed to vote. If you're less than or equal to 18, so that's 18, 17, 16, 15, 14, etc., includes the number 18. Or if the age is exactly 18, or if the age is not 18. And so actually what I'm going to do is print these out. So we've got greater than or equal to, less than or equal to, is equal to, and is not equal to. So these are the core comparison operators in pretty much every programming language. So once you learn these in Python, you've learned them in pretty much every other language. And so you really just need to remember that this one is the same, this one is not the same. And so what we're doing in any comparison operator here is we're saying, is the left equal to or not equal to the right? And what the computer is going to do is boil this down to a true or false statement. It's going to say, let's do this. If the age is equal to 18, well, 18, if we replace this, 18 is equal to 18, is that true or is that false? In reality, that's true. And so the program sees it like this, as, oh, that is true, execute this. Otherwise, let's change that age to 21, and let's say if the age is not 18, the person has to be exactly 18 for whatever reason. Is the left the same as the right? And so we're saying, is 18 not 21, or rather, is 21 not 18? And so what we're doing here is we're saying 21 is in fact not 18. This is where it gets a little tricky in our heads, but this is the opposite. And so this is true, because 18 and 21 are not the same, and we're comparing that they're not the same. That is in fact a true statement, and this will execute. So I'm going to get rid of this example because in the source code, that's not going to make any sense. Let's go ahead and comment that out, and you can access the source code at any time and just uncomment what you like. What I would like you to do as sort of your task for this particular lesson is create an example with a greater than or equal to, less than or equal to, is the same, and is not the same operators. Go ahead and give those a shot. Feel free to use user input or hard code the value so you don't have to type it every time. But the point is you're going to be using these probably hundreds of times a day. And it's really important that you understand which ones do what here. Let's talk about comparison shortcuts. In the Boolean lesson, I believe it was, I said something along the lines of everything gets boiled down to a Boolean. And in the last lesson, I said Basically, if statements or comparison operators are looking for a true statement. So notice that if something is true, we can do something else. And really all this is saying is there a Boolean that tends to be true or false? And if it's true, if whatever that statement is true, execute the code inside of our indented code here. Now, in the last lesson, we did something like if age is equal to 18. In this particular lesson, let's go ahead and do something a little bit shorter. So we're just going to say if something, do something else. And let's make this a print statement, print. And so we're not doing or using any comparison operators here. We're simply saying if something is true, and again, everything boils down to true or false. So we could say something is equal to none, for example. And let's go ahead and do an else statement, print, and I need to fix that one. This is false. And we're going to say this is true. And so when we execute this, not comparison operators, let's execute comparison shortcuts. It says this is false. None always returns false. What if something is a string? A string in here, and we execute this. This is going to be true. Anything, any string with a value in it is going to be true, but an empty string, that's going to turn out to be false. And it says this is false. And so an empty string is in a comparison operator and in Python, a lot like saying if something is false. We can also do Booleans if something is true, and this is going to print this is true. Sure enough, this is true. And false is going to execute the other path, so this is going to be false. And so this is a lot like saying if something is equal to true. Let's execute this, and it's going to say it's false because false is not true. As a shortcut, we can just get rid of that. And boom, it's still false. What I would like you to do is give this shortcut a little bit of a test. So try it out with a list, just an empty list, and then try it out with a list that has items in it. Try it out with a set. Try it out with an empty set. Try it with a tuple and see if an empty tuple returns true or false, and then put items in there and see if a tuple that has items in it is true or false. Go ahead and give those a shot because you're going to see this kind of shortcut everywhere when you're writing production level code or professional developer level code. When you're done, tinkering around, let's head on over to that next lesson where we learn about multiple comparison operators so we can compare multiple things at the same time. Let's talk about multiple comparison operators. Okay, multiple comparison operators is when two things have to be true, or three things have to be true, or four things have to be true, or one of two things has to be true. And so what I'm saying here is the and keyword. I'm also saying the or keyword. And so we can say age is equal to 31. Name is equal to Caleb. And then we can write an if statement, like if your age is equal to or greater than 18 in Canada, or in some parts of Canada anyways, you can print, I can drink alcohol. Now, what if I wanted to check if the age is 31 and the name is Caleb? Well, currently, the only way we know how to do this is by nesting these if statements. So we'd have to say if name is equal to Caleb. Now I can drink alcohol. So it's going to say, yep, this is true because 31 is in fact greater than or equal to 18. And then it's going to say, is Caleb equal to Caleb? Well, yep, that's true. And then I can print, I can drink alcohol. But there's a way to merge these together. So what we can do here is take this if statement, this nested one, and just delete this. And then we can say and. And so now we're saying if the age is 18 or greater, and get rid of that if statement, and the name is Caleb, then I can drink alcohol. And so we just merged two if statements together. Now the trick here is and is saying that both items on the left of this word and the right of this word have to be true. If either one of them is false, this is not going to print. So let's give this a shot. Let's say the name is going to be Python multiple comparison operators, and it doesn't print anything. Else, let's do an else statement in here. Print. Don't do anything, just so we know that it's actually working here. Don't do anything. And so one of these was false. Now, if I change this back to Caleb, and so this is going to execute, and that's because my age, 31, is over the age of 18, and my name is Caleb. I can drink alcohol. And so it's saying over here is true, and over here is true. Now, we also have an and statement. So what I'm going to do is I'm going to copy this and comment that out, and then just paste it down here, and change this and to an or. And so what this is saying is the item to the left or the item to the right needs to be true. Only one of them needs to be true. And so if I go back up here and change my name back to Jacob, 31 is greater than or equal to 18, so that's going to be true. Name is equal to Caleb, that's going to be false. And so with an or statement, just one of these needs to be true. And we could say, I can drink alcohol if the name is Caleb or if the person is 18 or older. Let's go ahead and give this a shot. And it's going to say, I can drink alcohol. And effectively what this is doing is it's going to render it from the left to the right. And it's going to say, this is true or something else. This happens to be false, but it doesn't matter if they're both true. Typically, they both need to be true in a regular if statement or a comparison operator. But the or keyword here is saying only one of these needs to be true for this to execute. And so if I actually execute this code, you're going to see that it works the exact same way. It says I can drink alcohol. And it's because it's only looking for one of these answers to actually be true. But if we're looking for both answers to be true, we use the and keyword. And that's going to say both true, or whatever's on the left, and whatever's on the right needs to be true. So both of them need to be true. And this, in fact, is going to say don't do anything. And that's because one of these, while both of these need to be true, one of them is in fact false. And so it's going to say don't do anything. And I'm just going to undo that. So your task for this lesson is to give this a shot. Use the and keyword and the or keyword. Tinker around with that because you're going to see this a lot in production code. There's going to be a lot of comparison operators that use the and keyword as well as the or keyword. So please give this a shot and really let it sink into your brain how this is going to work for you. For loops, we've actually dealt with these in a couple of lessons already, but a for loop is just a way to iterate through some sort of iterable, and is going to allow us to take an action based on every item in a list, a tuple, a set, or a string. So some sort of iterable object. And so we can say favefoods is equal to a list of pizza, tacos, and salmon. And so a for loop is really easy. We're just going to do for every food in the iterable, the favefoods iterable. Print food. And so what this looks like is for item in your iterable, you can do something with said item. That's all that is. And so the syntax is really easy, but also notice indenting, important. We're using a colon, so we indent at the very beginning of the next line. And so when I execute this code, we're going to see pizza, tacos, and salmon. Now we could also get a little fancier with this, and we could say print f string, my fave food is, and then the food itself. And this is going to print 3 different statements. My fave food is pizza, tacos, and salmon. And so literally that's all there is to this. Now we can mix this with a conditional or a conditional comparison operator. And we can say if that food is equal to pizza, size is equal to input, what size pizza would you like? And then print an F statement, you ordered a large pizza. And instead of saying large, we can change this to size. And so let's go ahead and try this now. And so what this is going to do is this is going to loop over every single one of these items, pizza, tacos, and salmon, no matter how many items there are. It's going to loop over all of them. And then it's going to say, if that food happens to be pizza, which is the first one here, what size pizza would you like? That's going to ask me for it. That's the size. And then it's going to say I ordered a whatever size pizza. Let's go ahead and give this a shot. It says, what size pizza would I like? I want a large pizza. And it says you ordered a large pizza. Or I could type small and it says you ordered a small pizza. Now what's cool about these iterables is we can swap this out for a set. So this is going to be a set, or we could cast it. In fact, let's do that. Let's cast this. Fave foods is going to be a set of fave foods. Now this is going to work the exact same way, but let's go ahead and comment this out. And let's just print the food. Print food. And let's execute it. It says tacos, pizza, salmon. Tacos, pizza, salmon. We know that that's a set, primarily because it's not maintaining its order anymore. We could, instead of using a set, we could use a tuple. This is going to work the exact same way. We don't even notice the difference at this point. That's pretty cool. What else can we do here? Let's use a string. So let's loop through all the characters in the word pizza. So food is equal to pizza with an exclamation mark. We can say for letter in food, print that letter. And because we know that strings are subscriptable, we learned about subscripting in a lesson a little while ago. So it's going to get P-I-Z-Z-A exclamation mark. And so let's go ahead and try this. It's also going to print out the foods from up above here in the fave foods. So let's just pay attention to the bottom part. So it says pizza, taco, salmon. That's from the top part up here. And then it says P-I-Z-Z-A exclamation mark. And that's because it's printing every single letter in our string. We can also loop through dictionaries. So let's go ahead and comment this out. And comment that out. And comment that out. We can loop through a dictionary. So we can say our dictionary of, let's say person is equal to name, Caleb. Twitter is going to be at Caleb Tallene. Feel free to come follow me there. And Instagram is going to be at coding.for.everybody. And so if we try to do this, we're going to get something a little bit strange because there's a key value pair. Which ones do we loop through? And so by default, we're going to see what it does. For, let's just call it a value in person. Let's print that value. And we're going to see that first of all, I need to save that file again. It just prints the keys. Name, Twitter, and Instagram. What's cool about this is now, because this is a dictionary, we can say dot items, and this is going to be a key value pair. So we've got a key value pair. So now we're going to deconstruct this. So for every loop here, we're going to get the name and the value, or the key and the value, the key and the value. So it's going to be a key value pair, and we can do the key is key, and the value is value. Let's throw an F at the front there for an F string, and let's try this out. And it says the key is name and the value is Caleb. The key is Twitter and the value is Caleb Tallene. The key is Instagram and the value is coding.for.everybody. And we did that with items. Now you can also try this with keys, and you can also try it with just values. But you're not going to be able to deconstruct, so you're going to have to use a regular for loop. And I'm purposely making this a little bit more difficult to understand because, well, sometimes you have to pick up code that we don't always understand, and you're going to have to sort of figure it out. Now, what I would like you to do for your task for this particular lesson is just this. Loop through some sort of iterable, and if that item that you're looping through is one of the items in your list, print something. You can also do a very basic sort of example here and just loop through all the letters in a word if you wanted to. But the idea here is that you're using the for keyword, some sort of variable name, in an iterable, and then you can print whatever that variable is. Go ahead and give that a shot, and when you were done, let's head on over to that next lesson. Hello and welcome back. Let's talk about while loops. While loops are not like for loops whatsoever. So a for loop, if we open up the for loop example here, A for loop is going to loop through every item inside of some sort of iterable until it exhausts itself. And then it's going to just silently finish. And we don't have to worry about handling that sort of finish. In a while loop, we do though. And so a while loop looks like this. While something is true, do something. And so this can actually get a little bit dangerous here. So you're going to want to be careful with this. But what we can do is we can loop through something until we tell it not to. And we don't explicitly need some sort of iterable. And so as an example here, we can say, while number is less than or equal to 100, print that number. Now that number doesn't exist yet, so let's make it exist. Num is equal to 0. And so while num is equal to 0, or I said 1, but it should be 0. While num is equal to 0, print the number. Then what? Well, we have to manage this on our own now. So we can do num is equal to num plus 1. Basic addition here. So for that first iteration, it's going to say while 0 is less than or equal to 100, print that number, and then add 1 to that number. Then it's going to say, okay, well, num is now the number 1. It's still less than 100. Print the number 1. Make it number 2. 2 is less than 100. Print the number 2. Make it the number 3, so on and so on and so on. And so what we're saying here is eventually this number is going to be the number 100 or 101, and it's going to be a false statement. And so eventually, this is going to be false. And that was actually incorrect. Eventually, this whole statement is going to be false. And if it's false, it's not going to execute. We want it to execute for as long as we want it to execute until that statement, this statement here, becomes false. Let's go ahead and run this. Python while loops.py. And we can see if we scroll on up, it is just going and going and going. So it goes from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way down to 99 and 100. And so we can do something 100 times, 1,000 times, 10,000 times, 5 times if we wanted to. It doesn't really matter what the number is. The important thing is that eventually this statement becomes false. Now, what I want you to do is give this a shot, try it out on your own. And in the next lesson, I'm going to show you how we can break out of a loop or how we can skip certain numbers in a loop. All right, in the last 2 lessons, we looked at for loops and while loops. There is a way to break out of a loop or to completely bypass a loop iteration entirely. And so let's do 2 examples here. Let's do one with a for loop and one with a while loop, and we're going to use break and continue. So first we need to set up an example. So let's say items is a list of items, and we've got 1, 2, 3, 4, and 5. And so what we can do here is we can say for item in items. And if we were to print each item, we would get print 1, print 2, print 3, print 4, print 5. What we can say here is if that item is equal to 2, we can completely skip this. And so this continue keyword says anything below this is not going to get executed in the for loop. And at the bottom, we're going to print the item. And so it's going to go through the first item. It's going to be 1. It's going to print that item. It's going to actually compare that 1 is equal to 2. That's going to be false, so it's not going to continue. Then it's going to print that item. Then it's going to go on to that second iteration, and it's going to say is 2 equal to 2. That is in fact true. It's going to continue, and this is not going to execute. In fact, we could say if item is equal to 2 or item is equal to 4, let's go ahead and skip that iteration altogether. So it's only going to show 1, 3, and 5. So if we do Python break and continue.py, it's going to say 1, 3, and 5. So that is one example. I'm going to comment this out. And let's create another for loop example. For item in items. And then we can say if that item is equal to 3, break. And what break is going to do is it's going to completely get out of this for loop altogether. So now we can print the item, and it's going to print 1, 2, and then it's going to check to see if it's on item number 3. In fact, it will be eventually on item number 3, and we're going to break out of that loop. So 3, 4, and 5 don't show up at all. Let's save that and give this a shot, and it just says 1 and 2. And again, what that's doing is first iteration is 1. Is 1 equal to 3? No. Okay, so it's not going to break out. 2, is 2 equal to 3? Nope, so it's not going to break out. It's going to print that item instead. 3, is 3 equal to 3? It is. And so it's going to break out of this for loop altogether, and it's going to stop working at 3. And it's not going to execute 4 or 5. All right, let's move on to a while loop. We can do something like this. While num is less than or equal to 20. And let's make sure we have a number in here. That number is going to start off at 0. And we always need to increment our number. Number is equal to num plus 1. Then we can say, if that num modulus 2, so is equal to 0. So we're saying if, let's say the number 4 divided by 2 has a remainder of 0, then we're going to skip it. We're going to continue. And let's print that number, print that current number. And what this is going to do is it's only going to show every second number. And in fact, I actually have a logic bug in here. So before giving that a shot, let's increment that number first. Because what we're saying here is if that number eventually hits that continue, with the incrementer down here, it's never going to increment. So num is always, always, always going to be less than 20. We need to move this up. And so let's go ahead and give this a shot. And there we go. We're getting only odd numbers. 1, 3, 5, 7, 9, 11, 13, 15, 17, 19, and 21. Now, if you're scratching your head wondering how we got 21, it's because this number at one point was the number 20. We immediately added 1 to it, so it's now 21. And then it's going to say if 21 modulus 2 has a remainder of 0, then continue, otherwise print it. And that's how we got 21 in there. Interesting little thing. So now we're using a while loop, we're using modulus, and we're using continue. Let's go ahead and break out of a loop if a loop is reaching the number 13. So we can say num is equal to 0, while num is less than or equal to, let's give it some absurd number. Don't even know what that number is. Let's give it 1 million. Num is num plus 1, and then we can say if num is equal to 13, break out of this loop. Otherwise, print this number. And so when we see this, eventually this number is going to, or let's actually start at the very beginning. We have a while loop. While 0 is less than a million, then that 0 is then going to become 1, then 2, then 3 on every iteration. Eventually that number is going to reach the number 13, and when that number is 13, we're going to break out of this loop. And so let's go ahead and give this a shot. While num is less than 1 million, incremented on every iteration. If that number is ever 13, break out of it, and let's see what happens. We get up to 12. We get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It stops on the unlucky number of 13. Now, what I would like you to do is try out all 4 of these examples. Try a break and a continue keyword in a for loop and in a while loop. Also, if you ever get stuck in a while loop, you can always just cancel. So let's go ahead and type pass, and let's execute this. And you're going to see that my script looks like it's just loading forever. You can hit Control-C to cancel. And I'm going to undo that so that you have the source code later. Go ahead, give that a shot. When you're done, we're going to level up our coding skills with this thing called a function. All right, coder, welcome to the world of functions. Functions are how we can write code once and use it over and over and over again. So let's go over the basic syntax of a function. In JavaScript, it looks like this: function, some name, parentheses, curly braces. In Python, we use def instead of the word function. Then some name, parentheses, and a colon. And it's going to do something in there. Let's get rid of the JavaScript one because this is not a JavaScript course. And then to run the function, we do some name, and that's it. That's going to run the function for us. Now, this is not a very good function. It does absolutely nothing. Let's go ahead and print something. Print hello world. And let's run this function. So let's do Python functions.py, and it says hello world. And every time we copy this, it's going to print it over and over and over again. And so this idea stems from the idea of DRY, D-R-Y, and it stands for don't repeat yourself. And so you can write one set of code over and over and over again. Now again, this function is still not very useful, and we need to work with some sort of customization. So if we said hello, and we wanted to put a name in here, and that has to be an F string, well, this just simply isn't going to work. There is no name. It says name error, name, the function or the variable name is not defined on line 2. And that is, in fact, that is true. It's not defined anywhere. And so we can set the name out here. Name is equal to Caleb, and let's see what this does. Okay, cool. So we inherited name from out here. But what if we wanted to throw some sort of name in here, a different name? This is called an argument or a parameter, and we could do that. So let's get rid of this name and put name in here. And now if we run this function without a parameter in here, notice that these sort of have to match. And there's no parameter in here. We didn't specify a name. We're going to get some sort of error here. We get some name is missing one positional argument called name. So let's go ahead and throw a name in here. G-U-L-L-Y. That's Gully. Let's go ahead and run it. It says, hello, Gully. We could do any other name, and it's going to work for us. And so basically what we're doing here is we're saying we defined a function, then we executed that function, and that parameter in here, this name, is now available inside of this function. And we pass that in through here. So we can do 1 parameter, 2 parameter, 3 parameters. We can do 50 parameters, though please, if you're ever writing advanced code, don't use 50 parameters in your functions. That's very hard to read. I've seen some senior developers do that before. It's just a very bad practice. Stick to something basic. So let's say name and food. And let's say in here, we're going to say, hello name. Let's eat some, and then whatever that food is going to be. And so again, if we run this without that second parameter on line 4 here, we get some name missing one required positional argument, food. And so let's go ahead and change this back to Caleb. And let's eat tacos. And so all we're doing here is really matching how this looks. And so now we've got a function, first parameter, comma, second parameter. Now what's interesting about this, and this is a little more advanced, is if you just extract this, looks like a tuple, doesn't it? And in more advanced Python, we're going to be talking about args, arguments, and keyword arguments. And when you have arguments like this, it always comes in as a tuple. Now this is a standard variable. We can overwrite it. This is a standard variable. But what I'm talking about later is this thing called args. You're going to see that down the road. Probably in Python 201, or if you see it in the wild, you sort of have an idea of what people are looking at. And so when I write this now, it's going to say, hello, Caleb, let's eat some tacos. And that's because name is matching this first parameter, and this second parameter is matching food. Now, what if you wanted to add some sort of default in here? In case someone didn't add something, we can add a default value too. We can say food is going to be pizza. And so what this is saying is, this is now a required positional argument or a parameter. And so we have to have that. And food is not. Food is going to default back to pizza if we don't give it any sort of value whatsoever. If we completely ignore that it's even there, it's going to default to say pizza. So when we run this, it's going to say, hello, Caleb, let's eat some pizza. But the nice thing about this is just because that's a default doesn't mean we can't overwrite it. We can totally overwrite it. In the second parameter here, we can say oranges. And let's go ahead and run that. And it says, let's eat some oranges. Now, this is called a keyword argument. This is a keyword and it's looking for some sort of value. So you could also do food is equal to oranges. And this will work as expected. And that's really all there is to a function. And now we can add our if statements in there. We can add a while loop, a for loop. We can do anything we want inside of this function and it will execute every single time. So now we can say if that name dot lower is equal to Caleb, all lowercase, print welcome Caleb, And if this doesn't match anything, it's just going to print this one statement. If the name is in fact Caleb, it's going to print two statements. It's going to print welcome Caleb and hello Caleb, let's eat some whatever that food is, going to be oranges. And so let's go ahead and run this, and it says hello Caleb. Let's go ahead and change that. Change it to Jacob. And now we're using a name variable as a parameter or an argument inside of our function. We're lowercasing it. We're using a conditional statement. We're checking to see if it's Caleb, and we're using a print statement in there. Let's do one more fun little example. Let's do name is equal to none, and let's get rid of this. So we have two default values here. Name is going to be none, and food is going to be pizza. Let's just see what this looks like. It says, hello none, let's eat some pizza. Well, none isn't a person, but what we can do now is we can say if name is none, we can overwrite that. Name is equal to Zephyr. And then it's going to basically use that name again. So just leave some space for us there. And it's going to say that name, if it is none, is going to be Zephyr. And so this is a lot like setting the default here to be Zephyr. The only difference is really we're doing this manually. And so Python comes with default keywords, but we don't necessarily need to use them. We can fall back and use our own way as well. We can also do some internal workings as well. So we can say person type is going to be, let's say, a human at first. And this is just an internal variable. This cannot be set from outside of, or when we execute the function, person type just can't be set. And then we can say, if name is equal to Zephyr, we're going to change that person type to be a cat. And we can print that as well. Print person type. And so now we're making a fairly advanced function here. We've got a lot going on. Let's go ahead and run this. Python functions.py. It says it's a cat. And so now we have some internal workings of a function. But what if we wanted to store the result of a function in a variable? So some variable is equal to this, and then print the variable is some var. Now this simply isn't going to do anything for us. Let's lowercase that. It says none. And so what we're looking at here is if we have a function, def some function, and it doesn't return anything, it's always going to return none. So every function by default is none in Python. What we can say instead is return a value. And so let's comment out this example because that's getting a little unruly. And we can say thing is equal to some function, print thing, and this is going to say a value. And so now we have a function using the return keyword, and it's simply going to store whatever it returns, and it can only return one thing. It's going to return this one thing in here, and this is a lot like saying a value, just like that. Let's go ahead and execute this, and let's see that it works. And it says a value. So at this point in time, this is probably not super useful to you. Let's create a basic exponent calculator. So let's go ahead and comment that out. And let's do def exp for exponent num1, num2. And we can say the total is going to be num1, exponent num2, return the total. And now we can say something like big number is equal to exp, and then let's say 33 to the power of 6. And let's print that big number. Print big number, and let's execute this. And it gives us a very big number, whatever that number actually is. Chances are that's right, it is using an exponent, so it's number to the exponent of number 2. So, in summary, a function is defined with a def keyword, then we give it a name. We have unlimited parameters. We can have default parameters, or default values for the parameters if we wanted to, like we have up here. Then we can work with these variables inside of the function. And when we want to return something so that we can store it in a variable outside of this function, we can just simply use the return keyword and return whatever we want. And then to execute it, we simply do a variable is equal to, and then that function name, the two parameters that it's looking for, num1 and num2, and we can print out that big number. Now, what I would like you to do for your task is a very, very simple function. Functions are a weird thing to think about at first. So if you're brand new to functions, this is going to be a little bit interesting for your brain to wrap around. So just create something very basic like this and try to execute it like I have on line 28. And then go ahead and explore how to break it. So num2, you could change that name to anything else. Or instead of doing exponent, you could do a modulus. You could even try not putting it in a variable. You could try returning something like that. Either way, I want you to get some hands-on experience with this because functions are a major part of Python. There's just no way to avoid them. You have to write them. And the nice thing is, if we had another big number 2, we could do like 12 to the power of 12 if we wanted to. And now it's doing this math for us. Or if there's an if statement in there, it's going to execute that if statement. Or it's just going to execute the same code over and over again for us. And all we're doing is injecting small little variables in there to just tweak it just a little bit. So go ahead and give that a shot. When you're done, we're going to talk about a little more advanced subject called scope. Let's talk about scope. Variables that live inside of a function simply cannot be accessed from outside of a function. So let's create a function called def myfunc, and it's going to create a new variable in here. Name is equal to Caleb. And so far we've been able to write variables anywhere and access them anywhere. But inside of a function, when a variable is declared, it can only live inside of that function, and that's called scope. So if we try to print name, this simply is going to give us some sort of error. So if we do python scope.py, it says name is not defined, even though it is. Even if we run this function, it's not going to work for us. We're going to run this function. It's going to, let's maybe even return something. Let's make it a proper function. And we still see that name is not defined on line 6. And so it's trying to look for it, but really you can think of it like this. When code is inside of a function, it's zipped up. It's like, I just collapsed it here, but it's like it's being zipped up and you don't have access to that name. So you can pretend that it doesn't exist when it's inside of a function. When you have a variable inside of a function, you can use it any way you like. You can declare new variables, you can use variables from parameters or arguments or anything like that. But simply put, a variable that is declared inside of a function cannot be accessed from outside of a function. Now let's create another example here, where let's get rid of this, and let's print out whatever myfunc returns. And let's create a name outside of the function. Name is equal to Caleb. Now we saw that originally we got a name error. What this is going to do now is it's going to look outside of its function. So this is called scoping. So it's going to look inside of its function for the name. If it doesn't find that name, it's going to then look outside of that function. And if it doesn't find it outside of that function, it's going to look outside of that function. And if you come from the world of JavaScript, this is called a closure. So let's go ahead and run this, and we're going to see that it says Caleb. And what this is doing here is I've got a function called myfunc. I'm executing it. It's returning the name, and that name is being defined out here. Now, what if I change that name inside of the function? Name is equal to new name. What is this going to print out? Because I've declared it up here, it's accessible in here, in this entire function, but I've overwritten it with a new value. Is this going to print out new name, or is this going to print out Caleb? Let's go ahead and give this a shot. And remember, when you don't know things like this, it's always good to try it out. Try it out and then ask questions about how it works. And so you see, my function is returning new name. But what happens if I print name? Just name itself. Because again, it's declared here, it's being scoped into its function, and then it's being returned. So this one we know is going to return new name. I was looking at the wrong words there. This one's going to return new name because we're overwriting it in the function. But because we're overwriting it in the function, is it also going to overwrite this one? Let's go ahead and give this a shot. And it does not. And the reason for that, again, is because we are simply looking for a name outside of a function if it doesn't exist in the function. But hey, guess what? It does. It exists inside of this function. And so it's going to use this scoping. And as one last example, let's go ahead and comment this out. And so this is going to return Caleb, and name should also be Caleb as well. And we see Caleb. And so that is scoping. So whenever you see a name error that a particular variable is not defined, chances are it's just outside of the scope and you have to make it accessible somehow. And so if it's not accessible inside of a function, you can always make it accessible by passing in name and maybe giving it a default. But yeah, that's pretty much what scope is. So there's no task for this lesson, but what I want you to take away from this lesson is the idea that if name doesn't exist, or if any variable doesn't exist inside of a function, it's going to look on the outside of that function. So it's going to look everywhere else above it for that name. If it doesn't exist, then you're going to get a name error. Let's do this. Let's get rid of that. Try it again. We get a name error. Name is not defined. Put it back. And it says Caleb. So this is a tricky thing to wrap your head around, but whenever you see a name error, just assume that there is some form of scoping going on, or your variable simply is not defined. And chances are it's probably not defined where you think it's going to be defined, and thus we get into the realm of scoping. This is really important when dealing with functions as well. Now, moving forward, it's always a best practice to put your content inside of a parameter. Put your variable inside of a parameter, or I guess it's called an argument as well. Put it inside of a parameter and explicitly pass it in. It's very Pythonic to do this. In JavaScript, we don't do this. In JavaScript, we leverage closures a lot and it gets really messy. In Python, we don't like that. In Python, we really like when we can just pass something in explicitly. Alrighty, let's talk about a local server. This really doesn't have anything to do with Python 101, but it is a very fun, interesting thing that we can do. So in Python, we can set up a simple HTTP web server. If you've taken any of my previous classes and you've used Ajax and you've ran into some CORS error, or you aren't allowed to load data from somewhere else on the web, chances are it's because your file was being loaded from your browser. And so you had something like users/website.html loaded up in your URL. And, for the most part, that's going to work, but sometimes it doesn't. And sometimes you need a local server. So to run a local server, we just go over to our terminal here and we can type Python, or Python 3 if you're using Python 3, or Python 3.9 if you're using Python 3.9, -m http.server. And it says serving HTTP on port 8000. So if we open up our browser and we go to localhost port 8000, we're going to see all of our files show up. Now that may or may not be what you want. Let's open up the Hello World one. We can actually see the source code in there and the URL changes. It's localhost port 8000/helloworld.py. Let's go ahead and let's actually cancel that. Let's go ahead and create a new file in here. Index.html. And let's do HTML:5, tab, Python 101. Welcome to Python 101. And let's put that in an H1. And so now we can serve static HTML through Python. Now there's not a lot you can do with this. This is very basic. You can't accept GET or POST requests. You can't use forms and things like that. It is a very basic server, and that's why it's called a simple server. So let's go ahead and rerun this server. And when we head back here, we're going to see that index.html loads for us. It says, welcome to Python 101. We still have access to that old file. Hello world.py shows us our source code. That's cool. But now that we have an index file, it's loading as if it's a regular web server. And so this can be really good for just simple web servers. If you need to create, like, for example, a JavaScript project where you're making a random Star Wars character generator, you can use localhost port 8000. What's nice about that, if you know anything about proxying, and if you don't, you can just ignore this part, but if you know about proxying, then you can use the service called ngrok. And you can use this server to make your website completely accessible to the web using a URL that they give you, which is really, really cool. So now you have a simple web server running at any point in time using a simple web server, and people then can view your files or they can download your files. So this is pretty fun. This is actually not used in Python 101 whatsoever, but honestly, it doesn't belong in Python 201 or Python 301. So I thought I'd throw it in here as a fun little thing to do. And if you want to make the site accessible to the web, definitely check out ngrok.com. Oh, and lastly, if you want to cancel, you just hit Control-C to cancel. Once you're done having some fun with that, let's head on over to the next lesson where we learn about random choices. All right, let's take a look at creating random choices in Python. And this gets into using Python packages, which is really, really good to know about. It's a little beyond Python 101, but it's also, we're going to need it for our final project. And so this is a good introduction into Python packages. So what I have here is just my terminal. And if I type Python 3.9, this is going to give me my Python shell. And to create random choices, first of all, we need to import a package called random. This doesn't come default with Python. You have to actually import it. And so now we can import this and we can say random.choice, and then we can give it a list. And so let's give it a list of rock, paper, scissors. And it's going to give me rock. And it's just random every time. It just happened to be that rock showed up a few times in a row. Scissors showed up a few times in a row. It's just completely random. And so the syntax here is really easy. So if I scroll back on up, we have import random, and then we used random.choice. It's a function, so it has parentheses around it, and it only takes one argument. And that one argument has to be a list. It has to be some sort of iterable. And so I gave it a list, and it just gave me rock, paper, or scissors. And we're going to need this in our final project. So what I would like you to do is open up your Python shell, import random, and then type random.choice and give it a list. It has to be a list of choices, and then just keep executing it, like I did, and it will show you all the different choices. Or rather, it won't show you all the different choices. It will choose one, and eventually you'll be able to get all the random choices. Go ahead and give that a shot. We're going to need this in our project, which is coming up in our next lesson. All right, welcome to your project. We're going to make a rock, paper, scissors game where you play rock, paper, scissors against a computer. So you're going to need a few things for this. I'm going to tell you what kind of things you're going to need as a little bit of guidance, and then I'm going to let you write the code on your own. So first things first, you're going to need random. We learned about that in the last lesson. I straight up told you we're going to be using it in the project. You're going to need a while loop that runs forever until you tell it to stop. So you can just keep playing rock, paper, scissors until you win. You're going to need to use input to accept, well, an answer from the user, being you. So it's got to be rock, paper, or scissors. We're going to be using print statements, and we're going to be using print formatting. We're going to be using comparison operators, break, and continue. And with all of these things equipped in your tool belt, you can now create a very easy project, a simple rock, paper, scissors project. So what I'm going to do is I'm going to fade the screen out for a few seconds. I would like you to then pause the video and try this out on your own. Try problem solving this out on your own. You need to break it down into smaller sort of tasks. Everything in this project we have learned in this particular course in Python 101. And the idea here is you want to keep playing rock, paper, scissors until you win against the computer. So I'm going to fade out to black. You pause the video, give it a shot. If you get really stuck, just feel free to resume the video and you can see exactly how I go about doing this. Okay, let's create a rock, paper, scissors game where you play rock, paper, scissors against the computer. So first I'm going to save this as project.py. So first things first, what do we need? We need to constantly ask ourselves for input. So we're going to need some sort of while loop. So we can do while true, and we know that it's going to run forever because remember, it's going to constantly run while this is true. And then we need to ask ourselves, do we want to pick rock, paper, or scissors? So let's do my answer is equal to input, choose rock, paper, or scissors. Now, what happens if I don't choose rock, paper, or scissors? Well, we need to basically quit the loop and try again. So we can either break or we can continue. So let's do if my answer is not rock and my answer is not paper. And let's make that a little smaller. And my answer is not scissors. Then print, please choose a correct answer. And let's continue. And so this just ensures that our answer is always going to be rock, paper, or scissors. After that, if the code makes it past line 7, we know that the answer is either rock, paper, or scissors. And in fact, what we can do, just to make sure, we can say my answer is equal to my answer dot lower. Now we need the computer to make some sort of a random choice. It needs to choose rock, paper, or scissors. And so we need to import random, and we need to give it a random choice. So computer answer is going to be random dot choice, and you can choose from rock, paper, or scissors. Now we need to compare. We need to see if rock beats paper, if rock beats scissors, all that kind of stuff. And we can do a pretty big if, elif, else statement. So I'm gonna just shut that down a little bit, move that down rather. And we need to see if the computer's answer is the same as my answer. So we could say, if my answer is the same as the computer answer, print, you tied. And let's continue. Because once you've tied, you've tied. You just have to start over again. Then we can say elif my answer is equal to paper, and the computer answer is equal to, well, what does paper beat? Paper beats rock. We could say print, you win. And in fact, let's add a computer answer in here. Let's print the computer answer. F computer chose the computer answer. And where were we? If my answer is equal to paper and the computer's answer is equal to rock, not rocks, it's going to say, I win. Elif my answer is equal to rock and computer answer is equal to scissors, print, you win. Elif my answer is equal to scissors and the computer answer is equal to paper, print, you win. Now, every time we win, what do we want to do? If we want to quit the game every time we win, we break. So let's do break, break, and break. And if we don't win, or rather, if we haven't tied and we haven't won, the only other option is we've lost. So then you can say print, you lose, try again. And because this while loop is going to keep going on forever, if you lose, it's going to hit the end of this file, and then it's going to start back up at the top. Let's go ahead and give this a shot, and let's see if there's any typos or anything. Clear, Python, project, py. Choose rock, paper, or scissors. Let's do rock. Oh, I won. Let's try it again. Paper. I tied. Let's try scissors. I lost. The computer chose rock. Rock beats scissors. Okay, now what happens if I want to quit? Well, I can hit Control C, and that gives me this gross little keyboard input error. What I can do instead is, if my answer is not rock or any of these, then please choose a correct answer. I can also do one more if statement in here. I can say if my answer is equal to quit, simply break. And let's try this again. Now it's going to ask me for rock, paper, scissors. I could type quit, and it didn't work for me. There we go. I have to actually type quit without a space at the end. So that space at the end, very, very important. And that is how we create a rock, paper, scissors game. And so really all I did was I executed it from the top to the bottom. So I asked myself, do I want to play rock, paper, scissors? Yes. So I start a while loop. Then I ask myself the actual question, do I want to choose rock, paper, or scissors? And then whatever that answer is, I made it lower. And then I said, if my answer is equal to quit, breakout. Get out of here. I don't want to play rock, paper, scissors anymore. Then I also checked to see if my answer was rock, paper, or scissors. If it's not rock, paper, or scissors, it's going to tell me to please choose a correct answer, and then it's going to continue. So it's going to skip all this stuff down here, and it's going to start at the top again. Choose rock, paper, or scissors. Then we're going to generate a random computer answer on every single iteration. So this is going to change it every single time. So it's not going to be rock or paper or scissors every time. It's going to be completely random. It's going to be rock or paper or scissors. We don't know. And then we're going to say, oh, the computer chose rock, paper, or scissors. We're not sure, but it's going to print it out for us. If my answer is the same as the computer's answer, we tied, continue, and basically don't execute anything else. Now, technically, we don't need that because this if statement was already called. And so because this if statement was executed, this if statement, the elifs and the else statement are not going to be executed. So it's going to jump back down to the bottom to line 30. There's nothing there, so it's going to restart automatically for us. So that was actually optional. Then we said, well, if the answer was not a tie, then what do? We say, we check to see if my answer was paper, and if the computer's answer was the losing answer. Paper beats rock, so I win. Break. And that just gets out of the whole game entirely. Then I check to see the same thing, but this time I'm checking to see if I chose rock, and if the computer chose scissors. If so, rock beats scissors, I win. And then break again. And then lastly, we do the same thing. If my answer is equal to scissors, and the computer's answer is equal to paper, I win. And then break out of the game again. Otherwise, in every other scenario, if it's not a tie, and if I don't win, I've lost. And that's saying you lose, try again. And because it's not breaking out of this loop, it's going to go back up to the top and ask you again. And that is your rock, paper, scissors project. Now, there are ways to make this significantly more friendly. We're doing a lot of ands in here. We don't necessarily need to do ands in here. We haven't learned about the in operator. So if you want to learn about the in operator, the in comparison operator, definitely go and check that out. You can check to see if, for example, my answer was in a list of rock, paper, or scissors, instead of writing all of this out. We could also merge these three together, these three elif statements. We can merge them all together and say, if my answer is paper and the computer's answer is rock, cool. Or my answer is rock and the computer's answer is scissors, or my answer is scissors and the computer's answer is paper. Then I win. We could do one big elif statement here. So there's a little bit to gain here. I would definitely suggest try out my code and then just try making it more efficient. Try merging all of these elifs together. Learn about the in operator. Learn how you can compare a string to an array, for instance. But yeah, that is the entire project. That's all there is to it. So feel free to download this code and use it whenever you want. Let's get started by talking about the in operator. And so in Python 101, we learned about comparison operators, and I just made this bigger. And a comparison operator simply looks like if something is equal to something else. Now, if you took Python 101, we had a little project where we wrote a rock, paper, scissors program. I'm just going to change this to a Python file here. And we saw something like if my answer is equal to rock, and that's actually does not equal rock, and my answer does not equal paper, and my answer does not equal scissors. If I make that just a touch smaller here, exit the program. And that's all it did. Now, there's a better way to do this because we know that the three answers that we're comparing to, rock, paper, and scissors, are all going to be, well, they're going to be the same. They're never ever going to change. So what we can do is this in operator, this in comparison operator. And so what I'm going to do here is view my terminal. And if I type Python 3.9, because that's the version I want to use here, I can simply write the in operator to compare one thing against an array or a list. And so I could say a list of names is equal to, and let's just make this way bigger here. A list of names is equal to Caleb, John, and Gully. And so if we do names, or if we do type of names, we're going to see that this is a list. And it's supposed to be names, names plural. There we go, that's a list. We don't see anything new. We should be familiar with the data type of a list already. But what if we wanted to check to see if a variable or one name is in a list of names? Well, currently what we have to do is for name in names, if my name, whatever that variable is equal to the name, print, this is the name. And so this is kind of honestly no way to live your life, because what if your list, what if your array is really, really big? What if you have 1,000 items in there? Then you have to iterate over 1,000 different items just to find out if something is in there. Python has this built in. So what I'm going to do here is Control-C just to cancel. And I can say Caleb as a string in names, and this is going to come out as true. I could also say the same thing with a lowercase k, and this is going to be false because our names has Caleb, John, and Gully. But remember when we're comparing strings in Python 101? A string with a capital K is not the same as a string with a lowercase k. It's not the same with a J or a G or any other letter. The fact is that it has to be an exact match. And so in the first example here, this is an exact match. And what I can do here is, if I just type that out once more, I can say if Gully in names, print Gully is in the list of names. And we see that Gully is in the list of names. And so this is a really, really easy way to check to see if one answer is in a number of answers, a possible number of answers. And so if we go back to our example here, I'll just move that down a little bit and make this a wee bit smaller. If we go back to this answer here, we're going to say if my answer is not rock, if my answer is not paper, if my answer is not scissors. What I can say instead is if my answer, whatever that is, and instead of equal to or equal to, we can say in a list of options. And so we just need to pass this in a list, and we can simply put in a list of options. And let's actually make these variables exist. So we can say my answer is equal to rock. And let's make the options to be a list of rock, paper, and scissors. And now we can say if my answer, rock, is one of these three, then do something. We can say print, rock is one of the possible options. Now let's go ahead and save this file as the in operator. And I'm going to Just get out of that. And I'm going to type Python in operator.py. And it says rock is one of the possible solutions. Now, what if I changed that? What if I changed it from rock to something else? Literally anything else. We could say something underscore else, and we're going to see that this no longer prints anything for us. And that's because if there were an else statement, this would be executed for us. Print, wrong answer, try again. And let's try this out, and we see wrong answer, try again. Now, where this gets a little bit more powerful is, and again, we touched on this in Python 101, so this is a little bit of a recap. Instead of saying my answer is equal to a hard-coded value, we could say input, what is your answer? And if that answer is equal to rock, paper, or scissors, then it's going to say that one of these is an option. We can say that option is a viable option. Otherwise, it's going to say wrong answer, try again. So let's save that and let's give this a shot. It says, what is your answer? If I type in rock, no, let's not do rock. We did rock already. Let's do paper. That option is a viable option. Let's try this again. It says, what is your answer? My answer is going to be Python. Python, I guess, because I put a Z in there for some reason. And it says, wrong answer, try again. And so the in operator, just in, simply says, is the thing on the left inside of the iterable on the right? If it is, if it's true, then execute this conditional statement. If it's not, then it's false, execute the else statement. Or originally we had nothing, so don't do anything at all. Now, if I were to comment that out, we can do the same thing with a dictionary. So let's give a value, not a value, but a variable called key. And this is going to be name. And we could create a person dictionary. Name, Caleb, profession, coding teacher. And then we can say if key in person, print, name is a valid dictionary key in the person object. So let's go ahead and give this a shot now. Let's type in Python space in underscore operator.py, and it says name is a valid dictionary key in the person object. What if we changed key here? What if we change it to just something that's missing? Nothing happens. And that's because what this is looking for is the key. And remember, in a dictionary, we have a key value pair. It's looking for that key in there. And so person with a key of 404 doesn't exist, but person with a key of name does exist. And so we can use the in operator in a dictionary as well. We can also use it in a tuple. Now, what I would like you to do to try this out, to get a little bit of hands-on experience, is I want you to use the in operator on a set. So a set is a Python data type. We learned about this in Python 101. And I want you to use the in operator on a set, not a dictionary, not a tuple, not a list, but a set. I want you to see if that works for you, if it does or does not work for you. Because at this point, we're getting into intermediate level Python. It's time that we start exploring and stop relying on someone showing you everything that can or cannot happen. It's time to start exploring and learning on your own. And so it's really important that you can do this because eventually you're going to have a job, and in that job, they're going to ask you to create some sort of unique feature, and there's not going to be a tutorial for it. There's not going to be a person to hold your hand for it. You're going to have to sort of experiment a little bit on your own and come up with your own solutions. And this is just really good real life experience when it comes to just experimenting. And you're not going to break anything, so feel free to experiment. And if it doesn't work, it doesn't work. If you get an error, you can learn what that error is all about. But go ahead and give this a shot. Say if key is in some sort of set data type, then just print something. That's all we have to do. Let's take a look at the not operator. So we learned about conditional statements, and we said something like, if something is equal to something else, do a thing. And that's cool. We also learned about this. If something does not equal something else, do a thing. But what if we don't want to simply write all of that out? Well, we have a shortcut. We can say if something is true, whether that string is true, the dictionary is true, the list is true, the Boolean is true, it doesn't really matter. If something is true, then do a thing. But what if we want to say if something is false? So let's go ahead and set up an example here. We're going to say my thing is equal to true, just to set up this example. If my thing, print thing was true. And if we execute this, we can do Python not operator .py, and it says thing was true. And that's because it really boils down to this. Now, what if we wanted the exact opposite? Well, currently, we have to do this. We have to write pass and then do an else statement. Print thing is not true. And let's go and change this to false, just so that we can make this execute. So thing is false. This is not going to happen. The else is then going to get executed, and it's going to say this is not true. So if we run this again, sure enough, it says this is not true. Now, this is the exact same thing as saying is equal to false, which is the exact same thing as saying is not equal to true. And let's just clean this example up and run this once more. This is going to say this is not true, because false is not true. In fact, this is not true. The statement is true because it's saying false. Is that the same as true? No? Okay. Well, then it's a true statement. And this is where it gets a little bit confusing. So in terms of Python, we like to shortcut things whenever possible. And we just simply say, if my thing is equal to true, print a statement in here. Now, when we execute this, we're going to see that this simply does not run. This doesn't execute anything whatsoever. What we can say instead is the not operator. So in other programming languages, you're going to see an exclamation mark in front of your variable. You see it a lot in PHP, and you see it a lot in JavaScript. In Python, we don't do that. In Python, we like our code to be nice and readable. So we don't want crazy little symbols all over the place like we have in JavaScript these days. We simply say, if something is not true, and it's literally making a sentence for us. If something is not, and it's always looking for a true value. So if it's not true, aka if this is false, print a statement in here. Let's go ahead and save this, and we're going to see that this now prints out a statement that says, print a statement in here, as we expected. Now let's go ahead and create one more example. Name is equal to Kane Eski. We can say if name not in. Look at this. Now we're mixing the in operator with not. And we have to give us a list of names. Caleb, John, Gully. So if Kane Eski is not in a list with these names in it, print Kane is not part of the club. And when we run this, first of all, we're going to see this print statement up here, so we can just ignore that. But then we're going to see the print statement on line 9. And sure enough, the original print statement shows up from line 4. And then from line 9, it says, Kane is not part of the club. And so what we're saying here is, if the name is not in this particular list or array of names, do a thing. And with the not operator comes a lot of power. We can now check to see if things are the opposite. We weren't able to do that in Python 101. Python 101, we had to take the long way. In Python 201, intermediate level Python, we need to know the not keyword. Is something not true? Is something not in another list? Is something not something else? Now, one thing to keep in mind is typically when we're comparing things like strings, we could have name1 is equal to Kane, name2 is equal to Caleb. Typically, we do not do this. We do not write if name1 not name2 print different names. Because this just doesn't really make sense. If name1 is not name2, I mean, yeah, there is a way to compare using the is operator, like that, but we actually don't do it that way. The is operator is a special one. The is operator means it's comparing pieces of memory, not just the value, which could be Kane or Caleb. And so what we usually say is, when we're comparing strings, if name1 is not name2, and we do it with this operator. But when we're working with the not operator in a list, we put it in the middle. And when we put the not operator in front of something, we're checking to see if it's false. And so if you literally read this, just like a regular sentence, it makes a lot more sense. If something is not true, print a statement. If the name is not in a list, do something. And if one person is not the same as a second person, do another thing. And that is the not operator. Now, what I would like you to do is I want you to do the first two examples here. So let's get rid of this and just do the first two examples. Try checking a Boolean and then try checking a list like this. Make sure you use the not operator in both situations. And the goal here is not to become an expert at the not operator, because it's a pretty easy thing to learn for the most part. The idea here is to simply get some hands-on experience learning how opposite code works. If I'm not part of a club, I can't enter. If I'm not rich, I can't buy a yacht. If someone enters some user input and it's empty, that would be false. So you could say, if not user input, then you can exit the script or tell them to enter more content or re-enter the script. So go ahead and try that out. Again, the goal here is just practice. We just want to practice, practice, practice. That's how you're going to get good. You just need to practice, practice, practice. So try this out, give it a shot. And if you get stuck or this explanation wasn't good enough, feel free to leave a comment down below or in the Learning to Code Facebook group. I'm always there to help out. In the next lesson, let's go ahead and talk about reading files. All right, let's talk about how we can read files. And so we open files in Python with this thing called a context manager. Now, we're not going to get into the details of a context manager too much. It is a little bit of a different way of opening a file, especially if you come from a different programming language. But it is also very memory performant, meaning that you can't accidentally break your computer. And so reading files is as simple as saying with open your file name, R for read, as file, and then we can do something like print file.read, and that's it. That's all there is to it. Now we actually need to create a file in here, so let's go ahead and create a new file, and let's call it readme.txt. Hello from Python 201. That's what this readme is going to say. And so what we're going to do here in this readingfiles.py file, we are simply going to open up that readme file and print out whatever is in there. And so we could say with open readme.txt, that's the file name, comma, R stands for read, as, and then we give it some sort of variable name. We could call it file. We try not to use F anymore because F is sort of short for an F string, so we don't want to get that too confused in Python. So we just write something like file or CTX for context or something like that. Doesn't really matter, it's just a variable name. And then we could say print file dot, and you can see that VS Code is already trying to autofill things for me. So if I just go on down here, I can click read, and this is a function, this is a method. It's actually going to perform some sort of logic, and so it needs those parentheses. Let's go ahead and save that and run this file in our terminal. Let's do Python reading files.py, and it says hello from Python 201. You notice there's actually an empty line in there too, and if we go back here, I'm actually quite certain that there's going to be an empty line too. And yeah, there it is, empty line 2. This is a new line. Let's go ahead and save that. There's an empty line 3. Hello from Python 201. This is a new line. And that's really all there is to reading files. Now, here's the thing, is when you are reading a file or when you're dealing with files, this context manager using the with keyword simply means we don't have access to file outside of this indentation. So if we comment this out and we type pass and then we try to print file.read, let's see what's going to happen here. It says value error, IO operation on closed file. It's trying to read this file, but it's been closed already. So basically what Python's going to do is say, with the readme.txt file open as a reading status, not a writing status or anything like that, just a reading status, it's going to assign that to a variable called file. And then that file is going to be scoped. That file variable is going to be scoped to this indentation here. And then when it gets to the end of the indentation, which it does on line 5, it's going to close that file automatically for us. So we don't have to worry about closing the file at all, ever. Python will do that for us. This is a safe way to open your files. Now, what I would like you to do as a little bit of homework here is go ahead and create a new file called readme.txt and write this out. Do with open and then your file name, comma, R for read as some sort of variable name, and then print that out. And I'm going to clean this up because we don't need that. And then all we do is that variable name, I just happen to call it file.read, and that's going to read the file out for us. So go ahead and give that a shot. Feel free to pause the video right here. There's one more thing I want to show you, but I would like if you could pause the video right here and just try this out. Now, there's one more thing we can do. If we want the contents of this file stored in a variable that's accessible outside of the with keyword here or the indentation here, we could simply say something like content is equal to file.read. And then down here, we can say print the content is content. And when we try this, we're going to see that this works. It says the content is hello from Python 201. This is a new line, and there's an empty line in there. And so now we have access to basically the entire contents of that file, but outside of the context manager that we opened with the with keyword. Now, why is this important? Well, this is important because we have a context manager. We stored the contents of the file in a variable called content, and then behind the scenes, Python closed this file. It did it for us, so it's not using too much memory. It's trying to be as efficient as possible, and because frankly a lot of people forget to close their files, this is a safe way to do it. And then we can access that content variable outside of the context manager. Now, I would also like you to give this a shot. So there's 2 tasks for this particular piece of homework. One is to open a simple txt file and then print it. And another one is to assign the content of that file that you're opening to a variable and then access it outside of the context manager, the with statement, including the indentation. Just make sure it's accessible from outside of that. Go ahead and try that out, and when you're ready, I'll see you in the next video. In the last lesson, we looked at how we can open files and simply read them, but we can also write to files as well. We can create brand new files. And so let's go ahead and create a brand new file from scratch using Python. And so it looks like this, with open, and then your file name. So let's say writing files.txt. So this is the writing files.py file. We're going to do writing files.txt. We're going to create that file. And then in the last lesson, we used R for read. In this lesson, we're going to use W for write as file. So now we have a context manager. So this file is only ever going to be open for as long as we're indenting our code here. Then we can say file.write hello from Python 201. Now let's go ahead and execute this file by typing Python writing files.py, and we're going to see a new file appears over here on the left. And look at that, writing files.txt appears. Boom, it says hello from Python 201. Now what happens when we run this again? Let's write hello from Python 201 a second time, save that, and let's execute this. Now, do you think this is going to append to the writing files.txt file, or do you think it's going to overwrite it? So is it going to say hello from Python 201, hello from Python 201 a second time? Or is it simply going to say hello from Python 201 a second time as one individual line in this file? These are fun little experiments that we can have while we're learning Python. Let's check this out, click, and it overwrote the entire file. Now, if you ever want to append to a file, that's really easy. A stands for append. We do A, and this is going to be a second line. Let's go ahead and execute this. Check our writingfiles.txt file, and it says, oh, it's actually not a second line, but it did append to the end here. So it went right to the very end of the file and it wrote more. What we actually want to do here, and this is a good example, I'm really glad this came up, is we can do /n. And so we don't actually see these in files, but in this file here where that colon is and it goes to a new line, there's actually a hidden character in there. It's a /n for new line. And we can write that new line in here. We can also add a new line and a tab /t. This is tabbed. Let's go ahead and execute this and see how this turns out. So we have hello from Python 201. A second line. This is because I actually messed up. I'm not going to edit that out. I want to show you that even seasoned programmers like myself will make mistakes. It's totally normal. A second line because we ran that a second time. And a tab in here. You notice it's not spaces. This is actually a tab. And it says this is tabbed. So now we can write files. And with this, we can take user input and we can write files directly from user input. But let's not jump that far ahead yet. In the next lesson, let's go ahead and read multiple lines at the same time. So how do we open this file? But then how do we just get this line and then this line and then this line? How do we do that? But before we head on over to that next lesson, what I would like you to do as your task is open a context manager using the with keyword, open a file, name it whatever you like. Use the W writing property, so W stands for write, we just put W for short, as some sort of file, and then that context manager file dot write, and then a new line, and you can put a /n for a new line in there if you want, or a /t, and then when you're done that, try appending to that file. So writing is going to overwrite the file every single time. A is going to append to that file, add it to the end. Go ahead and try that out. And when you're ready, let's take a look at how we can read multiple lines at once. Okay, welcome. Let's take a look at how we can read multiple lines at once. Now you might be thinking, well, why is this important? But if I gave you a list of 100 emails and I wanted you to find the one that has my name in it, how are we going to do that? And this is a lot like scraping data from the internet, which is a very, very common thing. So before anything, let's go ahead and create a new file. And this is just going to be called emails.txt. There's going to be email1 at gmail.com, email2, email3, and then let's put Caleb at gmail.com. Let's put John at gmail.com, and let's put Gully at hotmail.com. So we have 6 email addresses in here, and we want to try to figure out if, let's say, Caleb at gmail.com is in here. How do we do that? Well, first we need to open this up. We say with open emails.txt. Let's just read it. We don't need to write to it or append to it as emails. And what we can do here is emails.readLines. And if I print this out, we're going to see that this is going to look very, very familiar. So I can type, let's clear that out. I can type Python reading multiple lines.py. And would you look at that? This all of a sudden is an array. So the first item here is email at gmail.com, email2, email3, Caleb at Gmail, John at Gmail, Gully at Hotmail. This is an array. We can now work with an array. This is exciting because we can take nice shortcuts here. So let's go ahead and throw this into a variable called emails. And we don't have to work within that context manager anymore. Its job is done. We can now access all these emails as an array or as a list, as we call it in Python. We can access all of these emails in a list in a variable called emails. As simple as that. So now we can say, for email in emails, print Looking for, let's say, no, let's look for a Hotmail account. Looking for a Hotmail account. Then we can say if Hotmail is in this particular email, we can use the in operator to check to see if a string is inside of another string. Print the entire email. And so this is going to filter out all of the emails in a file and give us all the ones that have Hotmail in it. Let's go ahead and run this code, and we're going to see, looking for Hotmail account, looking for Hotmail account, looking for Hotmail account. Oh, look at that. I found Gully at hotmail.com. Let's go ahead and delete that print statement because that's not useful. Let's say we just wanted all the Gmail accounts. So this is going to filter out the one that said Gully at hotmail.com. We run this, and email 1, email 2, email 3, Caleb, and John. Now, what's up with that spacing? Well, that spacing is because if I scroll back on up, you notice that /n. And we talked about this in the last lesson. /n means new line. And so what we want to do here is we want to take this email and we simply want to trim it. Now, in other programming languages, we use the word trim. In Python, we use left trim or right trim. And we don't call it trim at all. In fact, we actually call it strip. So rstrip. And all that's going to do is take out those lines in there. So if we run this again, we're not going to see all those extra spaces. And in fact, that's actually not where we want it to be because we're printing it. This is not going to print anything out for us. We want to change what's being exposed in our terminal. So we do rstrip here. And when we run this once more, let's get rid of that hover there. We run this once more. There we go. It's getting rid of that extra line for us. And again, the reason that's happening is because if we print all these emails, we're going to see that this array here, this list, this Python list, has /n at the end. And that's because at the end of each line, there is a /n. It's an invisible character. We don't see it, but it is there. And that tells the program, that tells the computer that there's a new line here. And so all we're doing is saying, hey, instead of having /n there, strip it out. Now, what I would like you to do as your task is something a little bit easier. Try just opening a file called emails.txt, throw a bunch of emails in there, make sure it's readable, and then I simply want you to loop through every email and print the email. Try this out. And if you notice you have extra lines in there, try using rstrip. That's simply going to get rid of the /n at the end of every value. Go ahead, do me a solid, try that out. It's not gonna seem like this is actually super useful at the moment, but when you get into web scraping, which is what Google does, Google scrapes every single website on the internet and indexes it in a database. It's looking for strings inside of strings. It's looping through every single page out there. So instead of looping through every single email, it could be every single website. And then it's going to do a thing. And that could all be stored in a single file. So that's a fun real world example. Yeah, definitely try it out. And when you're ready, let's head on over to the next lesson where we actually ask a user for some user input and then create a file that's then going to be executable. Okay, welcome back. Let's talk about executing files, or I guess creating files from user input. And so the idea here is that you can ask a user for some form of input, and then you can create a file out of that. And with that file, you can add some content in there as well. So let's merge all the experience that we have with reading and writing and appending files into a program where you can basically create your own form of catalog or contact book or address book. So first, let's ask for a file name. File name is going to be input. What is the file name? And let's also ask for content. Input is equal to enter the content, whatever that content is going to be. Then we can say something like with, we're opening a context manager here, open that file name. We're going to write or overwrite it every single time as file. Then we can say file.write the content. Now, if we try this out, Python executable user files. It's going to ask me for a file name. So let's put zzz.txt just so it shows up at the very bottom here. It's easy to spot. Enter some content. Hello, my name is Bob, and I like to code. Okay, looks like it did nothing, but hey, check that out. zzz.txt showed up, and boom, my text is now in there. Now get this, we can actually start making this a lot more enjoyable for the user. We could say, open file is equal to input. Would you like to read this file? And this should take a yes or a no. So we could say if open file is in Y or N, then we can do a thing. We say if open file is equal to N, do nothing. Or we can say if the open file is equal to Y, let's go ahead and open this file now. So we can say with open that same file name from above with reading properties as file print file.read. And so the whole script looks like this. We're asking for a file name. We're asking for some content. We're then going to write that file name with content inside of it, and it's completely dynamic. It's up to the user. Then we're going to say, would you like to open this file? Yes or no? If open file is in a list of either Y or N, then execute this code. If open file is equal to Y, then we want to open this file and print that file out. Let's go ahead and give this a shot. Let's do yyy.txt is the file name. Enter some content. Content is king. Remember when people used to say that on social media? Content is king. And would you like to read this file? Let's type Y. And it prints it out for us. It read that file for us. And that's exactly what's in yyy.txt. Now I'm going to delete this file. I'm going to delete this file as well. And I'm going to leave this source code with you. Now I want you to try this out. Just try out lines 1 through 5. You don't have to worry about lines 7 through 11. We're just getting fancy there. We're basically showing off our skills just because we can. Which is a very programmer thing to do. We like to do that. But try this out. Ask for a file name, use some user input. Ask for some content, use some more user input. And use a dynamic file name. And dynamically write some dynamic content. And then make sure that file actually shows up where you think it's going to show up and open it up. Make sure that it's doing what you expect it to do. And if everything is looking good and looking right, let's move on to that next lesson where we talk about functions inside of functions. Because, surprise, surprise, everything in Python is called an object. Yeah, it's a mind-blowing concept, but we can nest things within nest things, and you can actually see it here. We nested a with statement inside of an if statement inside of an if statement. This can go on forever. It's not performant to do that forever, but we can do that forever if we wanted to. And functions are no different. We can have a function inside of a function inside of a function. So the next lesson, we're going to take a look at functions and some of the weird scoping that happens inside of that. Let's take a look at functions nested inside of functions, because in Python, we can do that. In Python, everything is called an object, and that means functions inside of functions are objects, files are objects, packages are objects, everything's an object. You get an object, I get an object, we all get an object. But in this course, not in this course, but in this lesson, let's take a look at scope and how it affects functions inside of functions. So let's create a function. Let's call it thing1. And then we can have a function inside of this. And let's just say print welcome to thing1. And let's tighten that up just a quick sec there. And let's have another function here, thing2. Print welcome to thing2. And to execute this, inside of this function, or rather to execute thing2, we simply execute it inside of thing1. So we say thing2, execute it, and then when we call thing1, this is going to execute, it's going to print, it's going to then register this function and the code inside of this function, and then execute that function inside of it. And so now we have two functions in one here, and it's really only required to call one of them. So let's go ahead and save this. And let's go to View, Terminal. And let's type Python executable user files. That's not right. That is, I gotta undo that. All right, so I just changed the name of that file there, so we're not overwriting the file from the last lesson. So what I want to do here in my terminal, type Python functions inside of functions. And we're going to see it says, welcome thing 1, welcome to thing 2. And that's, again, because if we separate this, it might make a little more sense to our eyes. But thing 1, well, we know that's a regular function. Thing 2 is then going to register, or be registered, inside of thing 1, and then we executed it. Now, if we didn't want it to be executed, well, why would we write it at all? But that's beside the point. We could just simply not execute it inside, and this is simply going to say, welcome to thing 1. So that is a function inside of a function, and ultimately that is what is called a decorator. A decorator, something like that. That is the premise of a decorator. We'll talk about decorators probably in a future course or a future module, but that is basically what a decorator is in Python. So now let's take a look at scope. Let's say thing 1 takes a name, but thing 2 is not going to take a name. So we could say, welcome to thing 1, comma name. And how are we going to pass thing 2 that name? Well, we could also do this. We could say name, and then we could say name in here. And then if I said Jacob, this is going to say welcome to thing 1, Jacob. Oh, we need name in there as well. And so it passes the name along, but honestly, having to type that same variable name over and over and over again is irritating. You see how many times I have to type name here? The nice thing about Pythonic scoping is if it doesn't find a name inside of this function, if it doesn't find this particular name, and this could be called literally anything, but if it doesn't find that variable, that parameter, that argument inside of its function, this is going to look outside of the function. It's going to look into thing 1 for a variable called name. And so let's go ahead and test this out. And let's not pass in name whatsoever. And so thing 2 is going to say welcome to thing 2. It's going to have a name in there, but we're not actually passing anything in. And so we see this a lot in the world of JavaScript, but we don't see this a lot in the world of Python. Let's go ahead and execute this, and we're going to say what we're going to see that it says welcome to thing 1 Jacob and welcome to thing 2 Jacob. And that's because even though we didn't pass in explicitly the name parameter, what it did was look for a name inside of this particular function. It didn't find it, so it looked just outside of that function. It found it inside of function thing 1. And the nice thing about this is it's scoped so that if we tried to print out here, print name, it's not going to exist whatsoever. In fact, this is going to throw us an error, name error. The name is not defined. And that's the nice thing about functions and scoping with functions is that once you have a function, if you have a nested function, you can use all of the same variables from that original function. And that original function, i.e. in this case, thing 1, is not going to leak out any of its parameters or any of its arguments. And so that keeps your namespace nice and clean. So we don't have to worry about name being registered and magically or mystically doing something when simply it doesn't exist. All we've said was, basically, if you package this up, you don't see name is equal to anywhere in here. It doesn't exist out here. And that is Python scoping. Now, that's just regular Python scoping. That's just how Python works. If it can't find a thing, it looks just outside of that thing. And as a recap, functions inside of functions is really you just declare a function, declare a second function inside of it, or a third or a fourth or fifth function inside of it. You can do a thing, you can return a thing, you can do pretty much anything you like inside of that second or third or fourth or fifth nested function. And you can just keep nesting away if you want to. Just you have to remember, whatever function you register, you have to execute as well. And so if you're thinking, well, why would I even do this with one print statement? Honestly, you wouldn't. But if you had 10 lines of logic in here and you wanted to reuse that logic 2 or 3 times inside of thing 1, you would register that as a sub-function. Now your task for this lesson is to give this a shot. Create a function, nest a function inside of it, execute the nested function, execute the original function. And make sure you pass in some sort of argument or some sort of parameter that gets used in both the original function and the nested function itself. Go ahead and give that a try. When you're ready, let's head on over to the next lesson where we talk about making simple API requests. Let's go ahead and make a simple API request. All right, in this lesson, we are going to need to use a package called requests. So first of all, let's try this out. Let's type Python to get into our shell, Python, if I can spell that. And then we can just type import requests. And if you don't see any errors, then you are good to go. We can proceed. We can use requests. If you see an error, something like this, import requests to, if you see a module not found error, then we have to go ahead and install requests. Now, if we have to install requests, that's fine. We can do that. Let's just quit our shell here. And you're going to need to have pip. Now, you should already have pip installed on your computer. If you type pip-v, it will tell you a bunch of stuff in here. And my pip is using Python 3.8. Now, if you do not have pip installed on your computer, if this command doesn't work for you, head on over to the lesson where we install pip. And we talk about packages and things like that, and then come back to this one. So that's a few lessons ahead, and then just come on back. But modern versions of Python, if I recall correctly, comes with pip by default. So what we can do here, assuming you have the requests package or module, you can import requests, and then you can simply say req for request is equal to requests.get, and then some URL. So let's do https caleb.io, and we can print the status here, x.status code, and not x. I'm used to typing x, it should be rec. I just changed the variable name there. Print rec.status code. And let's go ahead and give this a try. Python simple API requests.py. And it gives me a 200. Now a 200 status in HTTP codes means the site is up and running. Now at this point, you can make a site monitoring program quite easily. We could do something like this. Let's go ahead, comment that out, and we can do import requests, import time, while true, req is equal to requests.get, and then your website, so https courses.coding for everybody.com, print rec.status code, and then we can say if that rec.status code does not equal 200. We could send an email, we could alert, we could break out of this script, we could do anything we want. So we're just gonna pass, but ultimately this would ideally send an email, send a text using Twilio API, something like that. Email me or text me, something like that. And this is going to run very, very quickly over and over and over again. So we don't want to spam our server with requests. Instead, what we want to do is make one request and maybe wait for like 60 seconds. And so we could do time.sleep 60 seconds. And so once a minute, this is going to make a request. But just as an example, let's lower that down to like 3 seconds. And let's run this again and see what happens. 200. 200. So we're going to see that this is constantly polling my site to make sure that it's up all the time. Basically, we just created an uptime program or an uptime monitoring program in like 7 lines of code with Python. And so to cancel, all I did there was Control C. So I'm going to actually comment out this one. You can check out that source code if you like. And I'm going to uncomment the original one because that's all we really need to do. For this particular lesson, all we need to do is this. And this is a simple API request. In fact, actually, this is hardly even an API request. This is more or less just an HTTP request, but in Python, it's so close to an API, it's basically an API request. In the next lesson, we're going to take a look at making an API request to an endpoint that actually accepts JSON, or not accepts, but returns JSON, and how we can turn that into a Python dictionary and work with that data. But for now, go ahead and give lines 1 through 4 a try. Just try it out, have some fun with it. See if you can get a different status code from a different website. And if you get a different status code, something that's not a 200, feel free to go and research what that status code means if you're not familiar with HTTP status codes. All right, let's make a JSON API request, just a simple one. So we're just going to get some information. We're not going to post any information or put or delete or any other API term. We're simply going to get some information. And this is going to be the most common thing that you do when it comes to Python APIs, or APIs really in general. So from the last lesson, we did import requests, and then we said req is equal to requests.get, and then some URL in here. And we don't know if that turned out to be HTML or JSON or anything like that. So we need to find an endpoint. So if we head on over to swappy.dev, this is one of my favorite API sites because it's themed for Star Wars. And I like Star Wars. But we can also go to swappy.dev/API/ let's say people/1. And this is going to give us information about Luke Skywalker, or people, let's say 6, whoever that is. Owen Lars. And we can get all this JSON information. Now, what's nice about this is it's not a lot of information, but it's enough to be a great demonstration. So let's go ahead and get swappy.dev/API/people, and then just a number. So that's going to be our URL, https swappy.dev/API/people. Let's do person2, whoever that is. And then let's say that person is going to be whatever that request turns out to respond with, .json, and print person. Let's go ahead and try this out. Python, making JSON API requests. And it takes a second, and we can see we got C3PO. And if you're familiar with Pythonic data types, this looks a lot like a dictionary, doesn't it? So now we can pull out the name. We can say print name is tab. And let's do a f-string variable in here. So let's say person name. And let's make this an f-string. What else can we add in here? We've got a name. We can also add his birth year is person birth _year. And I'm just getting that from here and here. So let's go ahead and run this once more. Name is C3PO. Birth year is 112 BBY. Let's add one more tab in here, just to sort of line this up nicely. Name is C3PO. Birth year is 112 BBY. And now we have access to all of this information in here. Now, what's cool about this is we also have movies, don't we? They're called films, and films is simply a list of films that, let's say, C3PO is in. So let's take a look at where 3PO is in, and let's print out which movie that title is called. So we need to, what is that URL? API films 5. Films/5. Let's request that. And it's called Attack of the Clones, and it's in episode 2. So let's say we just want to figure out which movies he's in. We could then say for film in person films, because this is actually a list. req for request, requests.get film URL, print film is, and then we can do film. Actually, we need to JSONify this first. So let's say film is equal to request.json. And then we can do film title. And this is going to print out all the films for us. Let's also give us a print statement above. Films involved in. And let's run this once more. And it's going off and getting every single film. So this is making a different API request for every film that he's in and getting that title. And so now we're dynamically getting a lot of information. We're getting a character, C3PO. We're checking which videos or which films he's involved in. And for each one, we're getting that data, that whole film data, including the title. And all we're doing is printing the title. And that's why when we do this, you can see that it's coming back one at a time. Film is A New Hope, Empire Strikes Back, Return of the Jedi, Phantom Menace, Attack of the Clones, and Revenge of the Sith. Now, as a heads up, I do actually believe that there is some data missing from this API, but regardless, it's still a fun API to use. So as a recap, how do we make JSON API requests? It's the same as making a regular request, but if that data turns out to be JSON, we can simply do .json on that request object, and that's going to throw it into a variable. We called it person. And then we have access to all of that data, all of this data in a Python dictionary. So what I would like you to do is give this a simple shot. You don't have to do a for loop here, but what you can do is a simple request or a get request, and then JSONify it, and then print out what that data is. It'll come back as a dictionary once it's JSONified, or read from JSON rather. It'll come back as a dictionary, so you can have access to the name or the birth year or anything else that the API gives you. Go ahead and give that a try, and when you're ready, let's talk about how we can convert a string that looks like JSON to an actual piece of JSON and a Pythonic dictionary. Okay, let's take a look at reading JSON. So in the last lesson, what we did was we took some JSON from an API and we just sort of worked with it. And that was fine because the data was actually in JSON format. It wasn't a string, it was in JSON format. And so it was formatable for us, and we could easily turn that into a dictionary using Python. But what happens if this comes back as a string? Now, what I mean by that is just that data from C3PO in the last lesson looks a lot like this. So C3PO is equal to, we'll make this a bit smaller here, and it has all this information in here. Now, we can't simply say C3PO bracket name like we did in the last lesson, because this is a string. This isn't a dictionary. So if we say C3PO name, and we try to print this out, Python reading JSON.py, we're going to see that string indices must be integers. And that's simply because it's trying to slice this. It knows it's a string. And so it's not a dictionary. It doesn't have a key or a property called name. So we need to convert that. Now we can do that with the JSON library. All we have to do is type, I'm going to make this just a touch bigger there, import JSON, and we have C3PO up here. What we can do now is say C3PO is equal to C3PO, but we simply put JSON.load_s, load S. It looks like the word loads, but what it actually means is load string. So we're taking that string and we're throwing it into basically a conversion tool that's going to turn this into a dictionary for us. And if this is properly formatted, we won't see any errors. And so now you're going to see something like this with this particular example anyways. It's going to say something along the lines of expecting property name enclosed in double quotes. And that's because, guess what? This is not properly formatted JSON. This is a dictionary from Python. Now, if we go back here, people/2, let's get C3PO. You can see all this data has double quotes, or not double quotes, but not using apostrophes at least. So let's go ahead and copy that. And let's give it properly formatted JSON, which means we have to swap out the apostrophes we were using. And let's go ahead and use 3, like a docstring. So we can have multiple lines in there. Let's go ahead and try this out. Cool. That worked. So even though it's on multiple lines, it was totally fine. We have C3PO is equal to this giant JSON string. It's not a JSON object. It's not a dictionary. It's a string right now. And then we said C3PO is equal to JSON.load_s, and then that string, this string up here, and it simply converted it into a dictionary for us. So let's go ahead and print type C3PO, and we're going to see that this is going to be a dictionary. It's going to be a DICT. There it is, class dict. Now, what's cool about this is we can then put this out to another file after we edit it. So let's go ahead and remove that, and let's change something in here. Let's change C3PO's name to something else. So we can say C3PO name is equal to my friend Kane Eski. And now that's only going to change it in the dictionary. That's not going to change it in the actual text here. We need to convert this back. And so to convert it back, we simply do json.dump s, dump string, C3PO. And let's do C3PO underscore string is equal to, and let's print that. Print C3PO str. And this is all of his data. This is coming back as a string, and the name is Kane Eski. We have now taken JSON data as a string, and you're going to be working with this a lot, so it's important to know how JSON works. Not everything is perfectly formatted in the developer world or in the human world at all. And so we took a string, we said convert it to proper dictionary using JSON load s. Then we changed the name. Then we said, oh, actually what we want to do is we want to dump that data. So we changed that name, basically changed it up here. And then we dumped that data back into a string using dump s, dump string, gave it a string, and then printed it. And that's really all we had to do. Now, what I would like you to do is to give this a shot. I want you to try it out. This is really important. You're going to be using JSON a lot. Maybe not every single day as a Python developer, but certainly every week or every 2 weeks. So it's very, very common. Feel free to even steal this code just because it's got the dictionary, or not the dictionary, but the string JSON data in here. Don't forget to import JSON, json.loads, and then again, when JSON is imported, json.dumps. And that stands for load string, dump string. Let's take a look at function arguments. So in the wild, in a lot of Python, especially in like the world of Django, you're going to see something like def, thing, self, request, args, **, quargs. And so in this lesson, let's take a look at what args is. Because, well, that's going to come with classes, so we don't need self. Request is a Django thing, but this could really be anything. Let's say name. Then it takes some sort of arguments and then some sort of keyword argument. So let's ignore the keyword arguments for now, and let's just work with args. So first things first, when we're working with args, let's get rid of this because we're not using it. If we just dissect this function here, what data type does this look like to you? You should be saying this looks like a tuple. And that's what args comes back as. Args always comes back as a tuple. So let's create a function here where instead of def thing, we're going to say add numbers. And we're simply going to print the args. Now let's get rid of name because that is going to be a positional required argument. We don't want that. We just want to throw in any number of arguments. And the nice thing about args here is that you can pass in an unlimited number of arguments and it will just work. So now let's say add numbers 1, 3, 5, 7, and 9. And let's, yeah, there we go. Now this isn't actually going to add the numbers, but this is going to print out 1, 3, 7, 1, 3, 5, 7, and 9. So function args.py, and it comes back as 1, 3, 5, 7, 9. Let's take a look at this. Let's dissect this a little bit. Let's see what this actually is. Is this actually a tuple, or was I just pulling your leg? Look at that. I wouldn't lie to you. I wouldn't do that to you. It's a tuple. And so any arguments, not positional arguments, for example, if we have a positional argument called name, I'll use Caleb as an example. This name here, Caleb, gets assigned to the first positional argument. Everything after this positional argument is a star arg, or just a regular argument. And so what this is doing is saying, oh, let's match up that first one. And then if we didn't pretend, or if we did pretend that didn't exist, the rest of them would be arguments. And so now we can work with all of these. What's cool about this is we can say total is equal to 0. And if we wanted to add all these numbers, we could say 4 num in args total is equal to total plus whatever that number is going to be. So it's going to add 1, 3, 5, 7, and 9 together. Return total. And then out here we can say the total is add numbers, Caleb 1, 3, 5, 7, 9, print the total. And let's actually get rid of this positional required argument because we're not using it. So why is it there? And let's run this. We get 25. Let's add this together in our heads to make sure this works. 1 plus 3 is 4, plus 5 is 9, plus 7 is 16, plus 9 is 25. And so now we can take unlimited arguments using the args keyword. Now, it doesn't have to be args. It just has to be delimited by that star. And that's how Python knows that this is going to be the rest of the arguments. In JavaScript, I believe we use a thing called a rest operator, so a ... In Python, we use a star or an asterisk. And that simply tells Python that the rest of these functions, or the rest of these arguments in this function, is going to be a set of arguments. And so it knows to package them up, throw them in a tuple called args, and then we can work with all of those arguments. Now, what I would like you to do is give this a try. I want you to create a function where you maybe add all the numbers together, or you multiply all the numbers together, do some sort of basic addition, or multiplication, or something like that. You could even take names if you wanted to. Take a series of names. It doesn't have to be numbers. We just use numbers because it was simple. But you could use a series of names and print out all the names. Regardless of what you end up trying, I want you to try this out because you're going to see star args everywhere in professional level Python. It's very, very important you understand how this works. When you're done that, in the next lesson, let's talk about this thing called kwargs, keyword arguments, and that's delimited with 2 stars. It's a little bit different, kind of the same. Okay, let's take a look at keyword arguments in a function. So often you'll see def thing, a positional argument, a positional required argument. You could have something like a positional optional argument. So name, age is equal to 31 by default. Then you can have some form of arguments in there, any kind of arguments. These don't have a name. These are simply like 1, 3, 5, 7, or 9, like we did in the last lesson. And then we have keyword args. And this is a full function. This is pretty much everything we can do inside of a function in regards to parameters. So we know that name is going to be required, absolutely required. Age is optional. Whether it's in there or not, doesn't really matter. Age is always going to be 31. Then we have args, and this could be any number of arguments. It can be literally an unlimited number of arguments. It comes back as a tuple, and we can loop through the data in that tuple. Keyword args, kwargs, is delimited with 2 stars, 2 asterisks. And what this means is instead of coming back as a tuple, it comes back as a dictionary because keyword args look like this. Thing is equal to something. Or if we do this in Pythonic terms, thing, something. And so it's a little more dictionary-like. So let's go ahead and ditch this and let's create an example where we use kwargs. So def. Let's say a person has some sort of attributes. We don't know what those attributes are yet, but we can loop through them. So first of all, let's print kwargs and print type of kwargs. And let's execute person, and let's say name is equal to Jacob. Age is equal to 27. Brain is equal to huge. And what's great about this is I actually know a person named Jacob. I think he's about 27. And he's probably the smartest person I've ever met. Python function kwargs .py. And we're going to see that we get a dictionary with name Jacob, age 27, brain huge. And all this did was literally package this up and throw these keyword arguments into a dictionary for us. So now we can work with this. We have something to work with. So we can now say in our function, if, let's check to see if age is in kwargs, print your age is, and then we can do kwargs.get because it's just a dictionary. We know how to use the .get method already. Kwargs.get name. And so now we're using the in operator, we're using get, we're using dictionaries, we're using a conditional, we're using keyword arguments, we're using a function, and we're using print statements. And name, why did I put name? I should have put age. If you're yelling at your screen going, well, good catch. It says, your R, just one after another here, just killing it today. You are 27. Cool. Let's just pretend I got that on the first try. So now you might be thinking, where is this actually used? Like, this seems kind of far-fetched. And if you're thinking that, you're not wrong, but you're probably not completely right either. A good example of this would be like, let's say you want to order pizza from a website. Def order pizza. We need a positional argument. Name. We need an address to deliver it to. And let's say toppings. Now toppings is going to be a keyword argument. And so we can say print order is for name. I'm going to use an F string here. And the address is ship it to the address. Now we need to come up with some kind of pricing. So the price right now is going to be, let's say, a default of $18. And for every topping that we have, we want to add another $2 to it. So now we can loop through toppings. We can say for key value in toppings dot items, because we know this is a dictionary and we can simply loop through all the toppings. Now we don't really care what the toppings are. It could be pepperoni, could be ham, could be pineapple, could be extra cheese, could be jalapenos. I don't know, doesn't really matter. We just want to figure out the price here. And so we're going to loop through all the dictionary items. That gives us a key value pair. And frankly, we don't even need to use the key or value. So the fact that we're using .items is completely useless. It's just good for example code in this video. So let's go ahead and say for every item in here, price is equal to price plus $2. Let's print that out when we're done. The total price is price, and let's return price. So let's go ahead and now order this pizza. How do we instantiate this particular function? We do order pizza, because that's the name. Let's say it's going to go to Amanda. She lives in Canada. And what kind of toppings does she want? Let's say jalapenos is equal to true. It's a keyword argument. Extra cheese is equal to true. And ham is equal to true. And so we've got a positional, let's scroll that up just a little bit here. Positional required argument called name, another one called address. Everything else is considered a keyword argument. So if we order this pizza, we can now say total price is equal to this. Let's go ahead and actually execute this. Python function kwargs. And it says orders for Amanda, ship it to Canada. The total price is 24.0, so $24. And that's because we have 2, 4, 6 extra dollars, because every topping is worth $2, and the base price is 18. And this is a real world example of how you could possibly, if you wanted to, use keyword arguments. You could also check to see if address is in the keyword arguments, because if address was in the keyword arguments, you could either ignore it, or if it wasn't a positional required argument like this, if it was in there, then great, you know where to ship the food to, or deliver the food to. Yeah, do we ship food? Do we deliver food? You know where to deliver the food to. Otherwise, if address is not in toppings, and we're simply checking to see if there is a key inside of a dictionary there, if address is not in toppings, you're going to need to ask the user for an address. And this is a real world situation. This is how you would order pizza using Python. Now, I would like you to give this a shot. I'm going to undo that so this code actually works. go ahead and create a function that takes a couple of positional required arguments, and then let it accept keyword arguments with ***. And again, it doesn't have to be called KW_args, like keyword args. You'll just most likely see it that way. It could be called anything. But more often than not, you're going to see it as kwargs. Go ahead, try it out. You're going to need to know how this works when we move into things like Django, because we use keyword arguments everywhere in Django. In the next lesson, let's talk about how we can install pip. Let's take a look at how you can install pip. So first of all, what is pip? Pip is a package. I guess it's considered a package, but pip basically lets you install third-party packages using Python. So if you've ever used JavaScript, you might have used npm. In PHP, it's called Composer, I believe. Composer. I think it's Composer. It's been a little while. And in Python, we call it pip. And so how it works is we can say pip install package name, and this makes it available on our computer for us. So we can now use other people's code on our computer. Now, if you don't have, for example, requests installed, you can simply do pip install requests. Now let's check to see if you actually have pip installed first. Let's do pip-v in our terminal, and I have pip installed. If you don't have this, if this gives you some sort of error, like command not found kind of error, we're going to need to install pip. Now, if you already have pip installed, and you might already have pip installed just because Python might come with it, if your version of Python comes with pip, you can ignore the rest of this video. If you do not have pip, let's go ahead and install pip now. So to install pip, what we're going to want to do is we want to, first of all, curl this down to our computer. So we want to download this file to our computer. And so we can do that with curl on our terminal, https://bootstrap.pypa python packages.io/get-pip.py. Then we do -o, and we're going to call it get-pip.py. Now let's see if I have any typos in here. Downloading the file. And if I do ls-la, or if you're on Windows, you can write dir. And do we have get-pip? We have a function in here called get-pip. Great, that's what we want. So now once you have that file, all you have to do is type python get-pip.py. And that will go ahead and get and install pip on your computer for you. Now that command again is just this. Curl https://bootstrap.pypa.io/get-pip.py-o get-pip.py. So, feel free to pause the video here if you need to, if this isn't available for you on this platform, to basically copy and paste. You can just pause the video and write it out. And then you need to run python get-pip.py. And once that's done running, you should be able to do pip-v. And pip-v is going to show you your pip version, where it's being used. So for whatever reason, my pip version is using 3.8, Python 3.8. And it tells me Python 3.8 in here. Now to install a package is as easy as saying something like pip install Colorama. And this is going to go off and download a bunch of stuff. It says it's already satisfied for me. I guess I already have it somehow. And I can uninstall by doing pip uninstall Colorama. Yeah, let's get rid of that. Doesn't need to be on my computer, so I got rid of it. Another one you might possibly want, if it doesn't come with your version of Python, is go into your shell and simply type import requests. Okay, that worked for me. But if you see an error that looks a lot like this, module not found error, you're going to need to install requests. So let's go ahead and quit. And you can do pip install requests. And this allows us to then, in our code, what we saw before was like import requests or import JSON. And that just allows us to import other people's code. Now, Python comes with some of its own code, like you don't need the JSON library, it just comes with Python. It's just not part of the core part of Python. So you do import JSON. Whereas requests may or may not come with your version of Python. If it doesn't, you have to do pip install requests, and then we can, in our code, import requests. All right, welcome back. Let's take a look at this idea of something that can be mutable versus immutable. And these are fancy words for is something changeable versus unchangeable. That's all it is. Developers, programmers, we really like our fancy words, so we use immutable and mutable. Really, it just means changeable and unchangeable. That's it. But there's something to note here, is when you're working with certain variables, certain things are mutable or changeable, and some things are immutable, unchangeable. And so, for example, you might be thinking that a string is mutable. It's actually not. It's not changeable. So if we have some sort of string in here, we could say, the fox jumped over the cow. And then we said, string is equal to something else. We might be thinking that this is actually mutable, but what's really happening behind the scenes here is something very, very different, something you wouldn't necessarily expect. So string here is taking this particular string and is jamming it into a little piece of memory on your computer, and we nicknamed it string. That's the variable name. Now behind the scenes, we cannot change this whatsoever. And so if we did string dot upper, and let's print this. Let's print string.upper, and let's also print just the regular string. And let's do Python mutable versus immutable. We're going to see that one is uppercase and one is not uppercase. And what you actually see here is string is taking all of this, turning it into uppercase, but it's not restoring it back into this particular variable. What it's actually doing is just holding that in memory and then letting you use it. Now, if we wanted to, we could try to overwrite this. We could say string is equal to overwritten. And absolutely, this is going to work for us. But behind the scenes, it's doing something you don't expect. Behind the scenes, it's saying, okay, string is equal to this particular sentence here. And then that string is being overwritten. This has a piece of memory. This has a different piece of memory. So we're not putting this piece into this string and then putting this piece into that same string. We're actually overwriting it altogether. So we're saying this has a piece of memory. This cannot be changed. Once it's in there forever. Or, until your script ends at least. Then we're saying, okay, well, we know that there's a piece of memory called string. We're going to overwrite that with a new piece of memory and call it overwritten. So behind the scenes, you cannot actually change a string. Now that's wild because you would think that you could be able to change a string, but it just doesn't work that way in computer science. So another example of this would be like a list. So we could have names is equal to Caleb, Jacob, Gully, and Amanda. What's different about this is because we're using a list, and even though these strings in here, these individual items are immutable, the list itself is mutable. It means we can change it, we can add to it, we can append to it. So we can do names dot append, and let's add the cat named Rhubarb. Print names, and you notice how we didn't do names is equal to names dot append. We didn't do that. We simply assigned a variable here, and then we said, with that variable, add something to it, and then print that out. Let's go ahead and run this. We see the overwritten example at the first two lines. Then we see Caleb, Jacob, Gully, Amanda, and Rhubarb. And, interestingly enough, unlike this, where we did string.upper, it didn't save it as uppercase whatsoever. We can see that here, it was uppercase once, but it didn't actually save it as uppercase. Whereas names with a list, it did. We set that variable, whatever that variable is going to be, as a list. Then we said that list dot append a new item, add a new item to that list, and it automatically saved it for us. That means lists are mutable, but strings are not mutable. Now, is this important in your everyday Python life? No, not unless you're going to get into probably data science and you have giant amounts of data and you need to be very performant. In web development, we don't really need to know this, but it's a good thing to know nonetheless. Now, as your homework, what I would like you to do is go off and Google, is a tuple mutable or immutable? We know a list is mutable, we know a string is immutable, but a tuple is like a list that you can't add anything to. Is it considered mutable or immutable? You're going to have to go do a little bit of research for this one. When you're done that, let's head on over to the next lesson where we talk about this fancy word called enumeration. Oakley dokley, let's talk about this thing called enumeration. And really all this is going to do is we're going to loop through some sort of list, and we're going to get the index number from it. So we could create a list. Let's say animals is equal to a list of Gully, Rhubarb, Zephyr, and Henry. And then we can say for animal in animals, print the animal. But how do we know exactly which order this is in? How do we know that rhubarb is going to be number 2? Or how do we know that Henry is going to be the last one? Currently, we don't. And so if we execute this code, we're going to see that this is a standard for loop. We learned about this in Python 101. Nothing fancy, nothing new, nothing exciting. So if we wanted to get the numbering in here, we use this function called enumerate, and we wrap our list in it. And what this is going to do is if we try to run this, check this out. It gives us a tuple. And it's actually every single item in here is a tuple. It's a tuple of tuples, or a list of tuples, rather. And so 0, Gully, 1, Rhubarb, 2, Zephyr, 3, Henry. So now we have those index values. And because there's 2 of them in here, we can do this thing called unpacking. So we can do index and then animal. And then if we print just the animal, it's going to show up just like the first time. We could print index, then that animal. And we can see here, 0 Gully, 1 Rhubarb, 2 Zephyr, 3 Henry. So now we're starting to get that index number. Now we can actually do something with this. We could say, if index modulus 2 is equal to 0, so every second one, continue. And then, if we don't continue, if the index with a modulus of 2 has a remainder of 0 or doesn't have a remainder of 0, print that animal. And so this is only going to show every second one. This shows Rhubarb and Henry. Or as an alternative example here, what we can do is we can print with an F string, index plus 1, number. Let's do a tab. Let's not do space tab. Let's just do tab. And then the animal. And this is going to look like a proper numbered list for us. 1, 2, 3, 4, Gully, Rhubarb, Zephyr, and Henry. So now we're getting somewhere with this. Now enumerate comes in pretty handy. I use this probably once or twice a week in professional level code. And so you're going to need to know what enumerate does. And really all it does is say, hey, let's give it some index values here. So this is going to be 0, this is going to be 1, this is going to be 2, and this is going to be 3. Simple as that. All it does is add index values, because sometimes you need those index values. Go ahead, try this out. In the next lesson, we're going to talk about list comprehensions. All right, let's take a look at a list comprehension. So a list comprehension is really just a shorthand method of writing a for loop and putting all of that data into a list. Now, we would see an old example like items is equal to something like that. Actually, let's not do items. Let's do numbers is equal to a list of numbers for num in 1, 3, 5, 7, and 9. Numbers dot append whatever that number is going to be to the power of 2. Print numbers. And so we see 1, 9, 25, 49, and 81. And so all we did was exponent the number against the number 2. So we said 1 to the power of 2, 3 to the power of 2, 5 to the power of 2, 7 to the power of 2, 9 to the power of 2. You get it. There's a quicker way to do this in Python. This is a very Pythonic thing to do. And it looks very bizarre at first, but instead of doing it the long way, we could say numbers is equal to some sort of value for a value in a list of some kind. And so what we're saying here is, look at this, for loop. And this looks a lot like for num in a list of 1, 3, 5, 7, and 9. And check this out. Even when I highlight it, it's the exact same. And all we're doing is returning that value on the left. So now we have num. We can use num instead of x. Num to the power of 2. And let's print numbers once more. And let's run this. We're going to see that this is the exact same thing. So now instead of writing 1, 2, 3 lines of code, granted it's only 3 lines of code, we wrote it all in 1 line of code. And so again, we just said the answer for some sort of iteration or iterable in a list of things or a list of iterations, and we have brackets around it. And the brackets around it means that this is going to be a list comprehension. We can do something very similar with dictionaries called a dictionary comprehension, which we'll learn about in the next lesson. But for now, we just need to know that we have a hard bracket here, looks just like a list, and we have some sort of weird stuff in here. Now, what I want you to do is I want you to try this out because list comprehensions are very, very popular in Python. They're significantly more popular than a dictionary comprehension, and you're going to need to know how these work. So when you see it, you don't just look at it and you go, oh, I don't know what this means. I don't know what this is. I don't even know what this is called. You now know that this weird syntax here is your answer for your iteration in an iterable wrapped in a list. And that is identical to what we wrote here. It's just a little bit shorter. So go ahead, try it out. Have some fun with it. Try to break it. Try to understand it. Probably spend like 5 minutes on it and just mess around and see what you can and cannot do. If you want to take this one step further, I would definitely suggest going off and researching how you can add an if statement in here. Because you can have if and else statements inside of list comprehensions as well. So you have one big line with a for loop, and you could have an if statement inside of that for loop and only output something if there is a particular answer. Go ahead, try it out. When you're ready, let's head on over to the next lesson where we learn about dictionary comprehensions. Welcome to dictionary comprehensions. So like a list comprehension, a dictionary comprehension can be written in one single line as well. So let's go ahead and create a long example, and then we'll recreate it with a shorter example. So let's do an example where we want to create a dictionary out of a list of tuples. And so we can say something like this. Names is equal to, we've got a list and then a tuple in here. Name, Caleb. Occupation, coder. Now to turn this into a dictionary, we'd have something like D is equal to, and then 4. And because this is a tuple with 2 items in it, we can unpack it. So we could say for key value in names, D key is equal to value. And then we can print out whatever D for dictionary is. So Python dictionary. And you can see that's a dictionary now. Name, Caleb, occupation, coder. We could even double check that it is in fact a dictionary, although, I mean, we can look at it by its syntax. But let's see what this looks like. Yeah, it is in fact a dictionary. And so all we did here was create a dictionary from a list the long way. There's a shorter way to do this. So let's go ahead and get rid of that. And I'm going to make this just a little bit shorter so we can see the code. So now we can say D is equal to a dictionary comprehension. So we usually put some sort of key some sort of value for key value in, let's say, names, which is an iterable. So let's actually write this out the long way. So this is a key colon value for every key value in names. Let's go ahead and print out D again, and we're going to see that it's the exact same. It's going to look the exact same top and bottom, just like this. And so all we did here was we opened up and closed with curly braces. We said the key colon, just like a regular dictionary when we're creating a dictionary from scratch. It then has a value. And then we're saying that key and value are coming from unpacked items in an iterable. Key was the first unpacked item, value was the second unpacked item. And names is the iterable up here. Now, that's a lot easier to write than having to write these 3 lines. You can also add if statements in here as well to make sure that you only add certain information, which I'm going to let you research on your own because that's an important part of learning how to code. But there's also one more way. We could also simply say D is equal to dict names. Check this out. Simple typecasting at its best. So we're going to show up, we're going to print D 3 times, and check this out. We were able to convert names to a dictionary automatically with a single line of code, and we used like 4-6 characters plus a variable name. So there's a few different ways to do this. Now, a dictionary comprehension is not as common as a list comprehension. List comprehensions are wildly popular in Python. Dictionary comprehensions, popular, not as popular. But you're still going to see these and you're going to need to know how these work. So go ahead and give this a try. Feel free to just run this example, lines 1 through 3. You're going to loop through an iterable called a list. And that list is named names. Every item in that list is a set of tuples, or a tuple set. I can't remember what it's called there, but it's got a first value, comma, second value, comma, another tuple, first value, second value. And you can unpack that using key value in that iterable. And then you can create a dictionary comprehension. Then print that out. Make sure that it is actually what you expect it to be. I'm going to undo this code so you can see the long way. Go ahead and try it out. If you get stuck, definitely come check out the Learning to Code Facebook group. We're here to help you learn Python. Let's take a look at how we can get dictionary values. Now, I touched on this a little bit at some point a few lessons ago, but if we have a dictionary, we can check to see if a value exists and get that value by its property name. So let's create a dictionary here called courses. And let's say we have a JavaScript course, a JS course, and it's called JavaScript 101. And we have another course for Python called Python 101. We also have another one called Python 201. So let's make this one a list, Python. And there's also like HTML 101 and all that good stuff. CSS 101. This one's going to be called HTML 101. And so let's say we wanted to get JavaScript. We wanted to get this out of here. Now, we don't necessarily know all the time all the values that come in a dictionary. Typically, we do some print debugging where we do print courses. And then if we see it in there, we can do print course JS. We could do something like that, but we won't always know. And sometimes print debugging, it's okay to do, but it's sort of painful to do at the same time. So there's a better way we can do this. So we can actually say courses.get JS, and you're often going to see this, courses.get JS none. And this is what we're going to see. .get some property name, which matches our line on line 2, our property on line 2, or a key name. Sometimes we call it property, sometimes it's a key. They're interchangeable terms. Or if there isn't one, set some sort of default. And the default here is going to be NONE, it's going to be none. And so if we print this out, we're going to see that it gives us JavaScript 101. Now, that's good. That's exactly what we want. But what if we wanted to get CSS? Well, there is nothing in there, so this is going to print absolutely nothing. Just none. It says none in there because there's nothing there. We could also give it a default text in here. And that's going to give us the default text in here. Or better yet, because we're going along the sort of pattern of JavaScript 101, HTML 101, Python 101, etc., we could do CSS 101. And so if it can get CSS 101 out of this dictionary, great, it's going to. Otherwise, it's going to default to CSS 101. When we print this, we're going to see it says CSS 101. And that's because CSS as a key, as a property inside of this dictionary simply does not exist. So it falls back to CSS 101 or whatever we decide to give it. Now, where this is useful is if I comment that out, we can say if courses.get CSS, and we're not going to give it none because that's what the default is. We can simply say print you are enrolled in, if I spell that right, enrolled in CSS 101. Now watch this. This is not going to print anything. It does absolutely nothing. What if we say if courses.get and gave it some sort of value in here, CSS 101? Is this going to execute? And this is a good question to be asking yourself. It says you are enrolled in CSS 101. And that's because it couldn't get that CSS value. So then it went and set a default one. And this is a lot like saying if a string is equal to CSS 101, which is often why you're going to see this. And this is just a little more explicitly written. So this is going to say if courses.get CSS, if there is one, cool, execute this if statement, otherwise none. And we know in conditional statements with Python that if you say if none, this is going to be the same as saying if false. It's not going to execute. So when we try this out again, it's not going to print anything. I can do this over and over and over again. Literally just prints nothing. Now you're going to see this all the time, nonstop, probably every single day as a professional Python developer. What you want to do as your task, or what I would like you to do as your task, is get a little hands-on experience with this. Go ahead and create a dictionary. And in that dictionary, I want you to go and then use .get, and then one of the key values, and give it a default. And just play with an if statement. Basically, just do exactly what I did in this video. Even if it only takes you 30 seconds, you might think, oh, well, this is meaningless. But really, you're building up a lot of muscle memory here. And what's nice about muscle memory is as soon as you see it, as soon as you start typing it, eventually at some point, it just becomes second nature. You don't have to think about it. It just happens. You just know Python. Go ahead and try that out. In the next lesson, we're going to talk about something a little more complicated called a virtual environment. All right, let's talk about virtual environments. A virtual environment is a way to compartmentalize packages. So for instance, I can use pip to show my packages. I can say pip show Django, and I have Django installed here. I'm using Django 2.2.13, and that's on my computer. Now, what if I have a project that's using a different version of Django, say Django 3.1? And then let's make that one step more complicated. What if I have 5 different websites using Django, but they're all using different Django packages? Currently, what I would have to do is pip uninstall Django and pip install Django is equal to 3.1 point whatever. And I'd have to do that over and over and over again. And you can actually see when I'm using pip show Django here that it shows you exactly where Django is. And this is right on my computer. It's in library frameworks, Python framework versions 3.8, lib Python 3.8, site-packages. That was a mouthful. But what if you have, a project, let's say a Django website again, where you want to share this with everyone else in your company, and you want them to use Django as well. Well, instead of packaging up Django and shipping it with your website and sending it to everyone, it's like zipping up a file and sending it to everyone. You can just simply tell them to pip install Django using a certain version. And we do this, and we separate these different versions, or we separate these different environments, or these projects, using a virtual environment. And this is a very, very common thing in the world of Python. And so to get into a virtual environment requires one of two things, one of two steps rather. Either you're going to be on a Unix-based system like Mac OS or Linux. They're very, very similar. Or you're going to be on Windows. I'm going to show you how to do it on both. So To create a new virtual environment, first of all, let's do ls-la, or if you're on Windows, you can type dir. And if I scroll up here, usually you're going to see a folder called .venv, or just venv, or env. These are the three most common I have seen out there. So we don't have any of those yet. Let's go ahead and create that. So we can do python -m venv.venv, and that's the folder we're going to put it in. And it's going to take a second, do a bunch of thinking. VS Code is smart enough. It said, we noticed a new virtual environment has been created. Do you want to select it for this workspace folder? Yeah, okay, might as well. You can see over here, I've got a venv folder. If I do ls-la, or on Windows dir, scroll up, I now have a folder in here called .venv. I also have a VS Code one. That's just VS Code being VS Code. We don't have to worry about that. But I've got a venv folder in here, and it's got bin, lib, include, pyenv.cfg. If you're using pyenv, which I am, you might not have that. But that's how we create a virtual environment. Very simply, it's just python -m venv.venv, or whatever you want to call that folder. I usually call it .venv, so it's hidden. And we try not to commit these to our Git repositories. Now, that's all well and good, but if I do pip show Django, it's still using the exact same location. It's still using the exact same version as before. We're not actually using our virtual environment. We have to get into it. So we created it, but now we have to get into that virtual environment. So if you're on Mac or if you're on Linux, you can type source.venv bin activate. And you can see it says .venv over here. I'm in a virtual environment now. Now watch this. If I do pip show Django, nothing shows up. It's not installed in her virtual environment. And what's cool about this is I can do pip install Django. And I'm going to give you Windows instructions to get into your virtual environment as soon as this is done. So this is just going to go off, download Django, pip show Django. And this is now using Django 3.1.4. It's in my Python 201 folder in the .venv in its library, Python 3.8 site packages. Cool. So let's get out of this. We get out of this with deactivate. And that just got me out of my virtual environment. Now to get back into the virtual environment, if you're using Windows, this one is a little bit trickier. Typically we do something like \venv .scripts .activate .bat. Now this highly depends on your operating system. If you create a virtual environment in venv, it's going to be in .venv right in here. Otherwise, what you're often going to see is /env scripts with a capital S activate .bat. And that's how you get into your virtual environment using Windows. It's going to be one of those two options. So let's get back inside here. I'm going to do it the Mac way. So source.venv bin activate, and now I'm inside of it. Pip show Django, and this is going to show me Django 3.1.4 right there. Deactivate to get out of it. Pip show Django again. And my computer is using version 2.2.13. So my computer has access to Django, but it's an older version of Django. My virtual environment, which is brand new, has a brand new version of Django in it. And so now I can use two different versions of Django or any Python package and make sure that, they're not going to conflict. I can have another virtual environment on another project using a different version of Django. And so the whole idea here is that if you have multiple projects on the go, it's really, really easy to just upgrade one project and not have to worry about upgrading another project. Because if you upgrade one project and you have to upgrade all your other ones, that's going to suck. I have over 200 websites on my computer from my job right now. And I could not imagine having to upgrade Django on 200 sites every time I wanted to do a little bit of a version bump. And so this just keeps it nice and simple and separated for us. So typically, whenever you're working on some sort of Python project, you are going to create a virtual environment. It's always a good idea. Even if you only have one project on your computer, make sure you create a virtual environment. And again, that's just python-m venv.venv, and then it's going to be source.ven bin activate, or if you're on Windows, it's going to be .venv scripts /activate.bat, and that's going to get you in. And then once you're in, you simply type deactivate to get out of it. Go ahead, create a virtual environment, and then get inside of it. Do something like pip install Django, and then deactivate it. Once you have that virtual environment up and running, you've been able to enter it and exit it. Perfect. Let's head on over to the next lesson where we talk about a better way to learn Python using a new type of Python shell. Let's take a look at how we can learn Python in a more interactive way. So we can always go into Python and we can create some sort of object and then hit dot and then tab, and it's going to show us all sorts of methods on it. So for example, we can have a string called name. We're going to call this Python 201, and then we could do name dot, hit tab a couple of times, and we can see all different things in here. For example, we could capitalize this. It's already capitalized. That's not going to do anything. Name dot ends with. We could do 201, and this is going to return true for me. And so we can see all these different things in here. We don't have to do it with just a string either. We just happen to be doing it with this string. We can do it with a tuple, a dictionary, a list, pretty much any data type that has some sort of transformation on your data. You can do this with. So for example, if I wanted to put this into words, we could do name dot, and then where are you? It's called split right there, split. Name dot split, and we want to split it on every single space. Now it looks like it did nothing, but words is now a list. We could do words dot reverse, and let's take a look at this. Words dot, hit tab a few times. Reverse is at the very end. Reverse. It's backwards, and now we can join this back together, and then we can put this back together by saying course is equal to a string dot, and we had up here in string join. How do we want to join these together, or what do we want to join together rather? Words. And so we're saying use a space to join all the words together. Course. And now I just reversed all the wording in a course. Now it's, instead of saying 201, or instead of saying Python 201, it says 201 Python. And this is a really, really, really powerful way to learn how to code. So if I clear that out again, what we can do is words, I've got 201 and Python in there. Words dot, let's pop. That returned the word Python, and if I do words, I only have that one word in there. I can do pop again. It gives me that last word, 201. Words is now an empty array or an empty list. If you have some sort of dictionary, you can always do a dictionary dot and then hit tab a couple of times. Make sure it's an actual dictionary, so have a proper value in there. But then you could do your dictionary dot tab, or tab a couple of times sometimes, and it'll show you everything you can do. So what I want you to do is I want you to create a tuple, hit dot, then hit tab, and then I want you to see what kind of things you can do with a tuple. And then I want you to do the same thing with a list, because lists and tuples are almost the same thing, but tuples aren't really mutable. You can't really do a lot with a tuple. And I want you to compare the differences. And then just explore. Feel free to explore. The worst you're going to do is a little bit of damage to your variable. Not your computer, not your virtual environment. Everything else will be totally fine. You're just going to transform your variable. That's all you're going to do. And this is a very, very, very powerful way to learn Python, Django, Flask, really anything Python related like Wagtail CMS, anything really, you're going to be able to do it. You're going to be able to learn it a lot faster this way. And that's because simply a course should not go over every single item in here. For example, name dot. I'm not going to teach you format map or is numeric or is printable or partition or anything like that because there's just too many options. Same with a list. There's a lot of options in here. Now, this doesn't sound like a lot of options, but imagine what you can do with a dictionary. Imagine what you can do with a class. Imagine what you can do with a tuple or a set. And having to go through all of those one by one is, honestly, it's painful for you to watch. It's also painful for me to teach. And frankly, you're not going to use most of them. So whenever you see some code in the wild, let's say you're working with a senior developer and a senior developer has some really fancy code and you're like, whoa, what does words.extend do? Well, now you know that you can go and experiment with words.extend, or list.extend rather. Now, this is one way to use your shell, and that's just simply typing Python. That gets you in there. Another way is you can use IPython, and I really, really like IPython. So I do pip install IPython. Clear. And instead of typing Python, I simply type IPython. And you can see it's a little nicer in here. Name is equal to Caleb Tallien. Name, dot. Hit tab a few times, and now I can actually move through these and it types it out for me. You can copy and paste a lot easier in here as well. You can do multiple lines. You can do all sorts of stuff. And this is an even better way to explore because it's a little more interactive. It's easier to be like, oh, what is zfill? Takes exactly one argument, 0 we're given. Let's fill it with a 1. Let's see what happens. String cannot be interpreted as an integer. Okay. Cool. I have no idea what zfill does. I'm going to go and explore that after this this video is wrapped up. So fun. That's how we learn. And that's how you can learn on your own. So you don't need to take another Python course or another Fullstack web development course or watch another hour-long tutorial on zfill. You can explore it yourself and then figure out what you need to learn from there. So you're maximizing your time by doing your own exploration and getting your own experience. In the next lesson, let's go ahead and talk about packages. Let's talk about packages now. Okay, so we have this idea of a package, and we've dealt with this a little bit. We did pip install IPython. That's not how you spell Python. IPython. We did pip install Django. We even at one point did pip install Colorama, and we're going to do pip install Colorama again. But first, we're going to get into our virtual environment. So if you don't have one, python-m venv.venv. Cool. Source.venv bin activate. I'm now inside of my virtual environment. I can now do pip install Colorama. And I know that Colorama is a package that we can use, and it's going to go and install it. Cool. It says successfully installed Colorama 0.4.4. Now let's go and take a look at some of the documentation here. Colorama on PyPy. And this is where you can find any sort of package. PyPy.org, you can search for anything. So for example, if I wanted Wagtail packages, you could find different Wagtail packages in here. If you wanted to find Django packages, you could literally just type Django and you'll find all sorts of Django packages for you in here. The one I'm going to use is Colorama. Colorama 0.4.4. And it tells us how to install it. That's great. Now, how do we actually use it? And it tells us in here, applications should initialize Colorama using Colorama import init and then actually instantialize that init. Okay, so let's go ahead and do that. So let's go into our regular Python shell, not a IPython shell, just a regular Python shell. And actually what I'm going to do is I'm going to change my mind on that. Instead of using regular Python shell, what I'm going to do is use IPython because we installed it, might as well use it. From Colorama import init. And then we wanted to run init. Okay, cool. Looks like it did nothing, but we're following the instructions so far. How to get colored output. So let's go ahead and let's honestly just copy and paste this. Copy that whole thing, paste the whole thing in there. And look at that. We have some red text. We've got text with what presumably outside of IPython would have been a green background. Some dimmer text and normal text in here. So all we did here was we said import for back and style. We said foreground is going to be red. The background here is going to be green with some green text. Then style dim, we're going to dim that text. Style, reset all of it, and it's back to normal. That's all we did. And so to use a package, we really just do pip install the package name. From that package name, import something. Now we don't know what exactly we can import, and that's why it's so important to read the documentation. And it tells us all sorts of things that we can do in here. Now, this is kind of an ugly example, so let's go ahead and run this in our regular Python shell. Let's do python-v. I'm using Python 3.8. You can also try it just in your regular Python shell. It's probably going to turn out better in your Python shell. But what we can do instead here is we can let's import this. Let's do from colorama import init. Then we need to instantialize init. And let's go ahead and save this as packages.py. And I'll make this a little shorter here. And what I'm going to do is move all my imports to the top of the script here. We can actually even merge this together. We can say from colorama import init for backend style. Let's go ahead and run this now. So let's save and let's run this in Python. And there we go. It says some red text and with a green background. That's actually a super light green background. So maybe IPython was right and I just can't quite see that. It's super dim. We're keeping the dim red text with a green background. Then we're resetting it back to normal. And we're running all of this inside of our packages.py script. And so that's really all there is to a package. Remember, all you have to do is pip install the package name. And then we do from package name import thing 1, thing 2, thing 3, and we just follow the documentation. And the key here is really follow the documentation. Even on PyPy here, I typically don't even follow documentation from PyPy. I typically go straight to GitHub. GitHub. And this is going to tell me, I think this is the exact same, so great. But it also tells me other things like available formatting constants are for foreground, black, red, green, yellow, blue, magenta, cyan, white, reset. Background, same thing. Style, we can dim, normal, bright, or we can reset all. So what I would like you to do is pip install Colorama, go to this Colorama GitHub page, read through the documentation, make sure you import Colorama and import init from Colorama, run init, and then basically just copy and paste this. That's what I did. And just have some fun with it. Because now you can make your terminal look nice and colorful, which is amazing because terminals are notoriously boring. Now you're going to be using packages all the time, nonstop, every single day. You're going to be importing things every single day. So it's important that you know how to use packages. Go ahead and try that out. And when you're ready, let's head on over to the next lesson where we do a little API requests refresher before our final project. All right, welcome to the API requests refresher lesson. What we're going to do here is just a quick little refresher on API requests. So if I open up making JSON API request.py, let's go ahead and take a look at what we originally wrote. And so we're not going to do any coding in this video. We are simply going to go over how this works. So request is a package. We import it. And just like in the last video where we imported Colorama, we imported requests. And with that came an object or a method called get. And so we do req, this could be anything, is equal to requests.get, and then some sort of URL. And that's just going to fetch that data for us. Then if that data is JSON, we're simply going to say that request object dot read the JSON. And what that does is it turns that JSON into a Python dictionary, which we can use later. So in this example, we were using, I believe this was C3PO, and this is now a dictionary, and we can print person name, because name is a property or a key on the person dictionary. Birth year was also available, so we put person birth year, just like a standard dictionary. And it's because this is coming in as JSON, which technically is just a string, but it's formatted a certain way, and Python recognized that and turned it into a dictionary. We also said for every film that this person was in, for every film C3PO was in, make a new request to that film. So this was a list of films. And so this is going to go through every one of them. I think there was like 7 of them or something. So the data wasn't completely filled out yet. But then we said for every film, go ahead, get that film. Then we said overwrite that on every iteration. So overwrite film. And because we know it's going to be JSON, transform that JSON into a dictionary called film. And then we said the film is, and then the title. And we got all of that from swappy.dev. Now in our final project, we're not going to be using swappy.dev. We're going to be using pokeapi.co. So it's very, very similar, but instead we're going to use something with a little more information. And so you can see that this has like a lot of different dictionaries in here. So ability is a dictionary, but this has a list of abilities in here. So this is a list, and this is just a standard key value pair. So we're going to be working with a little bit of a more, I guess, an advanced API, but we're going to be using things in a simple way because Python keeps things simple. So for this video, instead of doing any coding, what I would like you to do is go to pokeapi.co and just read through it, experiment with it, click around, try to break things. Even if you're not familiar with Pokemon, it's totally okay. We can just use some base examples from what they provide us. Because in our final project, what we're going to be doing is using this API, and we're going to be fetching a bunch of different information. So go ahead, get yourself a little bit familiar with the Poke API. Don't feel like you have to write any code. We're going to do this as our final project. The code part is going to be our final project. When you're ready for that final project, and maybe set aside like half an hour to watch the video and work on the project, but once you have that time set aside, let's head on over to that next lesson, the final lesson, where we create a Pokemon character app. Let's take a look at our final project. Our final project is going to be creating a Pokemon character app. So in this, what I would like you to do is, let's write out some instructions here. One, I want you to ask for user input. So for example, ask for a Pokemon. Which Pokemon are we going to talk about? That could be like Ditto, for example. Then you're going to need to create an API string, an API URL. A lot like this, where it says, we can go straight here and gives us all the information. We're just going to take that URL, but we're going to change out Ditto for whatever the user input. So step 2 is going to be create a dynamic URL based on step 1. Number 3 is we need to then fetch that data using requests. So step 3 is fetch the data from the URL in step 2. Step 4 is going to be print out the JSON data. But because it's JSON, we can't actually print it out. We need to convert it. So step 4 is going to be convert JSON to a dictionary. Step 5 is then going to be print out some Pokemon data. So print out Pokemon data. And that data is going to come from, for example, here. So it has abilities, it has forms, it has base experience, game indices, height, held items, moves, IDs. It has all sorts of stuff in here. So I'm going to leave that up to you, to whatever you want to display. So I have now walked you through basically the exact steps you need to create some form of Python program that can accept a Pokemon as a string, and then you can go and fetch that data from an API and display it in your terminal. What I'm going to do here is I'm going to save this as project.py, comment this out, and I'm going to then show you how I go about doing this exact project. But I want you to give this a shot first, so please do me a solid here and just pause the video and try this out on your own. Feel free to reference these instructions again, but try this on your own. Try to make your brain sweat. Try to leverage what you've already learned in this course without having to watch the rest of this video. Now, our solutions guaranteed are going to be very different, and that's okay. There's a million different ways to do the same thing in programming. If I write this versus my mentor writing this, we're going to get different code anyways. And your code is going to look different from mine, but that's not the point. The point is you give this a shot. Try this out to the best of your abilities. Now, if you get stuck, that's okay. If you get stuck, you can just simply resume the video and you can see exactly how I do it. So I'm going to fade out and fade in. And when I fade out, I want you to pause the video and try this. Good luck. Don't forget to have some fun with this. This is a really good use case of Python and APIs. You're going to need this in web development and all sorts of Pythonic stuff down the road. All right, let's go ahead and finish up this project, or I guess start the project and then we'll finish it up. So first things first, step number 1, we have to ask the user for input. So we're going to say the Pokemon is equal to input. Which Pokemon do you want to find? And then we're going to say Pokemon is equal to Pokemon.lower. And we know that we have to do .lower and reassign this because strings aren't mutable. We have to basically take that value of Pokemon, whatever the user writes, lower it, and then jam it back into another piece of memory called Pokemon. Just happens to be the same name here. So that's where mutability versus immutability comes in. Then we need to create a dynamic URL based on step 1. So that URL is going to be this URL right here. Copy. Throw that into a string, but it's not always going to be ditto. We need to change that. So let's change that to Pokemon. And let's make that an F string. So that's step 2. Step 3 is to fetch the data from the URL in step 2. So we can say req is equal to request.get the URL. And when we use request, we have to then import request. And that's actually plural. It's supposed to be requests. So we use requests.get, then the URL. And that's step 3. Step 4 is to convert the data to a dictionary. So then we can go down here and we can say that data is going to be whatever that request is, .json. We know it's coming in JSON form, so we can use .json on it. That's step 4. Step 5 is print out Pokemon data. So what do we want to print out? Let's print out the name that we found. So we can say print name is tab, and then whatever that name is going to be, data name. And if you're wondering where I got name from, data is now a dictionary, or at least in theory it's a dictionary, and name is coming from this little fella right there. Let's make this bigger. Right there. And let's maybe see what kind of abilities it has. So this is a list. We can see that it's a list, and it has a list of dictionaries in it. So let's go ahead and look at the abilities. So then we can say print abilities is going to be something we don't know yet. And let's just loop through those. For ability in data abilities, we can loop through this because we know that this is a list. And so this first ability is going to be limber, and the second ability is going to be imposter. So then we can say print ability, and this is a dictionary as well. So for every item in this list is going to be a dictionary. And then we've got one called ability, which is also a dictionary. Ability. And then we want that name. And let's go ahead and give this a shot. Let's see what happens when we run Python project. I don't even know if I have typos. I haven't even looked for typos. Which Pokemon do I want to find? Let's look for Ditto. It has Limber and Imposter in there. Cool. Okay, what other Pokemon do I actually know? Charizard. Its abilities are, and let's just move this up. I found Charizard. Its abilities are Blaze and Solar Power. Cool. If we wanted to get more information, we could actually get that URL and make a request there as well. And we could see what kind of ability it has. And it has different language settings. How cool is that? So we've got an English language. The first one is a German language. Flavor text entries. I don't even know what that is. That's beyond my knowledge of Pokemon. But anyways, we can, if we wanted to, grab that URL for more details about what that particular ability is actually going to do. So at this point, we're pretty much done. That's all we have to do. But what happens if you type in a Pokemon that doesn't exist? Oh no, we get a problem. And this is interesting because, where are we here? JSON decoder error, expected value line 1, column 1 carry. It's basically saying that JSON is not formatted properly. So what we can do here is we can wrap all of this in an if statement. If rec dot status code is equal to 200, that means we're getting a healthy status code. We can take all of this stuff, make that just a weensy bit tinier there, and outdent that. Otherwise, we can print Pokemon not found. And so now we're dealing with proper status codes here. Let's go ahead and try this again. Let's write a bunch of junk in there. It says Pokemon not found. And so it went off and went to wherever that is. That's not a Pokemon apparently. And so Pokemon wasn't found. Let's make sure that the status code is actually supposed to be 200 because sometimes it's 201. Who knows? Which Pokemon do I want to find? Bulbasaur. And look at that, that came back really fast. Name is Bulbasaur, abilities Overgrow and Chlorophyll. Cool, cool. Now that's really all there is to this project. Now, if you want to take this one step further, what you could do is you can make this always ask for more user input. So let's do that. Let's always ask for more user input. So what we're going to do here is we're going to wrap this in a loop. We're going to say while something is true, put all of that inside of this while loop. And it's always going to ask for a Pokemon. It's always going to make a request. And then when it's done, it's going to ask for another Pokemon. And that's literally all we have to do to make this a permanent or a proper Pokemon lookup tool. So let's go ahead and type python project.py. Let's look up Ditto. Okay, found Ditto. What about Charmeleon? Cool. What about one that doesn't exist? Does not exist. It says Pokemon not found. And it just keeps asking over and over again. And if I ever want to quit, I can always just do Control-C. And that gets me out of that while loop. So now we have a program that's going to constantly ask, which Pokemon do you want to find? This is a great way if you ever wanted to build an app down the road, like a Pokemon finding app or a Pokemon information app. This is exactly what you would do using Python. So that was my solution to this particular project. Your solution might be a little bit different. Your solution might be a little more simple or might be a little more complex. That's completely up to you. What I want you to do, if you haven't done this, is I want you to now try this out on your own. Don't reference my code, try it out on your own and just see how far you can get. Make your brain sweat. It's important to make your brain sweat. It's supposed to feel like a little bit of a struggle. And you know, if you get really, really stuck and you're just like, I just don't know what to do, either consult Google, because honestly, half of programming these days is just Googling stuff. And if your own research doesn't get you anywhere, then reference this code. And that's sort of going to move you away from being tutorial dependent like this video is. This video is very tutorial style. And it's going to sort of move you into the realm of figuring out how to solve your own problems, which is really, really, really important because coding is all about solving problems on your own. And you're not always going to have a teacher. So you need to be able to do this on your own. I hope this was enjoyable for you. I hope this was a fun little project using APIs and all this good stuff. We use a lot in here. We used a while loop. We used a package. We used input, lower, so mutability versus immutability, an F string. We used an API request. We checked the status code, so a conditional. We turned code into a dictionary from JSON. Then we printed with tabs using more F strings. Then we looped through every ability and got the ability name. Kind of cool. So that was nice and short. That was actually a pretty fun small project. Go ahead and try that out if you haven't. Last but not least, I would like to say thank you for taking this course with me, your teacher, Caleb Tallien. This has been a lot of fun. I'm very proud of how far you have gotten. Don't forget, writing code is all about practice. Just practice, practice, practice. Just writing code, solving more problems. Writing code, solving more problems. That's all it is. Over and over and over again. Once again, I know there's a lot of different Python courses out there, but you chose mine, and I really, really appreciate that. So thank you for giving me, of all people, a little bit of time from your life. I really appreciate that, and I hope you get to build some really cool things in Python in the future.